In this video, I'll present some of the basic elements of Java, including keywords, comments, variables, identifiers, and data types. Object-oriented programming is a methodology based on defining objects that contain properties and methods. A Java object is a stateful entity with associated behaviors, and it's meant to represent a physical or conceptual thing, such as a cat, a chair, or a list. The class is an entity blueprint to instantiate objects, and can be conceptually extended via subclasses to create further blueprints. An object's methods are the actions that can be performed on the instance and are defined by the class blueprint. Attributes are represented as variables within a class and instance variables of the instantiated object. These can represent data types such as int, long, float, boolean, enumerations or enums, and even other classes. Java has syntax rules that a program must follow. Every Java program requires a main method. This is the entry point into the program, where the Java runtime environment will start executing, and it has a particular syntax which I'll demonstrate in the video titled Programming Basic Java. All identifiers in Java are case sensitive. This applies to class names, attributes, methods, and any other identifier types and keywords. Classes in Java are named. The first letter of a class name is typically in uppercase. Subsequent words in a class name should be capitalized as well. For example, a class called myForm, the M in my and the F in form are capitalized. There are some conventions for Java basic syntax for file and method names as follows. Java class names should match the file name it's contained in, and it's done in a case-sensitive way. This is not a strict rule, but it's an expected convention you should follow. Method names within a class should begin with a lowercase letter. Any additional words should start with an uppercase letter. This is known as camel case. If you have a method name called getName, the G in get is lowercase, but the N in name would be uppercase. Java consists of several constructs that combine to form the basics of the Java programming language. Some of the constructs are as follows. Since Java 5.0, we've had enumerated types which can be used to provide a list of predefined values. These are useful to restrict the valid choices for a value that can be chosen. We have arrays that store multiple values of the same type and is stored on the heap. The values in the array can be accessed by an index value which begins counting from 0. The values can also be accessed using a for each loop. Keywords in Java are special reserved words that are part of the Java syntax. Because they are reserved words, class, method, and variable names cannot be a reserved word. Another construct is identifiers. Names used for methods, variables, and classes are called identifiers. Identifiers must start with either an alphabetic character, an underscore character, or the $sign character. And identifiers cannot be keywords, and they cannot begin with a number, although they can contain numbers. Java contains both access and non-access modifiers. Access modifiers indicate which classes have access to the class, method, or variable. Non-access modifiers include final, abstract, and strict FP. Final means the class cannot be inherited from. Abstract means the class cannot be instantiated into an object, and strict FP restricts floating point calculations. And variables in Java can be a local variable, a static class variable, or a non-static instance variable. And that concludes this presentation on Java basic elements. In this video, I'll demonstrate some of the basics of Java, including keywords, comments, variables, identifiers, and data types. In the video titled Java Basic Elements, I shared slides covering the basic elements. In this video, we'll see the basics firsthand, in Java code, and I'll point out some of the details we need to remember. So in the first line, in this main.java file, I declare the package. So I have the keyword package followed by com.example followed by a semicolon to end the line. So this is typical to see the package. It's required that it's the first thing we have in a file that belongs to a package. Then on line 3, I declare public class main. And the body of the main class is enclosed in braces. And since we've declared a class as public, it has to belong in a file of the same name. So main with capital M has to appear in main.java, with capital M in main. So the public class has to match the file name. Then on line 4, I have static string greeting equals, in double quotes, hello. So we have our static keyword, which is a modifier to say that this variable can be accessed without having to instantiate the class main first. So it's static, so it's always there, it always exists. Then I declare a function, private static void greet, and its parameter, in parentheses, string recipient. And then in the body of this function, I call system.out.println. I pass the variable greeting, which I get from the class, plus the string comma space, plus recipient, plus this string exclamation mark. So it will print a greeting using the greeting hello. Now the modifiers we have on this function are private and static. Private meaning it can't be accessed by anyone other than other methods inside of main, so it's private to main. Static is that it always exists. It doesn't require on instantiating the class main first. And then on line 9, we have a very special function, the main function, the entry point into our application, which is declared public static void main with string double square brackets, so open and close square brackets, followed by args. The standard declaration for the main function, which is called by the JVM when the program starts. Then I have a comment with /* write your code here, // and then on line 11 I have int _I. So we have a variable name that begins with an underscore. And this is okay because variables can begin with an underscore. On line 12 I have char $C, which is also okay because variables can begin with the $. But on line 13, I have byte followed by 8b. And this is bad because comments cannot begin with a number. So if we'd like to compile and run this code, we can't have line 13, so I have to comment that out. And then on line 14, I have double float. Now I'm trying to create a double, so double is the type, with the variable name of float. But float is also a reserved word, and it's also a data type. So it cannot be used as a variable name. So I'll have to comment out that as well. Then on line 16, I have string with a capital S, so it's the type of string, and then string as the variable name. But the string, the variable name, is all in lowercase. This is fine because reserved words are case sensitive as well. So string lowercase is okay for a variable name, but not recommended. It's not a great variable name because there is some confusion, but it's valid. And I set that equal to args indexed at 0. So it's going to take the first argument passed into main, save it in the variable string, and I'm going to call greet of string. On line 17, so I call the function and pass the variable. Now before I run this code, we need to pass an argument in. So I go to the Run menu, select Edit Configurations, and where it has Build and Run, so it has Java 8 SDK, com.example.main, and then the arguments. And in here I put world, so we pass the string world into this program. Now I can run the program by going to the Run menu and selecting Run Main or using Shift F10. And when I run the program, I get process finished with exit 0, and in the output I have hello, world, exclamation mark. Exactly the output that was specified in the greet function by system.out.println. So everything works fine. And that concludes this demonstration of programming basic Java. In this video, I'll describe the conventions that should be followed when writing Java programs in regards to formatting, naming, and programming practices. When writing code in Java, there are several style guides that can be used for writing your code. Considerations need to be made when selecting the style guide that works best for you. So have a look at Sun Java Style Guide, the original Sun Java Style Guide, as well as Google's and Twitter's. These are all publicly available. Creating consistent code is crucial when working in large teams or external teams. If you stray too far from the Java norms built up over the past quarter of a century, it just makes onboarding harder because you're not only teaching new developers the details of a code base, but you're also wrangling a non-standard style at the same time. The build tools you use may determine the style guide you use, since the tools such as Maven have plugins to auto-format code. As you write, tools like IntelliJ make formatting changes automatically, such as indentations, function blocks, and Java.comment blocks. Java file names must be the same as the public class name in the file so the JVM knows its entry point. If an interface is being defined, then the file name must match the name of the interface. Common file names and class names and interface names are usually nouns or noun phrases. When you're creating a class, the class is the object, and the methods are the verbs. Stick to camel casing for fields, methods, and variable names. Java source file names must have the .java for the source file, which get turned into .class for the compiled bytecode, and .jar for the Java archive files. There are typical conventions that are followed when organizing Java files. Source files should start with a comment block, the package name, and import statements, and then followed by any class or interface declarations. The initial comment block should contain information on the name of the class, the version, the date, and any copyright or license information if necessary. The statements for creating a package or importing a package, class, or interface should appear next. Classes and interfaces should be created with the class or interface statements appearing first, followed by the class, static variables, instance variables, constructors, and methods. When indenting and writing a line of code, there are some conventions that should be followed. Indentation should be set to 4 spaces, and a single line of code or comment should be less than 80 characters wide so that the line of code is visible on a screen of any common display size. So 80 is your minimum. When a line needs to be wrapped, certain considerations need to be made as well. The line break should be done before an operator and after a comma. The second line of code should align in terms of indentation with the previous line of code that had the line break. Java has several methods for adding comments to the code. Some of the methods for adding comments are as follows. We have block comments, which are surrounded by /* and */ at the end of the block, and are used to add descriptions before methods, algorithms, and data structures. A block line should be added before the block comment. Single line comments are indented at the same level as the code they precede. They are useful for adding information about a line of code, but don't overdo this style and use it sparingly. Trailing comments are comments that appear on the same line as the code and are usually short and typically use block comment style. End-of-line comments are similar to trailing comments. The main difference is the syntax used for end-of-line comments, which are the 2 / comments. Some comments follow the Java.doc convention and add special symbols to the comment blocks so that they can be processed by the Java.doc tool to generate documentation. Flow control statements in Java, such as loops and exception handling, follow specific syntax based on the type of statement. Across all of these statements, the code blocks belonging to the statement, called its body, are within braces. The for statement is a loop that starts with the for keyword, followed by the initialization, condition, and update or increment section, with each section separated by a semicolon and all enclosed in parentheses. The while statement is a loop that starts with the while keyword, with a single condition containing a Boolean condition on whether to continue looping. The do-while statement is a loop that begins with the do keyword, followed immediately by the loop body and braces, and just outside of the closing brace is the while keyword, with its condition enclosed in parentheses. The switch statement is a flow control statement, which starts with the switch keyword, followed by the condition in parentheses, followed by 0 or more case keywords and the default keyword. Code blocks after the case and default statements end with a break statement, unless you want the program to fall through to the next case or default section. One of the more common errors when writing switch statements is forgetting the break keyword to end a case. Then the try-catch statement is Java's flow control for exception handling, which starts with the try keyword, followed by a try block enclosed in braces, followed by a catch section, and optionally a finally section can be added if necessary. The catch keyword is followed by the exception class to be caught in parentheses. Statements in Java should follow specific conventions when being written based on the type of statement being written. Each line of code should contain a simple statement. Compound statements are enclosed in braces and should be indented one level past the brace. Braces should be used when they're part of a control statement, such as an if-then-else statement. Return statements to return control to the calling method of a function. does not need to enclose the return value in parentheses. If you use parentheses as part of a return, it should only be for clarity in the return value itself. Otherwise, parentheses should not be used. If-then-else statements have blocks with enclosing braces for each section. A block that contains only one line of code can leave out the braces, but some coding conventions recommend not leaving out the braces ever, even for one-line blocks. And that concludes this presentation on Java's style guide. In this video, I'll demonstrate the conventions that should be followed when writing Java programs with regards to formatting, naming conventions, programming practices, and Java doc style comments. So I have open in my IDE the event.java file I've created, and at the beginning of this file on line 1, I have package com.example. So the first line in any Java source file, other than a comment block, is always the package declaration, if there is one. Then I have public class event with a capital E on event to match the event.java file. So the name of the class, including its case. So a public class declaration must match the name of the file that it's contained in. Then on line 5, I have the beginning of a block comment, /*. In this case, I have /*, star on the next line, constructor, and then / to end the comment. Now, the reason there's a double asterisk is that when I do a block comment in IntelliJ, in this IDE, it will automatically populate it if I put /*, and enter. And it automatically creates the block comment, including the closing tags, and it puts me right where I need to be to type in the comment I want to type in. So in this case, constructor. And then I declare the constructor public event, followed by open and close parentheses, and then the body of the method. So when event gets created, this function will be called, and I could just call system.out.println event created. So I print the text. Then on line 12, I declare a method belonging to this class. I declare it public static void do something int important value. Now in this case, the function doesn't need to be static, but I've declared it that way, which means I can call it without creating an instance of an event. On line 13, I have system.out.println with the string important value. Then I break the line, or put a new line in, and then on line 14, I have plus followed by important value, and then I close the function call to println. When there's a line break like this, if it's a function call with a number of arguments separated by commas, I leave the comma on the preceding line before my new line. But if it's an operation with an operator like plus, I put the new line in first, and then the plus falls on the next line. So when you're breaking a statement up into multiple lines, the operations go on the new line and commas go on the preceding line. So that's the convention that we follow with Java. Then on line 16, in this code block, I put in a single line comment, and this comment is indented to line up with the code. So it's very important if you have single line comments that it matches the indentation of the code that it's with. So it matches the system.out.println indented under my if statement. So this system just prints we received a negative value. So if important value is negative, if it's less than 0, we print the string informing the user that that's the case. Then I have else if important value is greater than 20. And this just prints using system.out.println pick a smaller number. And then I have an else with a trailing comment, so /* important value is between 0 and 20 //. So this is a comment to say that if we get into this else block, the important value is between 0 and 20. The case that's not taken care of by our previous if and else if blocks. So in this block, I have a for loop. The first clause is int loop equals 0, semicolon, loop less than important value, semicolon, loop plus plus. And the body of this loop just does system.out.println of the loop variable. So this is the value that gets incremented on each step of the loop. Now I'll switch over to my main.java, and we can have a look at how this program gets executed and its entry point. So I begin with package com.example, so it's in the same package as event.java, so I don't need to import event.java explicitly. this import com.example.event is unnecessary. So I can use event because it's in the same package. So I just delete that line because it's not needed. And on line 4, I have public class main matching the file it's contained in, including its case. Then in the body of main, I have a comment, a block comment, but in the Java doc style. So main entry point, and then @param, so the @ symbol, args. So here I can put in a description of the args param. And I can put in args of 0 is expecting an integer. So that just documents the method. So I have the usual main function, public static void main, with string double brackets args as its parameter. The default comment that gets put in by IntelliJ is write your code here. And then I'd create an instance of event. So event e equals new event with parentheses. And then on line 15, e.doSomething. So I call the doSomething method with integer.parseInt of args of 0. Now I'd like to run the code, but before I run it, I'm going to go into run, edit configurations, and go to build and run. And the program arguments input, I'm going to put in a value. Let's put in -20. Press OK. And now I'll use Shift F10 to compile and run the code. And it shows in the output, event created. So the constructor prints its message, important value, -20. And we received a negative value, and the program finished with exit code 0. So everything worked. And I can go into run again, edit configurations, change the value from -20 to 100, press OK, and I can select run with Shift F10. And now I get the output of event created, important value is 100, and it says pick a smaller number. Okay, well, I'll go back into run, edit configurations, and this time in the input, I'm going to pass 10. Okay, Shift F10, and we get a different output. And if I go into the output and scroll up, I get event created, important value 10, and then on each line, I get the numbers from 0 to 9, and then it exits that loop that it got into, and the program exits. It finishes with exit code 0 successfully. And that concludes this demonstration of programming conventions in Java. In this video, I'll go through the majority of reserved words in Java. These are keywords or programming-related terms that cannot be used for class names, method names, nor variable names. They can't be used outside of their original purpose. Compilers or IDEs should catch inappropriate uses of these, but sometimes invalid use results in valid syntax, and you can avoid some extra debugging by avoiding using them incorrectly in the first place. So let's start off with some keywords in Java that are special reserved words that are part of the Java syntax. We have abstract, which is a non-access modifier used by classes and methods to indicate that it has no body and no concrete implementation. Assert is used to stop execution if the predicate evaluates to false. It's a very useful debugging method. Boolean is a basic data type to represent true or false. Break is used to jump out of a loop or switch statement. Byte is a data type that stores an 8-bit data value. Case is used with the switch statement to designate a block of code. Catch is used to catch exceptions generated by try statements. Char is a data type that stores a single character. And class is used by Java to define a new class. Then we have continue, used to move to the next iteration of a loop. Const is a common C++ keyword for defining a constant value, but it's not used in Java, but it is still reserved. In Java, we use the final keyword to define a constant value instead. Default is used in a switch statement and specifies a block of code that's executed by default. Do is used with the while keyword to perform a do-while loop. Double is a floating point data type. Else is used an if-then-else conditional block. Enum is used to declare enumerated type. Exports is used to export a module within a package. And extends is used to indicate that a class inherits from another class. Final is a non-access modifier that indicates a class, method, or variable that cannot be overridden or modified. Finally is used with a try-catch block to indicate a block of code that will run even if no exception occurs. Float is a 32-bit floating point number data type. For is for creating a for loop. Goto is not used in Java and it has no function, but it's still a reserved word. If is used to create a conditional statement. Implements is used when implementing an interface. Import is used when importing a class, interface, or package. And instance of is used to determine if an object is an instance of a particular interface or class. Int is a data type used to store a signed integer. Interface is like an abstract class and can only contain abstract methods. Long is a data type used to store a 64-bit signed integer. Module adds a higher level of aggregation above packages and introduced in Java 9. Native specifies that a method is implemented in another language. New is a keyword used to instantiate new objects. Package is used to create a package that groups together classes. Private is an access modifier to keep a method or variable private within a given class. Protected is an access modifier that indicates an attribute or method or constructor is accessible in the class, the package, and by subclasses. Public is another access modifier indicating a class, constructor, variable, or method is accessible by other classes. Requires indicates that a library is needed inside a module, and this was introduced in Java 9. Return is used to exit from a method. Short is a data type used to store 16-bit integers. Static is used to indicate that a variable or method can be used without instantiating a class. Strict FP is used to restrict the rounding and precision of a floating point calculation. Super is used to reference and execute methods in a parent class. Switch is a flow control statement used to compare values and execute code based on those values. Synchronized is a non-access modifier that indicates a method can only be accessed by a single thread. This is a reference to the current object that the method or constructor that it's contained in. Throw is used to throw an exception and is usually used with custom exceptions. Throws is used to indicate a method that can throw a specific exception. Transient is a non-access modifier that indicates that a data member will not be serialized. Try is used to indicate a block of code that should be tested for exceptions. A catch or finally statement must occur after a try statement. Var is used to declare a variable. Void indicates that a method has no return value. Volatile is used to indicate that a variable may change asynchronously. And while is used to start a while loop. And that concludes this presentation on Java reserved words. In this video, I'll demonstrate this keyword and how you can interact with variables of the same name based on their scope. So I'm starting off in my main.java file with package com.example, and then I declare my public class main, and in the body of main, I have the entry point, the function main, public static void main with string double brackets args, and inside the body of this method, I'm using the class greet to create the object g equals new greet. And then I call the method g.sayGreeting with hi, comma, Steve. And one of the nice things about IntelliJ is that it gives me these hints. So it shows greeting, colon, hi, recipient, colon, Steve. So it shows which parameters are being set by these arguments. And if I don't like that view, I can always disable hints and hit OK. And it removes those hints provided by the IDE. Now I'll switch over to greet.java. And here, this is part of the same package, com.example. And this is a public class greet. It contains a private static string greeting, which is equal to the string hello. And I declare my method on line 6, public void sayGreeting. And my parameters are defined string greeting, comma, string recipient. And then in the body of this method, I have string message. So I declare a string message. Then I test the greeting parameter. There's two greetings. There's one that's the parameter defined as part of the method. So we receive the argument for this variable. And there's greeting the static member variable as part of the class greet. So on line 8, I have if greeting.isEmpty. So this greeting is actually the parameter. So in the precedence order, when there's two variables of the same name, that are in the scope, the local one always gets precedence. So the parameter I've defined here, greeting, is the one that's referenced if I just type greeting. If I want the one that belongs to the class that's defined outside of the method, I have to supply the this keyword. So if the string is empty, I set message equal to this.greeting. So it falls back on the class's greeting variable plus the string comma space plus the variable recipient plus the string with the exclamation mark. Else means that greeting is not empty. I have message equals greeting, so it will take the local greeting. Now, the nice thing about the IDE, as soon as I highlight the variable, so if I highlight this.greeting, nothing else highlights, but if I highlight the greeting variable, it highlights the references to the local variable. So greeting plus comma space plus recipient plus exclamation mark. And then outside of the if-else block, I call system.out.println of message. So it's going to print the greeting. Now I'll use Shift F10 to build and run the code, and I get the greeting, "Hi, Steve." Now I'll switch back to my main.java file and change the g.say greeting on line 6 from hi, Steve to empty string, world. I'll save this and run the program again, which will recompile it with the changes, and I get the result, hello, world, exclamation mark. So in this case, it used the this.greeting. So we got into the first branch of the if block because the greeting passed as an argument into say greeting was empty, and it used the default one that belonged to the class greet. And that concludes this demonstration of the Java this keyword. In this video, I'll describe the different types of Java comments and Java doc-style commenting. Java has several different methods for commenting code. Some of the methods for adding comments are as follows. The first is block comments, added before the code they describe. Single-line comments, which are in line just before the line of code that it describes and indented to the same level. Trailing comments are short comments on the same line of code. End-of-line comments are similar to trailing comments, but commented with double forward slashes by convention. And Java doc comments are specially formatted so they can be processed and used to generate separate HTML documentation. We'll have a look at each one of these in turn over the next few slides. The first example is Java block comments. In this example, I have a single line block comment with /*, then a new line, then a star and a space, followed by the comment, "This is a block comment," then a new line, and then /* to end the comment block. Now, even though this could be put onto a single line, it leaves it open to add more lines, and it emphasizes the comment. It makes it stand out. The next example, we have the /*, then with the star leading on every line. We have 5 lines with a leading star, including an empty line, but it still has a star. So in this comment block, it makes it clear that the entire section belongs to the same comment. So we have, this is a block comment with special formatting, then an empty line, then class, attributes, and methods. If we have a block comment that describes a method, we show the parameters passed and we describe them, and the return type and what it's returning. Java also has single line comments, and these are indented at the same level as the code that they precede. They use the /* and */ syntax, and in this example, a single line comment is added before the if statement. So it says, check if the file is loaded, then there's if is load, and then we have the body of the if statement. And inside the if statement, the comments are indented. It is a good practice, and it's conventional to leave a blank line before every single line comment. Trailing comments appear on the same line as the code, and they're usually not long. In this example, I have 4 trailing comments, which highlight the syntax of a trailing comment. So I have Boolean is load, semicolon, and then I have my /* declare the isLoad variable, / isLoad equals load file with file name as its argument. And then we have the comment saying attempt to load the file. And then if load, return true, and the comment says file is loaded, else return false, file is not loaded. So trailing comments can be helpful, although in this example I'm trying to be obvious displaying how trailing comments are formatted, but this is a bit too verbose and obvious. A trailing comment can be helpful, but it can also add clutter, so use it sparingly. End-of-line comments are similar to trailing comments. The syntax is a little different, and double slashes are typically used, and it's often used to remove code or comment out code that should be unused or changed. So inside of the else block, we have / file is not loaded, / return false. So this line of code was commented out, and the explanation as to why it was commented out. So it looks very much like the trailing comments with a different syntax. And then we have the Java.doc comments. And these add specially formatted block comments to be used by a Java.doc tool or processor. It contains common tags that populate the HTML documentation. So some of the common tags are @author, used to add the name of the author of the code, @version for the version of the code, @since specifies the date when the code, the method, or class was added, @deprecated can be added to indicate this class or method might no longer be used or is going to go out of use at some point in the future. We can also add an @return to describe the return value of a function, and the @docroot adds a relative path to the generated comments root directory. And that concludes this presentation on Java comments. In this video, I'll demonstrate the different types of Java comments and Java.doc style comments. So in this main.java file, I begin by declaring the package com.example. And then just before my class main is defined, the comment block I have for class main is in the doc style. So this style of comment begins with /**. So there's a double star. And this is a doc comment or Java.doc comment. So the generic term is doc comment, but more often than not, we're using the Java.doc tool to generate documentation based on these comments. A block comment in Java is a very similar style, but the convention is /**. And the nice thing about IntelliJ, it highlights the block comments in gray and the doc style comments in green. So the only difference between a Java.doc style comment and a block comment is how it's opened. So /* or /*. So this first doc comment is describing our main class. So inside of the comment, I have asterisk, main class for this demonstration, and then each line has its own asterisk inside of this comment. We have @author, Steve, @version 1.0, @since with the date 2020-12-20, so year, month, and day, and then I close it. And then I declare public class main, and inside the body of the main, I have a single method, main. But before the main function is declared, I have another Java.doc comment. So /**, and then asterisk Java in parentheses, so Java.doc comment for main. So whether you call it doc comment or Java.doc comment, they're used interchangeably. Then an empty asterisk, then asterisk, and then @param, describing the parameter for our function main. So the parameter name is args, and the description of it goes after. So @param, the name of the argument, followed by the description. And then I declare public static void main, string double brackets args, and in the body of the method, I have an empty line, and then /* single line comment //. So if you have a single line comment, always leave a space above it, and then have the code begin immediately after it. So I have string str equals args of index 0, and then I have a trailing comment /* trailing comment //. Now if we refer to something as a trailing comment, it's usually surrounded in /*//. So it's this style of comment. Then system.out.println of str, and then I have double slash to comment out system.out.println end, semicolon, // end of line comment. So the double slash is called an end of line comment. It's used to comment out lines completely or to be used interchangeably with trailing comments. So if I remove the beginning double slash, the end of line comment becomes a trailing comment. So now I'll go to the run menu, select edit configurations, and the argument I'm going to put in is the string hello. Select OK. Now Shift F10 to run the code. And I get the result, hello, and then end, which was printed at the very last line of our main method. Now we've created these Java doc style comments, but how do we generate documentation from them? Well, if we go to the Tools menu and select Generate Java Doc, it'll give some options about where to export the HTML files generated by these comments by the Java Doc tool. So I'm selecting the scope of it to be just the file, this main.java file. I can have it document at different levels from private, package, protected, or public. So there are a number of parameters we can set for how Java Doc is being used. So output directory /home/Steve/documents/comments demo. So I'm going to create this folder, press OK, and it creates the documentation and brings me right to the Java Doc. And it gives me package com.example, class summary, and there's a link to the main class. And it gives me all of the information, everything generated from the source. So inside it has public class main, extends java.lang.object. And then the comment I put in, main class for this demonstration, since 2020-12-20, version 1.0, author Steve. So this all appeared in the comment blocks inside of my code. And if I scroll down, it shows all of the generic details to do with this class, including its methods. And in this case, I have a main method, and it shows my description, Java, in parentheses, doc, comment for main. And if I select the method, it'll go down in the page and show me the method detail. And it shows the parameters, args, tag description goes here. Verbatim of what I put in the source code inside of the doc comments. And that concludes this demonstration of comment styles in Java. In this video, I'll describe Java packages and how to import them into Java applications. So Java packages are used to group together related classes and are useful for avoiding naming conflicts. They're used in Java's built-in packages for common functions such as performing I/O commands, math methods, language methods, native interface methods, etc. We also have user-defined packages. These are user-created by using the package keyword at the beginning of your class file to state that the class or interface contained within belongs to it. The package statement must be the first statement in the Java class file. I'll go over some of the rules and guidelines and some examples of common Java packages. There are certain rules that you need to follow when using packages and Java class files. The first rule is that the package statement must be the first statement in the Java source file. Rule 2 is that a single source file can only have one public class. Rule 3 is two source files with the same name cannot be in the same package. Rule 4, if a source file does not have a package name, then it is in the default package. And Rule 5, if a class accesses another class and both are in the same package, then they don't require specifying a package name to import it. There are many built-in packages available in Java. Here are some of the more common ones. We have the java.applet package, containing classes for creating applets. Java.awt or AUT contains creating graphical user interfaces with buttons and menu items. Java.io package contains classes for supporting input-output operations, such as printing to the screen, a printer, or file storage system. Java.lang packages contain the classes that support the Java language, such as primitive data types, string and StringBuilder classes, and the system class. Java.math contains methods for arbitrary precision floating point and integer arithmetic. Java.net contains classes for network operations, and Java.util contains classes for linked lists, dictionaries, date, and time operations, and other utilities. User-defined packages can be created by using the package keyword at the start of the file. So we specify the package keyword followed by the package name, and then the class and the typical Java definitions within. In this case, I've created a class called sample package class, and because of the way it's defined, this will belong to the package sample package. In this case, this class has no modifier specified, so we just have class sample package class without specifying that it's public, which makes it a private package. There are several advantages of using Java packages. Java packages are useful for grouping classes and interfaces for maintenance. Java packages help eliminate naming conflicts for classes that have the same name, and it provides access protection for classes and interfaces, and along with access modifiers can add additional levels of protection. In general, it makes it easier to share and reuse code. And that concludes this presentation on Java. In this video, I'll demonstrate Java packages and how to import them into a Java application. So I have open in my IntelliJ IDEA the file document.java. And the first line, it declares this to be package com.demo. So inside of the com.demo package, we have the file document.java with its class called document. Looking at the project browser, inside of the source folder src, we have com, and under com we have demo and example. So these are the two packages that are part of this packages demo project. And then inside of demo, I have document, and inside of example, I have main. I'll describe the main source file in a moment, but I'll do document first, and then I'll switch over to main, describe that, and then run the code. So inside of document, I declared its package, and then on line 3, I import java.util.arrays, import java.util.collections, and import java.util.list. So these are three classes from the java.util package that I'd like to use in my code. So on line 7, I have public class document, and inside of document, I declare a single public method, public void do something, and it takes string sentence as its parameter. And then inside of this, I have string double brackets words, so I'm creating an array of strings called words, and I set that equal to sentence.split with the argument, the string double backslash s. So this is going to split the string sentence on spaces. And it's going to create an array of words for each word in the sentence. Then on line 11, I create a list parameterized by string. So list with string inside of angle brackets, list equals, so lowercase list equals arrays dot as list words. This takes the array of words and converts it into a Java list. And now I use the collections class with its static method sort, and I pass in the list, and it's going to create the sorted list. And it's going to sort the words in alphabetical or lexicographical order. And then on line 13, I call system.out.println with the string sorted words plus list. So this is going to take the list and output the contents of it so we can see how it performed. Now I'll switch over to my main class inside of main.java, which is inside the com.example package, which I declare on line 1. So I have package com.example. And now since the document class is in a different package, I can't reference it directly without importing it first. So I need an import of com.demo.document. The only time I don't need this import is if Java gives it to me by default, such as the Java.lang package, or the class belongs to the same package. So if document was in com.example, I wouldn't need this import. But since it's in a different package, I do need this. And this is very important to remember. Then I have public class main, and inside of main, I have the usual main entry point, public static void main, string double brackets args, and inside of this, I create a document. So document D equals new document with the double parentheses to create the object. And then I call d.doSomething with the sentence, thank you for watching this video. So it's a string with spaces between each word, and those should get split, sorted, and displayed for us. So now I'll select run main, or I could do Shift F10, and I get the result. The string sorted words, the output of the list, gives me for thank this video watching you, the words from the sentence put into a sorted order. And that concludes this demonstration of programming with Java packages. In this video, I'll describe the features and components of the Java.lang package, including the primitive wrappers, string and string builder class, the math class, and the system class. The Java.lang packages contain classes that support the Java language and its essential features. Wrapper classes are available for each primitive Java type. This includes Boolean, byte, short, character, integer, float, long, double, and void. The string and StringBuilder class are both used to store and manipulate string data. However, they are used in different situations depending on the performance characteristics needed. The math class contains static mathematical functions such as trigonometry, rounding, logarithmic, exponentiation, and the system class provides access to the JVM and its system. Java wrapper classes provide functionality to primitive data types. The automatic conversion of primitive data types into their corresponding wrapper classes is known as auto-boxing. For example, from byte, lowercase byte, to byte, the uppercase. So the primitive type has the lowercase, char, int, long, float, boolean, double, and short, and the wrapper class has the same thing but with an uppercase leading character. The automatic conversion of a wrapper type to its corresponding primitive type is known as unboxing. So we have autoboxing and unboxing as the reverse processes of one another. The string and StringBuilder class are both used to store and manipulate string data. String is automatically created with double quotes. They're pooled to save memory. They're immutable, so once they're created, they can't change. They can only be recreated or copied. Strings can be concatenated using the plus operator, but because of the immutability, this is an expensive operation. There are many methods for searching strings and manipulating strings, but in some cases, we should be using StringBuilder. It's mutable so that it can be changed quickly and resized, and operations are much quicker. There are limited methods such as append, insert, delete, and replace. A string representation of the object's content can be obtained using the toString method. String buffers achieve thread safety by being synchronized across threads in a multi-threaded application, and StringBuilder is used for better performance when many operations are required to be performed on the string. The math class contains static mathematical functions such as the common trig functions like sine, cos, tangent, etc., rounding using round, floor, ceil, and rint, logarithmic functions such as the base log function or the log to base 10 function, the log10, and exponentiation and root functions like square root, cubed root, cbrt, pow for power, and exp for exponent, and other utility functions such as absolute, so abs, minimum, maximum, random, hypotenuse, 2 degrees, and 2 radians for conversions from degrees to radian measures. Another construct is identifiers. Names used for methods, variables, and classes are called identifiers. Identifiers must start with either an alphabetic character, an underscore character, or the $ character. And identifiers cannot be keywords, and they cannot begin with a number, although they can contain numbers. Java contains both access and non-access modifiers. Access modifiers indicate which classes have access to the class, method, or variable. Non-access modifiers include final, abstract, and strict FP. Final means the class cannot be inherited from. Abstract means the class cannot be instantiated into an object, and strict FP restricts floating point calculations. And variables in Java can be a local variable, a static class variable, or a non-static instance variable. And that concludes this presentation on Java basic elements. In this video, I'll demonstrate how to use some Java.lang package classes, including numeric classes, math functions, and the system class. The nice thing about the Java.lang package is that we don't have to write import statements for its classes. We get them by default. So at the beginning of this program, in my main.java on line 1, I have package com.example. So as in many of these demonstrations, I leave them in this com.example package, with the package statement always coming on the first line. Then on line 3, I have public class main, and in the body of main, I have a typical main function for our entry point. So on line 5, I have public static void main, and in parentheses, string, double brackets, args. And then inside of this function, I declare double D equals double with an uppercase D. So we're referencing the class double from the Java.lang package. Dot parse double. And I pass args at index 0. So it's going to take the first argument, try and parse it as a double, and store it in our variable D. Now the parse double function returns a primitive double, so double with a lowercase d. On line 7, I declare a double with an uppercase d, so the actual helper class associated with the double primitive type. So double called myDouble equals d. Now I can do a direct assignment like this, and Java applies an automatic conversion, and we call this autoboxing. And to test the result, I do system.out.println with the string input plus d. So it's going to print the value that's past the numeric value. And obviously, if we pass something other than a numeric value, there'll be a number format exception when it tries to parse it. Now I have a comment saying double with an uppercase d, so the double class, with a little arrow to lowercase double. So from the helper class or the wrapper class to the primitive type is called unboxing. And I do a system.out.println with the string floor because I'm going to use the math.floor function. So I have a plus, math.floor, and I pass myDouble to it. And I do the same thing for sealing, where I output the contents of math.ceil, C-E-I-L. And I do it on myDouble. So it's going to take the floor of it. So it'll be the nearest integer below myDouble and the nearest integer above it. Now I'm going to get the current timestamp in milliseconds and nanoseconds using the system object. So system is a special object from the Java.lang package that provides some system level functions. On line 15, I have long time milli, M-I-L-L-I, equals system.currentTime millis. So this will get the current time in milliseconds. This returns the time since the epoch from January 1st, 1970. So if we need a clock time in milliseconds, we use current time millis. It's not the most precise, however, it is accurate to the clock, and it's thread safe, so you'll get the same time between threads. On line 16, I have long time nano, so I'm declaring time nano equal to system.nanotime. So the nanotime method is not based on a particular clock date or time. It's not based on the usual epoch. So you can't use it to compute a time, but it's high resolution for computing more precise time differences. So you take a timestamp at one point in your code, and then you call nanotime again somewhere else, and you compute the difference. But in this case, nanotime is not thread safe, so you can't compare time differences between different threads, only in the same thread. And then I print the contents of each. So on line 18, I have system.out.println of current time in millis plus time milli, and then system.out.println of current time in nanoseconds plus time nano. Now I'm going to use system to get an environment variable. So the environment variable in this case is desktop_session, which will return the name of the desktop environment. So I print system.out.println of system.getEnv of desktop_session in quotes. So it's a string that I pass to it. So now that I've gone through the code, I'm going to go to the run menu, edit configurations, where we have build and run. The parameter I'm going to pass, let's pick another number. Let's say 5.55, and I'll hit OK. And now I can do a Shift F10 to run the code. So it's going to build and run and show me the result in the run window. So I have input is 5.55. The floor of this is 5.0, ceiling 6.0. I have the current time in milliseconds, which is a very long number, which is over 1.6 trillion. So it's quite a long number. And then the current time in nanoseconds, which is over 25 trillion nanoseconds. So it's a much higher resolution, but the two numbers aren't related in any way. And the nanosecond timestamp is not based on anything to do with the clock, so it doesn't resemble the time in milliseconds at all. And then finally, the desktop session in this case is mate. Even though it looks like mate, it's pronounced mate, and that's the name of the desktop environment I'm running in this version of Linux. And that concludes this demonstration of programming with the Java.lang package. So in this course, we've examined the Java Programming Basic and the Java Programming Style Guide, We did this by exploring Java basic elements and programming with them, Java style guide and programming in Java best practices, reserved words and the this keyword, as well as Java and Java doc comments and their use with programming, Java packages and programming with them, Java.lang package and its use in programming. And in our next course, we'll move on to explore the available mathematical, conditional, relational, bitwise, and unary operators in Java.
Operators in Java allow us to manipulate and control our data in various ways in order to accomplish our goals when we're doing our code. The first type of operator that we're going to talk about in Java is the arithmetic operator. And these operators allow us to perform mathematical functions on our data. So, for example, when we're dealing with primitive data types like ints or longs or doubles, then oftentimes we'll want to do some sort of arithmetic operation on them. So these are things like addition, subtraction, multiplication, division, and modulo. And all of these operators are available to us. We can see them in the bubble. The percent sign represents modulo, the minus sign represents subtraction, the plus sign represents addition, the forward slash represents division, and the asterisk represents multiplication. We also have assignment operators, and this allows us to store data into memory by assigning values to variables. So one assignment operator, which we see in the bubble on the right, is the equals sign, and the example shown is a equals 3, and this will store the value 3 into a. So that's what we use when we're using assignment operators. Something that often goes hand in hand with operators and our use of operators in Java is typecasting. Typecasting is when we convert a piece of data from one type to another. So in Java, everything has a type. For example, when we define something as an int, that means an integer, and it means that it takes up a certain amount of space in memory. Similarly, when we define something as a float, then that's defined as a different type than an int, and it consumes more space in memory than an integer does. We have two different types of typecasting. The first is implicit conversion, and this is something that Java will just do behind the scenes that you don't really have any control over and you don't need to interact with. And this comes up when we're dealing with arithmetic operations that have a mismatch of type. So for example, if we're trying to perform an arithmetic operation on a float and an integer, Java will implicitly convert the int into a float because the float is a much larger number, so the int is guaranteed to be able to fit into the memory space of a float. So Java will make sure that they both convert into floats and then perform the operation on two floats rather than a float and an int. Alternatively, we have explicit conversion, and this is done by putting a type in parentheses before the name of the variable that you're trying to convert. So in the example shown in the bubble, we could explicitly convert a variable to an int type by putting the word int between parentheses and placing that in front of the name of our variable. And then Java will convert it for us in that case. So as we mentioned before, addition is by the plus sign, subtraction is by the minus sign, multiplication is by the asterisk, and division is done by the forward slash. All of these operators work by having an operand on either side of them and then giving a result. So for example, you could have int a equals 5 plus 5, and then a would be equal to 10. And it's the same for subtraction, multiplication, and division. You put an operand on either side with the operator between the two, and Java will carry out the operation as you specify. The modulo or modulus remainder operator is something that might be a little bit less familiar. It doesn't come up a lot in daily life, but it does come up a lot in coding. What this does is it gives us the remainder after a division operation is carried out. So if you were to divide 7 divided by 3, that would be a modulo of 1 because 3 goes into 7 2 times and has a remainder of 1 left over. And there are quite a few use cases for the modulo remainder operator. One of the major ones is in cryptography. If you get into cryptography at all, you'll end up using this modulo operator a lot. Two other arithmetic operators that we have are almost like shortcuts, and these are the increment and decrement operators. So plus plus and minus minus. And what these will do is they will either add 1 or subtract 1 from a value respectively. So let's go back to our integer a, which is currently equal to 10. If I were to say a plus plus, then that would increment my a value by 1, and then a would be equal to 11. And then if I were to say a minus minus, that would decrement my a value by 1, bringing it back to 10. So that's how the increment and decrement operators work. And it's important to note a difference here between the increment and decrement operators and the other arithmetic operators I was talking about before. So with addition, subtraction, multiplication, division, and modulus, we have to have two operands on either side of the operator. With the increment and decrement, we only have a single operand. Notice I only used a plus plus and a minus minus. We didn't have to have something on either side of the plus plus or the minus minus. So increment and decrement are single operand operators. Now let's look a little closer at our assignment operators and how we can potentially combine them with our arithmetic operators. So the first assignment operator is the one that we've already touched on. This is your basic simple assignment, the a equals 3. And we do that with a single equals sign. And that will assign the value on the right side of the operator to the storage location on the left side of the operator, in this case the variable a. But we can combine our assignment operators with arithmetic operators. So we could have a case where we do first an add and then an assign. So what we could do is have something like a plus equals 3. So to see how that works, let's give a an initial value. Let's assume that a is equal to 5. If we then have a plus equals 3, that's equivalent to a equals a plus 3. So a will now be equal to 8 after we do that add and assignment operator. And we do that by having the plus sign followed by an equal sign. Similarly, we can have a subtract and assignment operator, which is done with a minus and an equal sign. So if we had a, once again equaling 5, and we did a minus equals 3, that's equivalent to saying a equals a minus 3. And after the operation, a will be equal to 2. We can do the same thing with multiplication. We can do multiply and assignment with asterisk equals. So saying b asterisk equals 5 is equivalent to saying b equals b times 5. Divide and assignment with a forward slash followed by an equal sign. So b forward slash equals 5 is equivalent to saying b equals b divided by 5. And modulus and assignment with a percent sign followed by an equal sign. So b percent equals 5 is the same as saying b equals b modulo 5. In this video, we're going to demonstrate the use of various arithmetic and assignment operators in Java. So to get started, we're going to create ourselves a Java class to make use of these operators within. This one will be called operators.java. Now we have our class. We'll make a main method to demonstrate some of these operators within. And now we can look at the operators. In Java, we have the following arithmetic operators. We have the plus sign for addition, the minus sign for subtraction, an asterisk for multiplication, a forward slash for division, and a percent symbol for modulo. We also have increment and decrement operators, but we'll talk about those in a future video. So let's take a look at each of these operators in turn and see how they work. If I want to add two numbers together, I can have int a equals 5 plus 7. And in this case, a will be equal to 12. I don't have to use straight values. I could also use variables within my operators. So I could have int b equals a plus 2. And then b will be equal to 14. And I could also just use variables. I can have int c equals a plus b. And then c will be equal to 26. So that's how we can use the addition operator. The rules of using values or variables are the same for every operator. We can use all values, like I did with my a with 5 plus 7. We can use mixed, like I did with b with a plus 2, or we can use all variables like I did with c, a plus b. And that's true for the subtraction, multiplication, division, and modulo. So if we wanted to do subtraction, I could have int d equals 8 minus 4, and d will be equal to 4. I could have int e equals 12 minus d, and then in that case, e will be equal to 8. And then I could have int f equals e minus d, and in that case, f will be equal to 4. So now we can see some of these in action. So I'm going to make a print statement for each of these, just to print out the variable values. We can see it in the console. And then I will compile and run this. And in order, the values are as we expect. A is 12, B is 14, C is 26, D is 4, E is 8, and F is 4. So that's how we can use addition and subtraction. Now, let's look at multiplication and division. They follow the same rules, so we can have int a equals 5 times 5. And in this case, a will be equal to 25. We could have int b equals a times 2, and b will be equal to 50. And we could have int c equals a times b, and c will be equal to 1,250. If we wanted to divide two numbers, I could have int d equals 10 divided by 5. And in this case, d will be equal to 2. I could use int e equals 6 divided by d. And in this case, e will be equal to 3. And then I could have int f equals e divided by d. Now we run into something interesting. What is f going to be equal to? Because e is equal to 3 and d is equal to 2. 2 doesn't divide into 3 evenly, it leaves a remainder. Now what Java will do, because we're dealing with integer types, it will just leave off the remainder. It just ignores it as if it isn't there. So 2 divides into 3 one time evenly, and then Java doesn't care about the rest. So in this case, f is actually going to be equal to 1. And we can see that in action by printing this to the command line. And here in the console, I've now run it, so we can see that in order, A is equal to 25, B is equal to 50, C is equal to 1,250, D is equal to 2, E is equal to 3, and F is equal to 1, like we suspected that it would be. Now, what if I wanted to get the full value of F, not just the value with the remainder trimmed? Well, in that case, I could use different value types, such as double, to store the result into F, and then I need to cast one of my integers to also be a double. And what Java will do now is convert implicitly my equation to have all the values to be the same as the largest value type, which in this case is a double. And now, f will not be equal to 1. We can actually see by compiling and running what f will be equal to. And now, if we look at the bottom of our list, f is equal to 1.5. We've done the full division here because we've used a value type that matches. This same concept applies with all of the other operators as well, but it most frequently becomes a problem with division, because that's most of the time where you're going to be dealing with these mixed types and looking for remainders. The last arithmetic operator that we're going to look at is modulo, which is the percent sign. What modulo does is it gives you the remainder of a division. So we can display that with int a equals 6 modulo 2. And in this case, a is going to be equal to 0 because 2 divides into 6 evenly and leaves no remainder. We could also have int b equals 15 modulo 4. And in this case, b is going to be equal to 3 because 4 goes into 15 3 times evenly to get a value of 12 and then leaves a remainder of 3 to get to 15. And to see that on the command line, let's do 2 more print statements. And the values are as we expect. A is equal to 0 and b is equal to 3. Now we've seen the arithmetic operators in Java. Let's look at some assignment operators in Java. I'm going to show most of the assignment operators, but I'm going to be leaving a couple out because they're a little more advanced and a little more niche, and they deal with bitwise operations. But the assignment operators that I'm going to show are the majority of them and the most common ones that you'll run into. The first operator you might already be very familiar with, and that is the equals sign. And the equals sign will assign the value on the right side of it to the variable on the left side. So in this case, x will now have the value of 5. And we'll set up a print system so that we can see these all at the end of the demonstration. So we'll print out the value of x at this point in time. The next assignment operator is the plus equals sign. And what this will tell Java is to add 3 to the value of x. So this is the same as saying x equals x plus 3. And in this case, x is going now to be equal to 8. So we'll copy this line and we'll paste it again to see the value of x at that point in time. On the opposite side of that, we have the minus equals. So I could write x minus equals 1. And this is the same as saying x equals x minus 1. And x will now be equal to 7. We have x star equals 2. And this is equivalent to saying x equals x times 2. And x will now be equal to 14. We have x slash equals 2. And this is the same as saying x equals x divided by 2. And x will once again be equal to 7. And then finally, we have x percent equals 4. And this is the same as saying x equals x modulo 4. And x will be equal to 3. Now we can compile this once again. And run it again. And we can see that in the console at the bottom of my screen, the values are as we expect. X starts out with 5, and then x plus equals 3 to become 8, x minus equals 1 to become 7, x multiplication equals 2 to become 14, x divides equals 2 to become 7, and then x modulo equals 4 to become 3. So these are the arithmetic and assignment operators and how they work in Java. Unary operators in Java are operators that only take a single operand. An example of these is the prefix and postfix operators, which are the increment and decrement operators, plus plus and minus minus. They only take a single operand. We also have certain arithmetic operators that we'll look at that only take a single operand. And then we have bitwise and logical operators that also only work on a single operand. So let's look deeper into each of these examples and see how they work. The first unary operators that we'll talk about are the prefix and postfix operators. So these are both dealing with the increment and decrement operator, but the difference comes in their placement either before or after the variable that you're trying to increment or decrement. So in a prefix operator, we put our increment or decrement operator before the variable. We have it as plus plus a or minus minus a if a is our variable. And in the postfix operator, we put our increment and decrement after our variable. So if a is our variable, once again, we'd have a plus plus and a minus minus for postfix. Both of these operations end up doing the same thing. They'll either increment or decrement your variable by 1, but the difference is in how they do it. With a prefix, the variable is first incremented or decremented, and then the result is stored. So what that means is, let's say a is equal to 10, and you had b equals plus plus a. You're using the prefix increment. Then a will first be incremented to 11 and then stored into b as 11. Now, if you were using the postfix increment, a plus plus, and you had that same statement, b equals a plus plus, the difference with postfix is that first, the value of your variable is stored, and then the operation is carried out. So in the case of b equals a plus plus with a equaling 10, first off, 10 would be assigned to b, and then the increment would happen after that. So you would have b equal to 10 and a equal to 11. So the difference comes in when the increment or decrement operation happens with prefix and postfix. The second type of unary operators that we have in Java are arithmetic operators. And we have a little bit of overlap here because increment and decrement also fall into this category, and they're signified with the plus plus and minus minus symbols, as we've seen. Other arithmetic operators are the unary plus and unary minus signs. And what these do is they indicate the sign of, say, an integer that you're working with. If you're working with a positive value and you want to explicitly define it as a positive value, you could have int I equals plus 3. And then that tells Java this is a positive 3. You could use the unary minus sign to tell Java you're working with a negative number. You could have int I equals minus 3. And then that would tell Java this is a negative 3. The default is unary plus. So if you don't define explicitly a plus or a minus, Java will default to positive numbers. So if you just have int I equals 3, Java will assume you meant positive 3. And these unary plus and unary minus operators aren't limited to just ints. They can be used on any value that positive or negative would have some sort of significance. So ints, floats, doubles, longs, these are all examples of things you could use the unary plus and minus sign on. Finally, we have our bitwise and logical operators. With bitwise and logical operators, often we'll have two operators that have the same last name. So in this example on the screen, we have two operators that are both complements. We have one that is a logical complement and one that is a bitwise complement. And you'll see that pattern repeated for many of the other bitwise and logical operators. And generally what that means is the logical operator is working with Boolean values, things like true and false and comparisons, whereas the bitwise operator is working with binary values, ones and zeros. So looking at the operators on our screen, we have the logical complement, which is represented by an exclamation point. And what this will do is reverse the value of a Boolean value. So if you have, say, a Boolean that's equal to true, and you put this logical complement symbol in front of it, the exclamation point, then that's going to flip that value to be false. Similarly, if you put the exclamation point or the logical complement in front of a false value, it will flip it to be true. Now, the bitwise complement, which is signified by the tilde, works on binary numbers. And what it will do is flip every bit in a binary number. So on the bubble in our screen, we have the binary number 10101111. If you were to apply the bitwise complement to that, the tilde symbol, that number would become 01010000. And that's how the bitwise complement would work. Here is a code snippet which is showing an example of the use of a unary operator. So on the top, we have our code snippet, and in the bottom, underneath where it says Java-XMX128M-XMS16M unary example, we see an example of this program being run and what the system would actually output. So our class is called unary example, and we can see on line 5, we have an int x being assigned the value of 10, and then we have 2 print statements beneath it. And in this case, the first print statement is using the post increment operation. It's saying print out r equals colon, and then followed by the value x plus plus. So x is currently equal to 10, and the postfix operation will only increment that value after whatever other operation is needed with x. So in this case, system.out.println on line 6 is going to print out r equals colon space, then it's going to print out the value of x as it currently is, which is 10, and then it's going to perform the postfix increment after that. So that's why we see down in the bottom of the console, our first r equals colon line prints out a value of x equal to 10. Then on line 7, we once again do another print statement, but this time we're just printing out the value of x as it is. And we can see that now x is equal to 11, because after that first print statement, x has been post-incremented and its value has become 11. On line 9, we see another variable, int y, assigned a value of 10. And then we have 2 more print statements, but this time we're going to be using the pre-increment operation. So the first print statement just prints out the value of y as it is. And we can see on the bottom console, it prints out y is equal to 10. Then we do another print statement with plus plus y on line 11. And in this case, the increment operations happens before the actual action of doing whatever it is that we're doing with y. So y is first incremented by 1 to 11 and then printed out. So that's why we see at the very bottom of our screen, y equals 11. In this video, we're going to demonstrate the use of the increment and decrement operators in Java. So to get started, let's create a class for ourselves to work in. We'll create a new class called increment.java, and we'll create a second class called decrement.java. These are going to be 2 completely independent classes just to show off one to increment and one to decrement. So we'll have a main method within our increment class, and we'll have a main method within our decrement class. So in Java, the increment operator is signified by a plus plus, and the plus plus can either come before or after a variable. So we could have it as something like plus plus I or I plus plus. Both are valid, and in both cases, this is the same as saying I equals I plus 1, but there is a slight difference in how that addition is done between the two, which we'll talk about shortly. So let's see this in action. Let's start out with int I equals 3. And then we want to increment the variable I. So we're going to say plus plus I. And we'll assign this to a variable, int a equals plus plus I. Now, our I variable is going to be equal to 4, and our a variable is going to be equal to 4, because we have incremented the value of I, and we've assigned that into a. So we can see this in action by throwing in a few print statements. Now our program will print out the initial value of I, and then it will print out the value of a and I after the increment has happened. So we'll compile that and run it. So in our console output, we can see our initial value of 3 for I, and then followed by the value of 4 for a and 4 for I. Now let's revisit what I mentioned earlier, which is the plus plus I versus I plus plus. The difference between the two is in post-increment and pre-increment. Plus plus I, which is the one that we've demonstrated so far, is pre-increment. And what that means is this operation, this I equals I plus 1, will be carried out before the assignment to a variable. So if we look at line 6, in this case, I've got plus plus I, and I'm assigning that to A. So I is incremented to 4 and then assigned to A. If I were to use post increment, int b equals I plus plus, now what happens is that this I equals I plus 1 operation is carried out after the assignment to the b variable has already happened. So the order of operations here is that I, with a value of 4, is now going to be assigned to b, and then I will be incremented to 5. So in this case, I now equals 5, but b equals 4. So we'll refactor our print statements to print out the value of b and I now. And then we'll recompile our program and rerun it. And we see in our console output at the bottom of my screen, the initial value of I is 3. And then we've run the operation A equals plus plus I. We haven't printed anything out there, but we still know that at this point, I equals 4 and A equals 4. And then we've done the post increment, where we've assigned the value of I to B, which would be 4, and printed that out in the console. And then we've incremented I to become 5, and then we printed out the value of I as 5. So that's the difference between the pre-increment and the post-increment. Now let's look at the decrement operator. The decrement operator is signified with a minus minus. So just like the increment operator, we have a pre and post decrement. So we have minus minus I, or I minus minus. And in both cases, they're equivalent to I equals I minus 1. But once again, with the minus minus I, that's a pre-decrement. So the decrement happens first, the I equals I minus 1 operation, and then the value is assigned to a variable. Whereas the I minus minus is a post-decrement. So the initial value of I is assigned to a variable, and then the I equals I minus 1 operation is carried out. So let's see this in action. We'll do I equals, we'll start out with a variable int I equals 5. And then we will apply a pre-decrement to I and assign that to a value of A. So we'll write int A equals minus minus I. And now we have A equals 4 and I also equals 4. Then we'll do a post decrement with int B equals I minus minus. And now we have B equals 4, but I equals 3. And we can see that out by printing it to the command line. And we will compile and run our decrement class. And so in order of printout in our console, our first print statement prints the value of I, which starts out as 5. We then print out the final value of I, which is 3, as we would expect, because that's the value of I after the decrements have been applied completely. And then we have the value of A, which is 4, and then the value of B, which is also 4. So the operations have been carried out exactly as we expect. And that's how the increment and decrement operators work in Java. Equality and relational operators are both used to compare two operands together and to check their relationship to each other. Most commonly, you'll see these in loop statements. So things like if else, while, do while. This is where equality and relational operators are most commonly used. And that's because you often want to do something while something is true, or if this check, then do this. So equality operators check two different operands together to see if they're equal to each other, and they'll return a Boolean value. If two values are equal, it will return true, and if two values are not equal, they'll return false. Relational operators, on the other hand, check various relationships between two operands, things like is one larger than the other, or is one smaller than the other, or is one larger than or equal to the other one, things like that. Let's look at equality operators first. Equality operators check two values to see whether they're equal to each other or not equal to each other. In the case of primitive values, like integers, it's just going to compare the values directly. If we're comparing things like objects, then it's going to look into the memory and see if we're looking at the same object. So the first one is our equal to operator. And this is represented by a double equal sign. So an equal sign followed by another equal sign. So if we were to compare two integers, we could do that with something like 5 equals 6. And that would return false because 5 does not equal 6. Or we could do 5 equals 5. And that would return true because 5 does equal 5. And we can do that with variables too. If a was equal to 5 and b was equal to 6, we could do a equal b. We could also do a mixture. We could have a equal 5. So we can play around with the operators like that. We also have not equal to, which is represented with an exclamation point followed by an equal sign. And this is the opposite of the equal to operator. This will check if something is not equal to another operand. And if it is not equal to it, then it will return true. And if it is equal to it, it will return false. So going back to our first example, if we did 5 not equal to 6, this would return true. And if we did 5 not equal to 5, it would return false. Now moving on to relational operators. These are used to compare the relationship of two operators. How does one compare to the other in terms of, say, its size? So to that end, we have our first relational operator, which is the greater than operator, represented by a right-facing chevron. And what this will do is it will check the operand on the left of the chevron to see if it is greater than the value on the right of the chevron. If it is, then it will return true, and otherwise it will return false. So if we were to check 5 greater than 6, it would return false because 5 is not greater than 6. If we were to check 6 greater than 6, it would still return false because 6 is not greater than 6. But if we checked 7 greater than 6, it would return true. And once again, we can mix and match variables and numbers. We could have a greater than 6, a greater than b. We can play around with our variables and numbers that way. The next relational operator is the less than, which is represented by a left-facing chevron. And this will check the value on the left side of the chevron to see if it is less than the value on the right side of the chevron. So once again, if we did 5 less than 6, that would return true because 5 is less than 6. If we checked 6 less than 6, that would return false because 6 is not less than 6. And if we checked 7 less than 6, that would also return false. The next relational operator is the greater than or equal to operator, and this is represented by a right-facing chevron followed by an equal sign. So this is going to compare the operand on the left to see if it is greater than or equal to the operand on the right. So once again with our examples, if we did 5 greater than or equal to 6, that would be false because 5 is not greater than or equal to 6. If we did 6 greater than or equal to 6, that would be true because 6 is greater than or equal to 6. And then if we had 7 greater than or equal to 6, we would once again return true. And then we have our less than or equal to operator, which is represented by the left-facing chevron followed by an equal sign. And this is going to check the operand on the left side of the operator to see if it is less than or equal to the operand on the right side of the operator. With 5 less than or equal to 6, we would return true. With 6 less than or equal to 6, we would also return true. And with 7 less than or equal to 6, we would return false. And here is a code snippet that shows off all of the equality of relational operators that we've been talking about. So in the top half of the picture, we have our code, and in the bottom half of the picture, we have the console output, which is what the console would show when we run this code. Essentially, this code is a bunch of print statements showing the result of our operators. So our class is called operatorExample as defined on line 1. And then on line 3, we have two integers defined. We have x and y, and both of them are equal to 3. So starting on line 5 and going to line 11, we have a series of print statements. The first print statement just prints out the value of x and y. So it says x is, then the value x, and y is, followed by the value y. And if we look at the console output, our first line is x is 3 and y is 3. This is followed up with a print statement using the equal to operator. So we first print out x equals y is, followed by the operation using the equal operator. So it's going to check x equal to y, which is true. So if we look down at our second line in the console output, x equals y is true. Our third print statement is going to check the not equal to operator. So we have x not equal to y is, followed by the operator in use, x not equal to y. And that's going to be false because x is equal to y. So if we look at our third line in the console output, we see x not equal to y is false. Then we have our greater than operator. So we have another print statement with x greater than y is, followed by the use of our greater than operator, x greater than y. And if we look on the fourth line of the console output, we see x greater than y is false because 3 is not greater than 3. Then we have our less than operator with x less than y is, followed by the use of x less than y. And that's also false. As we see on the fifth line of the console output, x less than y is false because 3 is not less than 3. Then we have our greater than or equal to operator with x is greater than or equal to y is, followed by the use of it. So x greater than or equal to y, which is true because 3 is greater than or equal to 3. So on our sixth line of the output, we see x greater than or equal to y is true. And finally, we have our x less than or equal to y, which is shown on the seventh line of the console output as true because 3 is less than or equal to 3. So we see x less than or equal to y is true. In this video, we're going to demonstrate how to use Java relational operators. So to get started, let's create a Java class to demonstrate within called relational.java. And within that, we'll create a main method. And now I'll list out what all the relational operators are, and then we'll look at each of them in turn. We have equals equals, we have exclamation point equals, we have a forward chevron, we have forward chevron equals, we have backward chevron, and we have backward chevron equals. So let's see how we can use each of these and what their purpose is. Relational operators will always return a Boolean because we're comparing one value to another in some way. So the result of these will always be either true or false. So let's create a couple different integers to compare. We'll have int a equals 3. We'll have int b equals 5. And we'll have int c equals 7. And finally, int d will also equal 3. Now let's take a look at equals equals. And to do this, I'm going to print the result to the command line of our comparison. So the first thing I want to do is compare my a variable to my d variable. So within my print statement, I have said a equals d. And what this will do is check for equality. So the equals equals is telling Java, is a equal to d? Are they the same value? And if they are the same value, it will return true. And if they're not the same value, it will return false. So in this case, it will print true because a is equal to d. Similarly, if I were to compare a equals b, this would return false because a is not equal to b. The next operator is the exclamation point equals, and this is going to check for not equal to. So this is the opposite of the equals equals relational operator. So if I do another print statement, and I were to say a not equal d, this will be false because Java is checking to see is a not equal to d. And since a is equal to d, this returns false. And if I were to check a not equal b, this will return true because a does not equal b. Our next operator is the single forward chevron, and this stands for greater than. So what this will check for is to see if the value on the left side of the operator is greater than the value on the right side of the operator. So if I were to check, is A greater than B, this would return false because 3 is not greater than 5. If I were to reverse the statement and check B greater than A, this would be true because B, which is 5, is greater than A, which is 3. And if I were to check two values that are the same value, such as A greater than D, this will also print out false because A and D are the same value, therefore A is not greater than D. Next, we have forward chevron equals. And this will check for greater than or equal to. So it will compare the value on the left side of the operator to the value on the right side of the operator and return true if the value on the left side is greater than or equal to the value on the right side and false otherwise. So if we do A greater than or equal to B, we will once again have false because A is 3, B is 5. We are still less than B. If I reverse that and check B greater than or equal to A, it will return true because B is 5, A is 3, and 5 is greater than or equal to 3. But if I once again check A against D, with A greater than or equal to D, now this will return true because A is 3, D is 3, so A is greater than or equal to D because they're both 3. Next we have the backwards chevron, which is going to check for less than. So it will evaluate the value on the left side and check if it is less than the value on the right side of the operator. If I check A against C, this will evaluate is A less than C. A is equal to 3, C is equal to 7, so A is less than C, so this will return true. If I were to reverse these and do C less than A, this will return false because C is 7, A is 3, and 7 is not less than 3, so this evaluates to false. And finally, if I compare two values that are the same, such as A and D, if I check is A less than D, this will return false as well because A is 3, D is 3, they're the same value, therefore A is not less than D. And finally, we have the backward chevron equals, which will check for less than or equal to. So it will evaluate the value on the left side of the operator and see if it is less than or equal to the value on the right side of the operator. So if we were to check is A less than or equal to C, this would return true once again because A is still less than C. If I were to check out the reverse, C less than or equal to A, this will still evaluate to false because C is not less than or equal to A. And if I were to compare two values that are the same value, like A and D, with A less than or equal to D, this will now return true because A is 3, D is 3, so A is less than or equal to D. To verify that this all works as we expect, we'll compile and run this Java program and check the output in the console. So going in order of our print statements, the first two are checking whether A is equal to D, and we have true. We check if A is equal to B, and we have false. Next, we are checking is A not equal to D, and we have false because A is equal to D. And then we are checking is A not equal to B, and we have true because A is not equal to B. The next three are checking is A greater than B? It is not, so false. Is B greater than A? It is, so true. Is A greater than D? It is not, so false. Then we have is A greater than or equal to B? It's not, so false. Is B greater than or equal to A? It is, so we have true. Is A greater than or equal to D? It is, so we have true. Then we're checking is A less than C? And it is, so we have a true. Is C less than A? It is not, so we have a false. And is A less than D? And it is not, so we have another false. And finally, we're checking is A less than or equal to C? And it is, so we have true. Is C less than or equal to A? And it is not, so we have a false. And is A less than or equal to D? And it is, so we have true. And that's how relational operators work in Java. Logical operators in Java are operators that we can use to combine relational operators together in order to produce true or false results. So we can have things like and or not, and combine them with the relational operators like greater than or equal to or not equal to, and return a true result from that. And with these logical operators, we can perform something called short circuiting, which is a micro-optimization in our code. Let's use the OR statement, which is a logical operator, as an example. The OR statement returns true if either operand on either side of it is true. So if Java is checking A or B, and A returns true, Java doesn't even need to bother checking B, because it already knows the end result is going to be true. So it can make the code a little bit more efficient by avoiding that statement. So if you're clever with how you place your statements, you can set it up so that a statement that is likely to be true 90% of the time would be on the left, so that most of the time you don't have to evaluate the one on the right. Let's look at some of the logical operators we have in Java. The first one we're going to talk about is the logical AND operator, and this is represented by the double ampersand. So what this will do is it will evaluate an operand on the left side of the operator and an operand on the right side of the operator, and if both operands evaluate to true, this will return true, otherwise it will return false. Most commonly on either side of the logical operators, you're going to have some sort of relational operators. Not always, but that's the majority of your use cases. So for example, we could have 5 greater than 3 on the left side of our logical AND operator, and 4 greater than 3 on the right side of our logical AND operator. Both of those statements evaluate to true, so 5 greater than 3, ampersand, ampersand, 4 greater than 3 is going to evaluate to true. Now, if we had one of our statements that evaluated to false, let's say, for example, we had 5 greater than 3, ampersand, ampersand, 4 less than 3, well, 4 less than 3 evaluates to false, so we would have the situation seen in our bubble on the screen where it says true and false. So that's going to evaluate to false because not both of our operands are true. And similarly, if both of our operands are false, this would still return false. The next logical operator that we want to talk about is the logical OR operator, which is symbolized by 2 successive bar symbols. So this will return true if an operand on either side of the operator is true. So let's use our first example, 5 greater than 3, but this time using the logical OR operator, and then 4 greater than 3. So we would have 5 greater than 3 or 4 greater than 3. Both operands are true, so this will return true. Now, if one of them was false, such as 5 greater than 3 or 4 less than 3, we have one that's true and one that's false. Well, this will still return true because one of the operands is true. The only time this will return false is if both operands are false. And finally, we have the logical NOT operator, which will just flip the overall result. So let's use our logical AND example, where we had 5 greater than 3 and 4 greater than 3. This evaluates to true. If we were to put the logical NOT in front of that whole statement, then that would evaluate to false. It will flip the end result of the entire statement. And this logical not operator is symbolized with a single exclamation point. Most commonly, you're going to see some sort of expression enclosed in parentheses and the exclamation point sitting just outside the parentheses. Again, it doesn't have to be like that, but that's the most common use case you're going to see the logical not used in. This code snippet shows an example of using the logical AND operator. So we have our public class operator example defined on line 1, and then we have a main method defined on line 2. On line 3, we have two booleans defined. X is equal to true, and Y is equal to false. So then we have a series of print statements from lines 5 to 9. And if we look at the bottom of the screen, we have 5 output lines in the console representing what would happen when this program is run. These are the results of the print statements seen from lines 5 to 9. So the first print statement on line 5 is just printing out the value of what X is and Y is. So on the first console line, we can see X is true and Y is false. Then we're going to use the logical AND operator with various combinations of Y and X. The first combination, seen on line 6, is Y and X. So this is going to be false and true, because Y is false, X is true. And since both operators are not true, this is going to result in false. And we can see on the second line of our console output, Y ampersand ampersand X is false. Our third print statement on line 7 is going to do X and Y. So the same as our previous statement, but we've flipped the operators. X is on the left and Y is on the right. So in this case, we're now going to be checking true and false as opposed to false and true. The order of the operands doesn't matter, so the result is going to be the same. We still have a false on one side of our AND operator. So if we look at our third console line output, we can see X ampersand ampersand Y is false as well. Our fourth print statement is comparing X and X. So this is going to be true and true. In this case, we have true as both of our operands on either side of the AND operator. So the result is also going to be true. And if we look on our fourth console line output, we can see X ampersand ampersand X is true because both operands are true. Finally, our fifth and last print statement is comparing Y to itself with Y and Y. So this is going to be comparing false and false. Since both operands are false and neither one is true, then we have the end result being false. And we can see that on our final console line with Y ampersand ampersand Y is false. Our next code snippet shows the use of the logical OR operator. So once again, we have another public class operator example defined on line 1 with a main method defined on line 2. And we have two booleans defined on line 3, boolean X equal to true and Y equal to false. And then we have a series of 5 print statements from lines 5 to 9 with their corresponding 5 console output lines at the bottom of the screen. The first print statement on line 5 is once again printing out the values of X and Y, so we see X is true and Y is false. Our second print statement on line 6 is using Y or X as its operation, symbolized by Y bar bar X. So this is going to be comparing false or true. Since we have a true on one side of the OR, the end result is going to be true. So we can see that on the second line of the console output, Y bar bar X is true. Our third print statement on line 7 is the same comparison but with the operands flipped to the other side. So we're comparing X or Y, X bar bar Y. Once again, the order of the operands doesn't matter. So since we have a true on one side of our OR operator, this is going to evaluate to true. And we can see that in the third line of our console output, X bar bar Y is true. Our fourth print statement is comparing X or X. So this would be true or true. And once again, at least one of the operators is true, so the end result is going to be true. We can see that on our fourth line in the console output, X bar bar X is true. Finally, we're going to compare Y or Y. This is false or false. And since neither operand is true, this will evaluate to false. And we can see that on the final line of the console output, Y bar bar Y is false. Our final code snippet deals with the logical NOT operator. Once again, we have our public class operator example defined on line 1, followed by a main method on line 2. followed by the two definitions of the Boolean variables on line 3, Boolean x equals true and y equals false. Once again, we have 5 print statements from lines 5 to 9 with their corresponding outputs as would be seen in the console at the bottom of the screen. The first print statement on line 5 prints out the values of x and y, and we can see that on the first line of the console output saying x is true and y is false. Our second print statement on line 6 is going to say not x. So we can see exclamation point x at the end of line 6. And that's going to flip the value of x. Since x is true, not x will be false. And we can see that on the second line of the console output, exclamation point x is false. Our third print statement on line 7 is dealing with not y. So we can see exclamation point y. Y is false, so not y is true. And we can see that on the third line of our console output, exclamation point y is true. On our fourth print statement on line 8, we're using a not operator in conjunction with an or statement. So inside of our parentheses, we have x or y with x bar bar y. So that statement is going to be comparing true or false, and it evaluates to true. So we can think of the inside of the parentheses as being true. Outside of the parentheses, we have an exclamation mark. So that's saying not whatever is inside the parentheses. Since whatever is inside the parentheses is true, and we're saying not that, then this will evaluate to false. And we can see that on the fourth console line output, exclamation point, parentheses, x bar bar y, parentheses, is false. And in our last print statement on line 9, we're doing an and comparison inside of parentheses and a not operator outside of the parentheses. So we're checking inside the parentheses x and y, so true and false, which evaluates to false. And then we can think of the not operator operating on the inside of the parentheses, which is false. So we're saying not false, which evaluates to true. And we can see that on the final line of the console output, exclamation point, parentheses, x ampersand ampersand y, parentheses, is true. In this video, we're going to demonstrate the use of Java conditional operators. To get started, I'm going to create a class for us to work in called conditional.java. And within that, I'm going to have a main method to run our code in. In Java, we have 3 conditional operators. We have ampersand ampersand, bar bar, and exclamation point. So let's look at what each of these do in turn. The first conditional operator we'll look at is ampersand ampersand, and this stands for logical and. So what this will do is evaluate 2 statements and return true if both statements are true, and false if both statements are false. So let's see how that works. I'm going to make an integer, x equals 9. And this is what we're going to use in our conditional. So I'm going to next make a print statement to use our logical and. And within that print statement, I'm going to check x greater than 5, logical and x less than 11. And this returns true because x is both greater than 5 and it is less than 11. Let's do one that would return false with, once again, x greater than 5, logical and x less than 8. This will return false because while x is greater than 5, x is not less than 8. So both conditions on either side of the logical and are not true, and therefore the statement as a whole evaluates to false. The next conditional operator is bar bar, and this is logical or. So this one will look at 2 statements on either side of it and return true if either one of those statements are true. So with logical and, we had the requirement that both statements be true. With the logical or, all we care about is that one statement is true. So let's see how we do that with another print statement. x greater than 5 or x less than 8. This will now return true, because even though x is not less than 8, x is greater than 5. And since all we need is one of the statements to be true, since this is asking, is x greater than 5 or is x less than 8? Well, x is greater than 5, so we return true. If both statements are true, such as x greater than 5 or x less than 11, we would still return true. And if neither statement is true, such as x greater than 10 or x less than 8, then we return false, because x is neither greater than 10 nor less than 8. And the last operator that we want to look at is the logical not operator. The not will flip the overall result. So let's look at some of the statements that we've already done. So I'm going to copy our first logical AND statement from line 6 and paste it here on line 13. Now this is the exact same statement that we have on line 6, but I'm going to add something to it. I'm going to put the inside statement, our logical AND, within another set of parentheses, and outside of that set of parentheses, I'm going to add our logical not operator, the exclamation point. And now what this will do is return false, because it will evaluate first the statement within the parentheses, which we already know returns true because x is greater than 5 and x is less than 11. And then the not operator will flip that result. So the inside evaluates to true, and then we say not this. So that will flip it to become false. If I paste the line from line 7 onto line 14, and once again do the same thing, enclose the inner statement within parentheses, and add my exclamation point, my logical not, now this will return true, because previously we know that x greater than 5 and x less than 8 will return false, and then I add the not outside of that parentheses to flip it to return true. To see this in action, we'll compile and run our program. And in order, we have our first logical AND statement, x greater than 5 and x less than 11, which evaluates to true. Then we have our second logical AND statement, x greater than 5 and x less than 8, which evaluates to false. Then we have our logical ORs with x greater than 5 or x less than 8, and that evaluates to true. X greater than 5 or x less than 11, which evaluates to true as well. X greater than 10 or x less than 8, which evaluates to false. And then we have our logical nots, which are the opposite of our first two statements. So we have not x greater than 5 and x less than 11, which returns false. And then we have not x greater than 5 and x less than 8, which returns true. So that's how we use conditional operators in Java. Bitwise operators in Java are used against integer types of data, things like ints, longs, doubles, floats, and they work by operating on the binary representations of these data. So you might have an integer, and if you're applying bitwise operators, Java behind the scenes will be working on the binary representation of that integer. Our bitwise operators come in two forms, either unary or binary. The unary bitwise operators work on a single operand, so that means that they're doing things like flipping the bits of a number. And we have binary operators, which are working between two different operands. So this is more of a comparison between two binary numbers. Let's take a look at some of the bitwise operators that we have. The first ones that we want to talk about are the bitwise shift operators, and these are all unary operators. These are going to be working on a single operand. They're either going to be pushing the numbers of the binary to the right or to the left. The first one is our zero fill left shift, And let's use the binary number that we have in the bubble on screen as an example, 1010. The 0 left shift will shift the numbers, or the bits, in our binary number to the left the number of places specified. So the operand goes on the left side of the operator, and the number of places that you want to shift goes on the right side of the operator. So if we wanted to left shift our number by one place, we could have 1010 followed by the left shift, represented by two left-facing chevrons, and then the number 1. And that will shift our value one place to the left. Now, how does it do that? Well, our leftmost bit will just be dropped off. So in this case, in our 1010, we'll get rid of that first 1. And from the right side, we'll fill in zeros. So our number will become 0100 once it's left shifted by one place. Next, we have our signed right shift. Signed right shift will shift the bits in our number to the right by the amount specified. So once again, our binary number, or our integer, which will be treated as a binary number on the back end anyway, is placed on the left side of the operator, followed by the signed right shift operator, which is two right-facing chevrons, followed by the number specifying how many places we want it to shift to the right. So if we wanted to shift it one place to the right, we could have 1010 right shift 1. And what this will do is it will shift the number to the right by one place. So our rightmost bit, which is a 0, will get dropped off. And then our leftmost bit will be copied with whatever the previous leftmost bit was. So if our leftmost bit was a 0, then a 0 will be filled in from the left. And if our leftmost bit was a 1, then a 1 will be filled in from the left. So in this case, our leftmost bit was a 1, so a 1 will be filled in. So once we right shift our number right one place, it would become 1101. And finally, we have a 0 fill right shift. This is represented by 3 chevrons, and it works very similar to the signed right shift, but it's different in how it brings a number in from the left. With the signed right shift, we copy whatever number was previously on the left, whether it was a 1 or a 0. With 0 fill right shift, we just default by filling in with a 0. So once again, if we were to right shift our 1010 by 1, but with a 0 fill right shift, we would have 1010 followed by 3 right-facing chevrons to signify the 0 fill right shift, followed by 1. And what that will do is, once again, it will drop the 0 off the far right side of our binary number, and then it will bring a 0 in on the left side of our binary number, giving us 0101. Now let's move on to a couple binary bitwise operators that are going to work on 2 operands. The first is our bitwise AND. And what this is going to do is perform a bit-by-bit operation. So what that means is you're going to have 2 binary numbers, and it's going to compare the bit in the first spot of your first binary number to the bit in the first spot of your second binary number. And then it will continue on that way, comparing the bit in the second place of your first binary number to the bit in the second place of your second binary number, all the way until you are out of bits. And we use these operators to perform these comparisons in order to generate a new binary number based on the result of the comparison. So in the case of the bitwise AND, represented by a single ampersand, we're going to be going on a bit-by-bit procedure. And if we're looking at the first bit in the first place of our number, then the result will go in the first bit of our resulting binary number. So in the case of the first bit in both of our numbers being 1, then the bitwise AND operator will return a 1, and we'll have a 1 in our resulting binary number at that place. If either bit is a 0, then we'll have a 0 in our resulting binary number at that place. And if both bits are a 0, then we'll have a 0 at that binary number in that place. The bitwise OR operator works in the same way, except it only requires one of the bits to be a 1. So in the case of both bits in a certain place being a 1, then the resulting bit in that place in our resulting number will be a 1. If we have a single 1 and another 0, then we'll still have a resulting 1 in that place in our result. And if we have both bits as a 0, then we'll have a 0 in that resulting bit in that place in our result. And the bitwise OR operator is represented by a single bar. Moving on to the bitwise NOT operator. This one is once again a unary operator, so it's only working on a single operand. And what this does is it flips the bit in every place of a binary number. So it's symbolized by a tilde, and you put the tilde in front of your binary number. So let's say, for example, our binary number is 1111. Well, if we put the bitwise not operator in front of that, it would flip and the result would be 0000. So anytime you see a 1, you flip it to a 0. Anytime you see a 0, you flip it to a 1. And that's how the bitwise not operator works. We also have the bitwise exclusive OR, represented by a caret symbol. And this is a binary operator, so it once again works on 2 operands. So we're comparing 2 binary numbers in a bit-by-bit operation once again. But what we're checking now is the result will be a 1 if and only if a single bit in the 2 operands is a 1. So if we're comparing a 1 exclusive OR to a 1, the result is going to be a 0 because we don't want both bits to be a 1. If we're comparing 1 exclusive OR to a 0, the result will be 1 because that satisfies our conditions. And if we're comparing 0 exclusive OR to a 0, our result will be once again 0. And we can combine these bitwise operators with assignment operators to help give us some shortcuts and clean up our code. So we can use our left shift followed by an assignment operator with 2 left chevrons followed by an equals sign. To use this, we put the variable on the left that we want to be shifted, and we put the number of times we want it to be shifted on the right. So it will shift the variable that number of times and then store it in that variable. Similarly with the right shift, we put the variable on the left side, the number of places we want it to be right shifted on the right, and then it is right shifted that amount and stored in that variable. With the bitwise AND assignment, we can do the variable on the left side, the value we want to AND it with on the right, and then it is carried out and stored in the variable. Bitwise exclusive OR AND assignment with the caret symbol followed by an equals sign, and once again, it will perform the exclusive OR between the variable on the left and the number or value on the right, and then store that result in the variable that you have on the left. And much the same with the bitwise inclusive OR, but instead now it's a bar and an equals sign. In this video, we're going to demonstrate the use of Java bitwise operators. When we're talking about bitwise operators, we're actually dealing with binary logic. So in the demonstration, I'm going to be showing you how we use these with integers, but the whole time we're going to need to be thinking about these integers in terms of their binary representation. To get started, we'll create a Java class called bitwise.java. And within bitwise.java, I'm going to have a main method. And now we can deal with our bitwise operators. The bitwise operators that we have, represented by ampersand, bar, tilde, caret, a double left chevron, a double right chevron, and a triple right chevron. So let's take a look at each of these in turn and see what they do and how they're used. Starting in order, the first one that we'll look at is the single ampersand, and this stands for bitwise AND. So let's use it to perform a bitwise AND operation on 2 integers, and then we'll take a look at what it's doing behind the scenes. So we'll have int x equals 4, and then we'll have another int y equals 1. And then what we'll do is throw a few print statements out so we can see it in the console later with x bitwise and y. So what this is going to do is look at both of these numbers in their binary format. Now in Java, ints are 32-bit signed representation. So that means every integer is going to have 32 bits, with the first bit representing the sign, whether it's positive or negative, and the remaining bits representing the actual value of the number. When we get into negative values, it's important to remember that Java is actually dealing with these using 2's complement. And I'll show a little bit about how that works in the shift operations, the left chevron, the right chevron, and the right chevron. So for now, let's look at what these integers actually look like in binary. So beside int x equals 4, I'm going to put the 32-bit signed representation of 4. So this value that I put in a comment beside 4 is what Java is actually looking at the binary representation of 4. Similarly, beside int y equals 1, I'll put the binary representation of 1. So that's what we're looking at when we're doing these bitwise operations. So going back to our bitwise AND, where we've done our x and y, what this will do is look at each bit in both numbers, and if both bits are 1, the resulting bit in that same location will also be 1. If both bits are not 1, then the resulting bit will be 0. So if we look at our int x equals 4 and int y equals 1 values, we can see as I've placed them one on top of each other, it's very easy visually to do the comparison because we just have to look at the top value and the bottom value. And if they're both 1, the result will be 1. Otherwise, the result will be 0. So starting from the right, we have for int x equals 4, a 0 value, and for int y equals 1, a 1 value. We don't have any duplication there. Since not both values are 1, this will be a 0. Similarly, on our third bit, we only have one bit, which is a 1. The one below it is a 0, so the resulting bit will be 0. So by doing a bitwise AND between these two integers, we'll actually end up with a value of 0. The next operator that we want to look at is the single bar, which is bitwise OR. And I can do it with the following print statement, x or y. And what this will do is, once again, compare the two binary numbers and looking at the same position versus the same position. And if either bit in that position is a 1, then the resulting bit in that position will also be a 1. So if we look at our values x and y, in our rightmost bit, x is 0 and y is 1. So since one of those values is a 1, the result will be a 1 in that place. Moving along, the next second bit, both of them are 0, so the result will be 0. The third bit in x is a 1. The third bit in y is a 0, so the result will be 1. And then the rest are all zeros in both of them, so they will remain zeros. So our result in binary is 101, which is equivalent to 5. Our next operator is the tilde, which stands for bitwise not. So we can use it as follows. I can do bitwise not x. And what this will do is invert all of the bits in x. So if the bit is a 0, it will be flipped to a 1. If the bit is a 1, it will be flipped to a 0. So the result will be as seen in my comment at the end of line 12, where we have a large amount of leading 1s, a 0 in the third bit from the right, followed by 2 more 1s. Now this is where what I mentioned at the beginning of the video, where Java uses 32-bit signed integers and 2's complement, becomes important. Because in order to read what this value is, we need to understand first how signed integers work, and that is the first bit on the left, the most significant, is either a 1 or a 0. If it's a 0, it's a positive number. If it's a 1, it's a negative number. So in this case, we know we'll be dealing with a negative number now, since the bitwise not has flipped everything. And then in the 2's complement, in order to read a negative number, flip all the bits once again, and then add the value 1 to it, and then add the negative sign in front of it. So what this will actually convert to when it prints is -5. Because if we invert all of the bits in this value, we get the original value that we started with before we did the bitwise not, which is 4. We add 1 to make it 5. Then we put our negative symbol back in front of the value to make it -5. And that's how these values are handled in Java. Next, we have the caret symbol, and that can be used such as x caret y, and the caret stands for exclusive OR. So this differs from our bar symbol, which was the bitwise OR, in that the bitwise exclusive OR will set a bit to 1 if and only if one of the bits is a 1. So if both bits are a 1, we don't set the resulting bit to a 1. We only do it in cases where a single bit is 1. So in this case, if we look at x with 4 and y with 1, in all cases, we only have a 1 in one of the positions in the binary representation. So the actual result will be the same as the regular OR in this case. Now we move on to our shift operators. So our first one will be the double left chevron, which stands for 0 fill left shift. And I can use it with x double left chevron y. And what this will do is shift all of the numbers in the binary representation to the left by the amount specified on the right side of the operator. So in this case, y is equal to 1, so we're shifting all of the bits in x to the left one place. And any bit that gets shifted to the left off the left side is just discarded, because we can't have more than 32 bits in an integer. And from the right side, we fill in with zeros. So what this will look like, if we shift x to the left by one place, we will delete this first 0, and at the right side, we will add a 0. So the result will be 8. Next, we have the double right chevron. Can be used in a similar way, x double right chevron y. And this is the signed right shift. So this works a little bit different than the 0 fill left shift. What this will do is, once again, we're going to shift the bits, whatever number of places is specified by the right side of the operator, to the right. So in this case, the x value will be shifted to the right one place. And whatever gets shifted off the right side will just be discarded. But coming in from the left, we don't automatically fill with zeros. We will actually fill with whatever is already on the left side of the value. So if the leftmost bit is 0, we'll put in a 0. If the leftmost bit is 1, we'll put in a 1. So in this case, we will get rid of the value on the rightmost side of our binary, and then we will fill in on the leftmost side of our binary with a copy of whatever bit is to our right. In this case, it's a 0. And this will print 2. And our final operator is the triple chevron to the right, which is used as x triple chevron to the right, y. And this is the 0 fill right shift. So this is more similar to our 0 fill left shift, which was the double left chevron. And in this case, we'll once again shift our binary to the right by the amount specified on the right side of the operator. So we'll shift our x binary to the right one place. We'll discard whatever bits get pushed off the right side, and we'll fill in from the left with zeros. So once again, we'll get rid of our rightmost 0, and then we will just add a 0 to the left side of the value. And in this case, we'll once again print 2. Let's compile our program and see the output in the console. So our first operation, as we predicted, has printed 0. The second operation has printed 5. The third operation has printed -5. The fourth operation has printed 5. The fifth operation has printed 8. The sixth operation has printed 2. And the seventh operation has also printed 2. So everything has worked as we predicted that it would. And that's how we can use bitwise operators in Java. Operator precedence refers to the order in which Java will carry out your operations. In Java, every operator has a certain precedence priority. The higher the priority, the earlier that operator is carried out. So we'll take a look at how the operator precedence works in Java and the order in which these operators are used. So we'll look at unary operators, which are performed first, then arithmetic, shift, relational, bitwise, logical, and ternary, and assignment operators. Unary operators have the highest precedence in Java and are therefore executed first in any operation. The highest priority of the unary operators are the post-increment and post-decrement operators. These will be carried out first. Next, we have the rest of our unary operators like pre-increment and pre-decrement, the unary plus sign to signify whether something is a positive or a negative, along with the unary minus sign, the bitwise complement, and the logical complement. So everything on the left side of the screen has the absolute highest priority, followed by the unary operators on the right side of our screen. Moving down in the priority list, our next operator precedence is with the arithmetic operators. Within these arithmetic operators, our multiplication, division, and modulus/remainder operations have the higher priority, and then addition and subtraction have lower priorities. So we've moved down a level from our unary operators. Arithmetic operators have a lower precedence, and then within the arithmetic operators, we have two different precedence levels, one with the multiplicative side and one with the additive side. After the arithmetic operators, we go to a lower precedence level with the bitwise operators, specifically the bitwise shift operators. So we then have, all on the same precedence level, our zero fill left shift, our signed right shift, and our zero fill right shift. After the bitwise shift operations, the next operators in line to be executed are the relational operators. And once again, within the relational operators, we have two different precedence levels. Our higher precedence relational operators are our comparison operators, things like greater than, less than, greater than or equal to, less than or equal to, and instance of. We haven't talked about instance of before, but that's a way of testing whether a specified object is a certain type. And then lower in precedence level within the relational operators, we have the equality operators, our equal tos and our not equal tos. After our relational operators, the next lowest priority and the next ones to be executed are the rest of the bitwise operators, and each of these actually exists on their own precedence level. So at the highest precedence within the bitwise operators, we have our bitwise and. Bitwise exclusive OR is next, and then our bitwise OR is the lowest precedence within this group. Our next lowest priority is the Java logical and ternary operators. And once again, these all exist on their own precedence level. So within this group, our highest precedence would be the logical AND, followed by the logical OR, and finally our ternary operator, which is a shorthand kind of an if and else statement. So you have an expression, and if that expression is true, it executes a certain expression. Otherwise, it executes a different expression. And at the lowest priority, our last to be executed is the Java assignment operators. This is where we have our mathematical assignments, things like your simple assignment, add an assignment, subtract an assignment, multiply an assignment, divide an assignment, modulus an assignment. Then we have our bitwise assignments, bitwise an assignment and, bitwise exclusive OR an assignment, bitwise inclusive OR an assignment. And then our shift assignments, our zero fill left shift an assignment, signed right shift and assignment, zero fill right shift and assignment. Now every operator that I've discussed so far, in terms of their precedence order, will be executed based on highest to lowest priority. But sometimes we don't always want it to be that way. So we can manipulate in Java what order our operators are going to be executed in, and we can do that with the use of parentheses. Let's use multiplication and subtraction, for example. Multiplication exists at a higher precedence level than subtraction, so it will be carried out first. Now let's say we had the expression 5 times 2 minus 1. Well, in this case, without any parentheses, Java will do 5 times 2 first to be equal to 10, and then subtract 1 to be equal to 9. But what if we actually wanted that 2 minus 1 to be operated on first? Well, in that case, we could enclose 2 minus 1 in parentheses, and then we could have 5 times open parentheses 2 minus 1 close parentheses. And what this will do is tell Java, work with whatever's in the parentheses first, and then work with whatever's outside the parentheses. So Java will do 2 minus 1 first to be equal to 1, and then it will do 5 times the result of the parentheses, which is 1, so it will be 5 times 1 equal to 5. And that's how we can manipulate what order the operators get executed in using parentheses to override their default precedence. In this video, we're going to show how operator precedence works and how we can use parentheses to modify the default operator precedence. So to get started, I'm going to create a new Java class called precedence.java. And within that class, I'm going to start with a main method. Now, in Java, every operator has a precedence level. And the higher the precedence level, the earlier that an operator is executed. So operators with the highest precedence are operated first. The table is as follows. From highest to lowest, we start out with our post increment and post decrement. Next, we have our pre-increment, our pre-decrement, our tilde, which inverts all of the bits in a value, and our not operator. Then we have our multiplication, division, and modulo operators, followed by our addition and subtraction operators. Next are our shift operators, so the double left chevron, the double right chevron, and the triple right chevron. Then we have our comparison operators, the less than, greater than, less than or equal to, and greater than or equal to. Then we have our equality operators, so equal to and not equal to. Then we have our bitwise AND operator, followed by our bitwise exclusive OR operator, followed by our bitwise OR operator. Then we have our logical AND operator and our logical OR operator. And finally, we have our equals, plus equals, minus equals, multiplication equals, division equals, and modulo equals assignment operators. So this is the table that we'll follow when determining what order something gets executed in. So let's see how this works. Let's look at, for example, int x equals 5 minus 7 times 8. The way that this will operate is Java will look for the operator with the highest precedence first. In this case, multiplication is higher on the precedence table than subtraction. So 7 times 8 will be executed first, which will give us 56. And then 5 minus that result will be executed next. So we'll have 5 minus 56, which will give us negative 51. Now, if we wanted to change that behavior, we could use parentheses. And what parentheses will do is whatever statement is inside the parenthesis block will be executed first, regardless of whether or not that operator has a higher precedence. So if I used in brackets or parentheses 5 minus 7 times 8, this will work out differently now because whatever is within the parentheses is executed first, even though the subtraction operator has a lower precedence than the multiplication operator. So for this one, 5 minus 7 will be operated on first, which will be minus 2, and then that value will be multiplied by 8 to give us minus 16. So let's put in two print statements to print out the values of x and the values of y to verify that they are as we expect them to be. So let's open up a terminal and compile and run the program to make sure that everything is like we expect it to be. And just as we suspected, the first operations without parentheses, minus 51, and the second operations with parentheses equals minus 16. So that's how we can use precedence in Java and parentheses in order to evaluate what our statements will be resulting in. We go to the precedence table, we find out which operator has the higher precedence, we know that one will be operated first, and then we can change that precedence order with parentheses. So, in this course, we've examined the available mathematical, conditional, relational, bitwise, and unary operations. We did this by exploring programming Java arithmetic, assignment, and unary operators, programming Java equality, relational, and conditional operators, programming bitwise operators, and programming with operator precedence in Java. In our next course, we'll move on to explore working with strings and the benefits of using the StringBuffer and StringBuilder with the stack and heap memory.
One of the most basic classes in Java is the string class. The string class is used to manage text. An individual string is really just composed of multiple individual characters. A string is not a primitive type, though. It is treated like an object, and that means that you can create instances using the new keyword. But the most important detail about a string is that it's immutable, and that means that it can't be changed. Once it's set, that's what it is. You can create new strings and even replace the variables you're using, but you can't change an existing string value. In fact, behind the scenes, Java treats string values as constants, and that's why you can't change them. Now in Java, there are two ways that you can create an instance of a string. The first, and frankly the easiest, is to use a literal. What that means is that you can define a string simply by saying it equals a piece of quoted text. The second way is to use the new keyword. In this case, you create a new instance of the string class and pass the text you want it to be equal to. The advantage of the literal, besides being easier, is that Java keeps all the literals in a constants pool. So if you created two strings that had the same literal, Java would actually optimize your memory usage by having both variables point to the same memory block. So what's the syntax that we use when we're creating a string? What's the actual code that we would write to create a string and then use it? Well, as I said earlier, there are two ways to do it. On the screen, we can see the code that represents those two ways. At the top of the code snippet, you see a string creation using a literal. You can declare your variable with a single string space myString. The myString text is your variable name. Then, after an equal sign, you can provide the text that you want in double quotes. In the case of this code, we're saying that the myString variable is being set to the literal constants of hello world. Now remember from earlier that Java will always try to optimize your code so that if there are literals with the same text in them, they'll share the same memory location. You should use this method as much as possible because it's better for optimization and frankly it's easier to read. The next line of code is an example of using the new keyword. This code once again creates a string variable called myString. Except this time, after the equals sign, we say new space string, and then in the string's constructor, we pass in the double quoted string. So remember from earlier that this will always create a new memory location for your string. It guarantees a different object in memory, but it also reduces the chance for Java to optimize your code. Strings can also be created from arrays of characters. The code on the screen here could be copied into a new Java project and it would work out of the gate. You may even want to try it. The code includes a class definition called myString and has a single static starter method in it called main. The main method would fire when the project starts up, but it's inside the main method where the magic happens. In this code, a variable called stringArray is created, and it's an array of individual characters. You can see each character in single quotes to the right of the equals sign. Now, if you put all the characters together, you can see that they would spell string if they were all put together. And that's what the line below does. Below the string array line, there's a new string variable being created called thisString. After the equal sign, there's once again the new keyword to create a string, but this time we're passing an array of characters. That's right, the string class knows how to translate characters into a string. Why? Because at the end of the day, that's what strings are, arrays of characters. Then the last line of code outputs the string to the console so that it can be read. So if you ran this code, the output would be the word string. Now once you have an instance of a string, you can make use of many of the different accessor methods it has. We'll talk about all the different methods later in this course, but to give you an idea, here's a couple of examples. The length accessor can be used to determine how many characters there are in the string. Meanwhile, the char_at method can be used to find the individual character that exists at a given index. Now, it's important to understand that indexes in Java are zero-based, and that means that an index of 0 corresponds to the very beginning of the string. So let's take a look at those string accessor methods in action. On the screen are two code snippets that show what you can do with the length and char_at methods. The top section of code creates a string variable called myString and sets it to the text hello space world. Then, in the next line of code, an integer variable is created called len. The length method is then called against the myString variable, and the result of that command is placed in the len variable. Now remember that the length variable simply counts all the characters in the string. Now that includes the spaces and special characters. So if we count the number of characters in that string, we'd get 11. So when the printline command is run after all that, that's exactly what we'd get. The bottom section of the code creates a string variable called myString2. It also sets it to the text hello space world. Then in the next line of code, a character variable is created. The char_at method is then called against the myString variable with a parameter of 4, and the result of that command is placed in the char variable. Now remember that the char_at method gets the character at the given index of the string. And remember too that the index is zero-based. So we're actually looking for the 5th character in the string. So if we count out the letters in hello space world, we'd see that the 5th character is the letter O. So when the printline command is run after all that, that's exactly what we'd get. Now sometimes we need to create strings from other strings. Sometimes we need to join them together. So how do we do that if strings are immutable? Well, there are a few ways to do it, and here are a couple of the most common ways. The first way you can join strings together is to use the concat method, and this will add a single string to an existing string. But it's important to note that the concat method actually generates a whole new string. It doesn't change either of the strings involved. The second way you can join strings is to use the plus character. This actually allows you to join many strings all at once. But the important thing to remember here is that each new plus symbol will result in a new string being generated in memory. So if you're planning on adding lots and lots of strings together, you may want to be careful about your memory usage. So let's take a look at a string concatenation in action. On the screen are two code snippets that show the two mechanisms of concatenating strings. In the top snippet, two strings are created. The first says hello with a space at the end, and the second says world. Then the code takes the first string and calls the concat method to add the second string. Then when the code is output to the console using the printline command, we can see the output of hello space world. In the bottom snippet, the same two strings are created again, but this time the strings are simply added together right inside the printline command. A string containing a comma and a space are added to the first string, then the second string is added, and then finally a string containing an exclamation mark is added. In this case, you can see that we're actually adding 4 strings together. Now this is a very simple and common way to add strings together, but watch out, it's technically less efficient and takes more memory to do it this way. In this demo, we're going to go over the features of the string class in Java. To do that, we're going to create a project in Eclipse, and then create and display strings in a couple of ways. Alright, so as I said, we're going to use the free Eclipse IDE in this demo. Now you can use any other kind of Java IDE, and it'll work perfectly fine. Anyway, let's go ahead and open the Eclipse IDE now. Okay, so the first thing we're going to create is a new project. In Eclipse, that's as simple as opening the File menu, and selecting New Java Project. Now, when you want to create a project, you need to give it a name. And for the sake of this demo, I'm just going to go ahead and call my project Demo1. Now, strings have been around since the very beginning, so there's nothing special beyond the default settings that we need to give it. So let's just leave all the defaults as they are and click Finish. Good. Now it asks us for a module name, and this isn't super important for what we're going to be doing in this course, So let's just leave that as the default too and click Create. Perfect. Now our project is created and we're just about ready to get started with strings. Now before we can actually code any strings, we need a file to code in. So let's go ahead and do that. Now first, let's close the module tab that we opened up in the middle of our screen. Alright, now in order to be able to play with a string, you first need to have an entry point into the project. So let's do that by creating a main class. From the File menu, let's select New Class. Perfect. Now in the pop-up, we're being asked for information about our class. The source folder and the package are pointed to the root of our project by default, and that's fine for our purposes. Now let's give our class a name. In this case, let's call it main with a capital M. We'll leave the modifiers, superclass, and interfaces as the defaults, but let's make sure that we check the public static void main method stub checkbox and leave the others unchecked. Good. Now let's click Finish. Excellent. We have our class. So now we can get to creating a string. Now there are three basic ways to create a string. The first way is based on what a string actually is. A string is actually a collection of characters. So what we're going to do here is we're going to create an array of characters and then generate a string from that array. So let's do it. Now let's delete the comment on line 6. Alright, now where the comment was, which is inside the main method, let's type the following code. char space ch open and close square brackets space equals space open squiggly bracket single quote h single quote comma single quote e single quote comma single quote l single quote comma single quote l single quote comma single quote o and end squiggly bracket semicolon. Perfect. Now you can see that we have an array of characters which, put together, spell hello. But that's just an array of characters. Now let's create a string. To do that, we go down to the line underneath our array and type the following code. String, with a capital S, space S1, space equals, space new, space string, open bracket, ch, close bracket, semicolon. And I'll correct my typo. Excellent! We've created your first string. In this example, we created an array of characters and then we created a new string object and passed in that array. Don't believe me? Well, let's see it in action. Let's go down to the next line and type the following code. System, with a capital S, dot out, dot println, which stands for print line, open bracket, S1, close bracket, semicolon. Now that line of code will output our string to the console whenever we run the project. In fact, let's do that. Let's save the file with a Control S, and then run the project. Now we can run the project by clicking on the Run button in the toolbar. Good! Now notice at the bottom of the screen that we now see the word hello in the console. And there you go, we created a string. Now let's look at the second way that we can create a string. Now notice in line 7 that we created a new string object and passed in our array of characters. Well, we can use a similar syntax, but instead of passing in an array of characters, we'll pass in a literal. Let me show you. Let's go down a couple of lines after our print line call and type the following code. String, again with a capital S, space S2, space equals, space new, space string, again with a capital S, open bracket, double quote, my, double quote, close bracket, semicolon. Good. Now in this case, we created a new string again, but this time we passed in a piece of text inside double quotes. This is way easier than creating an array, isn't it? Well, let's see it in action again. Let's add another print line command underneath our new string just like we did for the S1 string, except this time we'll output S2. Good, now let's save the file and run the project. Well, excellent, perfect. Once again, at the bottom of the screen, we can now see the console output our first string and now our second one too. Alright, now let's look at the third way that you can create a string. Now notice on line 10 that we created a new string object and passed in a piece of text in double quotes. That double quoted text is what's called a literal. It's actually already a string. So in reality, saying new string and passing in a literal is a little bit redundant. We can make this even easier. So let's go down another couple of lines after our latest print line call and type the following code. String space S3 space equals space double quote friends double quote semicolon. Good. Now in this case, we've created a string variable directly from a literal. Let's see it again and type out another print line command for our new string. Good. Now let's save and run the project. Excellent. And once again in our console, we're seeing our latest string. And there we have it. We've created string objects in 3 different ways. Great. In Java, strings are immutable, and that means they can't be changed. To change a string means you actually need to create a new string or overwrite your existing variable. So how do you work around that? Well, Java includes a class called StringBuffer. At the end of the day, the StringBuffer class is the same as the string class, except it's mutable, which means that it can be changed. Furthermore, you can actually change the string any number of times in any number of ways. You could change it so it's completely unrecognizable from the original value, and that's perfectly fine. One aspect of the StringBuffer class that's important to understand is that it's thread safe, and that means that multiple threads can't access it simultaneously. And that's important because it means the operations against a StringBuffer class are guaranteed to result in order. Now, unlike the string class, you can't create a StringBuffer class by just defining a string literal. You must always use a constructor. In other words, you'll always have to use the new keyword. The StringBuffer class has a bunch of constructors that you can use. For example, you can use the default empty constructor to simply create an instance and then get started. And this is particularly useful ahead of looping algorithms. You can also create an instance that already has a string in it. To do that, you can use the constructor that includes a string parameter. Now, if you want to set the initial capacity of a StringBuffer instance, you can do that by calling the constructor that accepts the initial capacity value. And this is useful in cases where you want to keep a close eye on how much text is being allowed in the buffer. And finally, you can pass a char sequence value into the constructor to create a string entry from that. Now let's take this simple code snippet to demonstrate a StringBuffer constructor. In this code, we've got a class called myStrBuffer with a static main method. That means that the method will execute when the project is run. In the main method, we create a variable called StrBuffer, which is a StringBuffer type. You can see because we're using the new keyword that we're creating an instance of the StringBuffer class. Now in the brackets of the StringBuffer, we're passing in a string literal that says hello world. And that means that we're using the string-based constructor of the StringBuffer class. What this code does is create an instance of the StringBuffer with an initial value of hello world. Then, in the print line command after that, the value is output to the console. In that case, we'd see the hello world value. Now, as mentioned, the StringBuffer class allows strings to be changed. In other words, the strings are mutable. To do that, there are a few methods that are included in the StringBuffer class. Specifically, the append method allows us to add more text to the existing string. The insert method allows us to insert text somewhere in the existing string. The replace method allows us to replace a portion of the string with some other text. The delete method allows us to remove a portion of the string. And finally, the reverse method allows us to reverse the order of the string. Now, it's important to note that most of the StringBuffer class methods always use indexes to understand where to make changes in the existing string. And those indexes are always zero-based. So a value of 0 means the very beginning of the string. Let's take a look at an example of how you would use the append method. In the code snippet we see here, we're once again creating an instance of a StringBuffer class. and this time we're setting the default value to just hello. Then on the next line, we call the append method to add the string space world. The result when we call the printline command at the bottom of the method is our familiar hello space world. Not too hard, right? Now let's take a peek at an example of how you would use the insert method. In the code snippet that we see here, we're yet again creating an instance of a StringBuffer class, and this time we're setting the initial value to h space world. A typo, right? Well, in the next line, we call the insert method to insert the string ELLO into that string at index 1. Now remember that indexes in Java are all 0-based, so what that means is that an index of 1 would be after the letter H. In the end, when we call the printline command at the bottom of the method, we get the same old hello world text. Next, let's take a look at an example of how you would use the replace method. In the code snippet we see here, we're creating an instance of a StringBuffer class with the text, "Hey there world." But now we decided we wanted it to be our normal text. So in the line below, we call the replace method to replace whatever text starts at index 0 and ends at index 9 with the text hello. Remembering that indexes are 0-based, that means that the text "Hey there" will be replaced with hello. So if we ran this code, the result from the printline method would be our usual hello world. Now let's take a peek at an example of how you would use the delete method. In the code snippet we see here, we're creating an instance of a StringBuffer class with the text "Hello there world." Once again, we want to reduce the text to our usual greeting. So in the line below, we call the delete method. The delete method then removes the text from the string starting at index 6 and ending at index 11. And that means it will remove the word there along with the space that follows it. Then, when we call the printline command at the bottom of the method, we get the desired greeting of hello world. And finally, let's take a look at an example of how you would use the reverse method. In the code snippet we see here, we're creating an instance of a StringBuffer class along with some default text. Astute observers will notice that the text is actually our usual greeting, but spelled backwards. In the line below, we call the reverse method to reorder the text back to front. Then we call the printline method at the bottom of the method and get the proper hello world. In this demo, we're going to go over the features of the StringBuffer class in Java. To do that, we're going to piggyback off our previous demo and then create an instance of a StringBuffer object, and then explore the methods and features available within that object. Alright, so as I said, we're going to piggyback off our previous demo, which we built in Eclipse. So let's head over to the Eclipse IDE now. Alright, so I already have our project open from the previous demo, so if you don't, go ahead and open the project now. Alright, so in our last demo, we created string objects. Strings are great, and you're going to use them an awful lot in your journey into coding. But there is a problem with strings. The problem is that they're immutable, and that means that they can't be changed. You can replace the variable, sure, but you can't actually change a string. And that's where the StringBuffer class comes in. The StringBuffer class manages a string in such a way that it appears to be mutable. In other words, that you can change it. So what we're going to do in this demo is we're going to implement the StringBuffer class and go over a few of the methods and see it in action. Alright, so the first thing we need to do is create an instance of a StringBuffer. So let's go to our main class, and we can do that by double-clicking on the main Java file in the Package Explorer panel on the left-hand side of the screen. And I've already got mine open. Alright, now in our last demo we created some string objects and we can still see them on the screen. So let's leave these strings there and move down a couple lines from our last print line entry, and then let's type the following code. StringBuffer with capital S and capital B, space, buffer, space, equals, space, new, space, StringBuffer, open bracket, double quote, hello, double quote, close bracket, and semicolon. Let's make sure that hello is capitalized. Okay, now just to see that this is working, let's add another print line command below our new buffer object and output its value. Alright, now let's save the file and run the project. Excellent. So in our console output at the bottom of the screen, we can see that the string buffer behaves exactly like a string, and the value is output just like the other strings. Remember, a string is immutable. Our string buffer is supposed to help with that. So let's play with the buffer a bit. Let's make our greeting a bit more personal. Rather than just saying hello, let's add a name to the text. In the line above our print line command, but after our buffer creation, let's type out the following code. Buffer.append, open bracket, double quote, space, and then your name, double quote, close bracket, semicolon. Okay, let's save the file and then run the project with Control F11. Hey, look at that! Now our name is being output to the screen with our greeting. Cool! Now it's worth noting that you can actually chain these append commands. In fact, let's go back to our append command and before the semicolon, add this code. Dot append, open bracket, double quote, exclamation mark, double quote, close bracket, and semicolon. Now we can save the file and run the project again. Cool. So why would we do that instead of just putting the exclamation mark in the name? Well, maybe the name was a whole other variable, so being able to append like this is a good thing. Okay, so that's appending, but what if we wanted to put some text at the beginning or somewhere in the middle of the string? Well, that's where the insert method comes in. Let's try it. Let's pretend we wanted to insert a surprised exclamation at the beginning of the greeting. To do that, let's add a line of code after our append commands and before the print line command. Let's type the following. Buffer dot insert open bracket 0, comma, double quote, O, exclamation mark, double quote, bracket, semicolon. Good. Now as you can see, the insert method accepts two parameters. The first parameter is the location in the original text to place the new text, and the second parameter is the new text to insert. The location is a zero-based index in the string, so by putting 0, we're actually asking for the text to be inserted right at the beginning. Anyway, let's save this file and run the project. Hey, look at that! Now we've added our surprise to the beginning of the string. Now earlier I said that you could chain the append commands together. Well, the chaining is not limited to just the appending. In fact, we can delete the semicolon from the previous line and then pull our insert command up, removing the buffer word, of course. Let's do that. Good. So here we have buffer.append.append.insert. Nice. So let's save and run it to prove it. Hey, perfect. No change to the output except for the space I just added. Good job. Alright, so we've appended text to the end and we've inserted text at the beginning, though we could have put it anywhere. But what happens if we want to replace text? Well, that's where the replace method comes in. With the replace method, we can choose a position in the text that we want to take text out and replace it with some other text. Now be careful. This isn't like a search and replace. You need to know the actual location of the text, just like the insert command. In fact, let me illustrate. Let's add a new line of code between our existing commands and our print line command. Let's type buffer dot replace open bracket 4, comma, space 9, comma, space, and then double quote hi, double quote, and bracket, and semicolon. Cool. Now in this case, we're telling the buffer that we want to replace whatever text starts at index 4 and ends at index 9 with hi, comma. Actually, we're going to put a comma in there. The idea here is that we want to replace our existing hello with something a little less formal, but also correct a little bit of grammar while we're at it. So let's save this and run it. Perfect! We've successfully replaced hello with hi. Now let's shrink our code again a bit. Let's chain the replace with the two appends and the insert. And let's save and run it just to make sure it still works. And it does. Good job. Alright, now let's say we think that surprise thing at the beginning is a bit goofy and we want to remove it. Well, with the string buffer, we can also remove text. To do that, we use the delete method. So let's add to our chain of methods. After our latest replace, but before the semicolon, let's add this code. Dot delete, open bracket, 0, comma, space, 4, close bracket, semicolon. Good. Now, just like the insert and replace, the delete command is accepting index locations for which part of the text to remove. In our case, we're removing the O, the exclamation mark, and the space that follows it. So let's save and run this. Nice! Now we're just left with the hi and our name. Finally, let's play with one more method of the string buffer. Let's adjust our print line command. Instead of just outputting the contents of the buffer, let's reverse the text. Let's add the following code after the buffer variable, but still inside the brackets. Dot, reverse, open close brackets. Good. Now all this is doing is taking the contents of the buffer and reversing the order. So let's save it and run it. Perfect! Now our string has been reversed, and there's not much left of our original hello, is there? And that's it. That's the string buffer. With that class, you can create and manipulate strings to your heart's content. In Java, strings are immutable, and that means that they can't be changed. To change a string means you need to actually create a new string or overwrite your existing variable. So how do you work around that? Well, earlier we saw that we could use the StringBuffer class, but there's another option too. You can also use the StringBuilder class. One big difference between the StringBuilder and StringBuffer classes is that the Builder class is much more efficient. However, it isn't thread safe. That means that multiple threads can access it simultaneously, but in those situations, you would not be able to guarantee the order of operations. But like the StringBuffer class, you can use the StringBuilder class to change a string any number of times. And that's because at the end of the day, the StringBuilder class is the same as the string class, except it's mutable, which means that it can be changed. Now, unlike the string class, you can't create a StringBuilder class by just defining a string literal. You must always use a constructor. In other words, you'll always have to use the new keyword. The StringBuilder class has a bunch of constructors that you can use. For example, you can use the default empty constructor to simply create an instance and then get started. And again, this is pretty useful when you're doing looping algorithms. You can also create an instance that already has a string in it. To do that, you can use the constructor that includes a string parameter. Now, if you want to set the initial capacity of a StringBuilder instance, you can do that by calling the constructor that accepts the initial capacity value. And this is useful in cases where you want to keep a close eye on how much text is being allowed into the builder. And finally, you can pass a char sequence value into the constructor to create a string entry from that. Now let's take this simple code snippet to demonstrate a StringBuilder constructor. In this code, we've got a class called StringBuilderCreation with a static main method. That means that this method will execute when the project is run. In the main method, we create a variable called mysb, which is a StringBuilder type. You can see because we're using the new keyword that we're creating an instance of the StringBuilder class. In the brackets of the StringBuilder, we're passing in a string literal that says hello world, and that means that we're using the string-based constructor of the StringBuilder class. What this code does is create an instance of the StringBuilder with an initial value of hello world. Then in the print line command after that, the value is output to the console. And in that case, we'd see the hello world value. Now, as mentioned, the StringBuilder class allows strings to be changed. In other words, the strings are mutable. To do that, there are a few methods that are included in the StringBuilder class. Specifically, the append method allows us to add more text to the existing string. The insert method allows us to insert text somewhere in the existing string. The replace method allows us to replace a portion of the string with some other text. And finally, the delete method allows us to remove a portion of the string. Now, it's important to note that most of the StringBuilder class methods use indexes to understand where to make changes in the existing string. And those indexes are always zero-based. So a value of 0 means the very beginning of the string. Now let's take a look at an example of how you would use the append method. In the code snippet we see here, we're once again creating an instance of a StringBuilder class. This time we're setting the default value to just hello. Then, on the next line, we call the append method to add the string space world. The result when we call the print line command at the bottom of the method is our familiar hello space world. Pretty easy. Now let's take a peek at an example of how you'd use the insert method. In the code snippet we see here, we're yet again creating an instance of a StringBuilder class. And this time we're setting the initial value to hello space world. Missing the H. Sounds very British of us. Hello, gov. Anyway, on the next line, we call the insert method to insert the string h into that string at index 0. Now remember that indexes in Java are all 0 based, so that means that an index of 0 would be right at the beginning of the string. So in the end, when we call the print line command at the bottom of the method, we're getting the same old hello world text. Next, let's take a look at an example of how you would use the replace method. In the code snippet we see here, we're creating an instance of a StringBuilder class with the text hey there world. But now we decided we want it to be our normal greeting text. So in the line below, we call the replace method to replace whatever text starts at index 0 and ends at index 9 with the text hello. And again, remembering that indexes are 0 based, that means that the text hey there will be replaced with hello. So if we ran this code, the result from the print line command would be our usual hello world. Finally, let's take a peek at an example of how you would use the delete method. In the code snippet we see here, we're creating an instance of a StringBuilder class with the text hello there world again. And once again, we want to reduce this text to our usual greeting. So in the line below, we call the delete method. The delete method then removes the text from the string that starts at index 6 and ends at index 11. And that means it will remove the word there along with the space that follows it. Then, when we call the print line method at the bottom of the method, we get the desired greeting of hello world. In this demo, we're going to go over the features of the StringBuilder class in Java. To do that, we're going to piggyback off our previous demo and create an instance of a StringBuilder object, and then explore the methods and features available within that object. Alright, so as I said, we're going to piggyback off our previous demo, which we built in Eclipse. So let's head over to the Eclipse IDE now. Alright, so I already have our project open from the previous demo, but if you don't, go ahead and open the project now. Okay, so in our last demo, we used a StringBuffer object to manipulate strings. That's because strings are immutable, which means they can't be changed. In this demo, we're going to use the StringBuilder class to manipulate strings. StringBuilder and StringBuffer are very similar classes. There are two main differences between them. The first is that StringBuffer is thread safe, whereas StringBuilder is not. And what that means is that a single StringBuilder instance can be called by multiple threads simultaneously, whereas StringBuffer can't. And StringBuilder is also much more efficient. Anyway, let's give it a try. Alright, so the first thing we need to do is create an instance of a StringBuilder. So let's go to our main class, and we can do that by double-clicking on the main.java file in the Package Explorer panel on the left-hand side of the screen, and mine's already open. Good, now in our last demo, we created a StringBuffer object, and we're going to leave all that and the other strings alone and move down a couple lines from our last print line entry. Then let's type the following code. StringBuilder with a capital S and B, space builder, space equals, space new, space StringBuilder, open bracket, double quote, hello, double quote, close bracket, semicolon. Good. Now notice that this looks exactly like the StringBuffer command that we used earlier, and that's no coincidence. Now just to see that this is working, let's add another print line command below our new builder object and output its value. Good. Now let's save the file and run the project with a Ctrl F11. Hey, look at that! Excellent! In our console output at the bottom of the screen, we can see that the StringBuilder behaves exactly like our string and buffer objects, and the value is output just as expected. Now, just like our StringBuffer object, the StringBuilder is supposed to help us with manipulating otherwise immutable strings. So let's play with the builder like we did with the buffer. Let's make our greeting a bit more personal again. Let's add our name to the text. So in the line above our latest print line command, but below the builder creation, let's type out this code. Builder.append, open bracket, double quote, space, your name, double quote, end bracket, semicolon. Good. Now let's save the file and run the project. Hey, look at that! Now our name is being output to the screen with our greeting. Cool. Now it's worth noting that just like with StringBuffer, you can actually chain commands. In fact, let's go back to our append command, and before the semicolon, add this code. Dot append, open bracket, double quote, exclamation mark, double quote, close bracket. And now we can save the file and run the project again. Cool! So now we know that the builder works just like the buffer. Nice. Alright, now that's appending, but what if we wanted to put some text at the beginning or somewhere in the middle of the string? Well, just like with the StringBuffer class, the StringBuilder class also has an insert method, so let's try it. Let's pretend we wanted to insert our surprised exclamation at the beginning of the greeting. So to do that, let's chain another command to the end of our builder command. So before the semicolon, type the following. Dot insert, open bracket, 0, comma, space, double quote, O with an exclamation mark and a space, double quote, close bracket, and then we'll leave the semicolon. Now, as you see, just like with the StringBuffer class, the insert method accepts two parameters. The first parameter is the zero-based index of where to put the new text, and the second parameter is the new text insert. Now it's important to remember that the index is zero-based, so by putting 0 in our command, we're actually asking for our new text to be inserted right at the beginning. Anyways, let's save the file and run the project. Hey, excellent! Now we've added our surprise to the beginning of the string. Nice job! Alright, so we've appended text to the end and we've inserted text at the beginning, though we could have put it anywhere. But what happens if we want to replace text? Well, StringBuilder has us covered there too. And just like StringBuffer, the replace method can be used to choose a portion of the text that we want to replace with some other text. Now be careful though, just like StringBuffer, this isn't like a search and replace. You need to know the actual location of the text, just like the insert command. In fact, let's add another command to our chain of commands. Before the semicolon, let's type dot replace, open bracket, 4, comma, space, 9, comma, space, double quote, high, comma, double quote, close bracket. Good. Now in this case, we're telling the buffer that we want to replace whatever text starts at index 4 and ends at index 9 with high, comma. Now we've once again decided that we want to replace our existing hello with something a little less formal but also correct a bit of grammar. So let's save this and run this. Perfect! We've successfully replaced hello with hi. Nice job! Alright, now let's say once again we feel that our surprise thing at the beginning is goofy and we want to remove it. Well, with StringBuilder we can remove text just like we did with StringBuffer. So let's do that. We'll use the delete command to do that. So let's add to our chain of commands. Now after our latest replace, but again before the semicolon, let's add this code. Dot delete, open bracket, 0, comma, space, 4, close bracket. Good. Now just like the insert and replace, the delete command is accepting index locations for which part of the text to remove. Now in our case, we're removing the O, the exclamation mark, and the space that follows it. So let's save this and run it. Nice! Now we're just left with the hi and our name. Now finally, let's play with one more method in the StringBuilder. Let's adjust our printline command just like we did with the StringBuffer. Instead of just outputting the contents of the builder, let's reverse the text. So let's add the following code after the builder variable, but still inside the brackets. Dot reverse, open and close brackets. Good. And now let's save it and run it. Perfect. Now our string has been reversed just like it was with the buffer. Now there's not much left of our original hello again, is there? And so that's it. That's the StringBuilder. With that class, you can create and manipulate strings to your heart's content just like you did with StringBuffer. Now StringBuilder is more efficient, but it isn't thread safe. So choose whichever one works best. The string class in Java has quite a number of built-in methods that can be used to attain information or new strings altogether from a given string. As an example, here are a few common methods that are used against a string. char@, length, to uppercase, to lowercase, substring, there's a couple different kinds, trim, index of, last index of, concat, and more. In fact, let's dig into these a little bit. Let's take a look at a small code snippet and see the char@, method in action. In the code snippet we have here, we create an instance of a string with the text hello world. Then in the line below, we call the char@, method on the string and ask for the character at index 0. The purpose of the char@, method is to return whatever character is at a given index. Now remember that indexes are all 0 based, so that means that index 0 means the very first character in the string. So in this case, that would be the letter H in hello world. That value is put into a character variable called ch and then printed to the console in the print line command at the bottom of the method. If we ran this code, it would output the letter H. Next, let's look at an example code snippet that shows how we would use the length method. In this code snippet, we create an instance of a string with the text hello world. Then in the line below, we call the length method on that string, while outputting the result to the console using the print line command. The purpose of the length method is to return the total number of characters, including spaces and special characters, in the string. Now, if you manually counted the number of characters in the string hello space world, you would arrive at 11 characters. So if we ran this code, that's the result that we would get in the output. Now let's take a look at another small code snippet and see the toUppercase method in action. In the code snippet we have here, we yet again create an instance of a string with our familiar text hello world. Then in the line below, we call the toUppercase method on that string. Now the purpose of the toUppercase method is to simply take a string and output a capitalized version of that string. So when we use it in the print line command, as has been done here, it means that the output of this code would be the text hello world, but in all uppercase letters. Now, if the toUppercase method creates a version of a string that is all uppercase, guess what the toLowercase method does? That's right, it makes the text lowercase. So let's take a peek at a code snippet for that method. As you can see, the code is exactly identical to our last snippet that we used for the toUppercase method. The difference here is that we just call the toLowercase method. That means that the result of this method would be to take our usual hello world greeting and output the same text, but all in lowercase. One of the more interesting methods in the string class is the substring method. In this code snippet, we're using the version of the method that takes only one parameter. We once again create a simple string with the text hello space world. Then we call the substring method against that string with a single parameter that has a value of 6. The purpose of the substring method is to retrieve a portion of a given string and output a new string. Remember that indexes are 0 based, so that means that the substring method is going to return the entire string starting at the 7th letter. In this case, the 7th letter is the beginning of the word world. Since this version of the substring method takes everything from there, it means that this code would return the word world. But then there's the other version of the substring method. You can pass 2 parameters into that method. The first parameter would be the starting index, and the second parameter would be the ending index. Then the substring method would return the text in that range. In this example, we call the substring method against a hello world string and ask for whatever it is in the range from 0 to 5, and that would return the word hello. If we wanted the word world, we would use the range 6 to 11. Now let's take a look at an example of how you would use the trim method. In this code snippet, we've created the string hello world, but then we added a bunch of spaces at the beginning and again at the end. The purpose of the trim method is to remove spaces from the beginning and end of any string. So in the next line, we call the trim method, and the output of that call is a new string, but with no spaces at the beginning and end. Now, it's important to understand that the trim only works on the beginning and end. It doesn't touch any of the spaces inside the text. So the space between hello and world is safe. In the end, this code would output our usual greeting of hello world. Next, let's take a look at an example of how you would use the index of method. In this code snippet, we've yet again created the string hello world. In the next line, we call the index of method against a string and pass in the character W. The purpose of the index of method is to find where in the string a certain piece of text starts. In this case, we're looking for the letter W, anywhere in this string. Actually, that's important. Here I'm looking for a single character, but I could just as easily look for an entire word. If we ran this code, the output would be 6. Now remember that all indexes are 0 based. So index 6 is actually the 7th character, so that's right. So what happens if the text isn't found? What if we had the letter Q in there? Well, if the text isn't found, the index of method would return a value of -1. Now, another thing you need to remember is that the index of method returns the first instance of a piece of text. So if we'd put the letter O in this code, the index of method would have returned the index 4, even though there's another O at index 7. Now that brings us to the next example quite nicely. What if we wanted the other O in the text? Well, another option would be to look for the last instance of a piece of text in a given string. The method lastIndexOf does exactly that. In this code snippet, we used the lastIndexOf method to look for the last occurrence of the letter O in the string hello world, and the answer is then 7. Now, the indexOf method does support being given a starting index. So if you wanted to find all instances of a certain piece of text in a string, you can create a loop that searched for that text until the result was -1. At each iteration of the loop, you would set the starting index to the last found instance of the text plus 1. Finally, let's take a look at the example of the concat method. In this code snippet, we've created a string called myString with the text hello. Then in the next line, we call the concat method with the text space world. The purpose of the concat method is to take an existing string and add the given text to it to output a new combined string. Strings are immutable, which means that they can't be changed, so the concat method has to output a new string. But this code tries to be clever and actually replaces our original string variable with the new value anyway. Then, in the end, when the code is run, the output from the printline command is our usual hello world. In this demo, we're going to go over the various methods associated with the string class in Java. Even though the string class is immutable, meaning it can't change, it doesn't mean it doesn't have a whole load of useful features. In this demo, we'll piggyback off our last few demos and go over some of the methods associated with a string and output the results to the console. Alright, so as I said, we're going to piggyback off our previous demos which we built in Eclipse. So let's head over to the Eclipse IDE now. Alright, so I already have our project open from the previous demo, and if you don't, go ahead and open the project now. Okay, so in our last demos, we created a few strings, implemented a string buffer, and implemented a string builder. Strings are immutable, so our buffer and builder classes were used to show how to manipulate strings. But you saw that those classes really didn't have much more than manipulation features. Well, that's because the string object itself already has quite a few useful methods in it. In this demo, we're going to look at a few of those methods. Alright, so the first thing we need to do is access an existing string instance. So let's go to our main class. We can do that by double-clicking on the main.java file in the Package Explorer panel on the left-hand side of the screen, but I've already got mine open. Good. Now in our first demo, we created 3 strings. What we're going to do in this demo is explore some of the features of those strings. There are quite a lot of methods, and in the interest of time, I won't go over all of them, but I will go over some of the most common and important ones. So let's start with the join method. Actually, before we do, it's worth understanding that there are some static methods that you can access on the string class, and then some methods that you can access on instances of a string. The join method is a static class. In fact, let me just show you. Below our S3 friends string and its printline command, let's move down a couple of lines and type the following code. String space S4 space equals space string dot join open bracket double quote space double quote comma space S1 comma S2 comma S3 close bracket semicolon. Now the join command joins any number of strings together, and a delimiter can be provided too. In this case, I've set the delimiter as a space, so all 3 of those strings will be joined together and separated by a space. Now let's add a printline command for S4, and then let's save and run it. And remember, the run command is Ctrl F11. Excellent! Now we can see in the console output at the bottom of the screen that all of our strings have been joined together. Hello, my friends. Nice. The next method we want to look at is the length method. This method is an instance method, meaning it needs an instance of a string to work, and it tells us how long our string is. Now that might seem unimportant, But you may also remember from our StringBuilder and StringBuffer classes that we provided indexes for where to insert, replace, and even delete characters. Well, if you try to provide an index that's outside the size of the string, it will fail. So knowing the length can be very crucial. So let's see it in action. Let's adjust our S4 print line command. Let's append dot length, open and close brackets. Now, if we count the number of characters in the sentence, "Hello, my friends," we'll see there are 16 characters if we include the spaces. So let's save this file and run the project and see what it tells us. And look at that. The "Hello, my friends" was replaced with 16. Another common method is substring. Substring is used to extract a portion of the string based on given indexes. So let's say we wanted to extract the word friends from the sentence that we have in the S4 variable. To do that, we'd need to know the starting and ending index for that word. If we count out the characters in the sentence and remember that everything is zero-based, we know that the word friends starts at index 9 and ends at index 16. So let's replace the length method in the S4 printline command with substring, open bracket, 9, comma space, 16, close bracket. Good. Now let's save and run it. Excellent. We got the word friends. Now notice that in this case, the end index actually happens to be the end of the string. Well, if that's the case, then there's a shortcut that you can take. There's another version of the substring method that you can use where you can just provide the start index and then it will take the rest of the string from there. So let's remove the comma space 16 from the substring command and save the file and run it again. And look at that, the exact same output. Nice. Next comes the contains method. Now contains tells us whether some text exists within our string. And let's try it out. Let's replace our substring command with .contains, open bracket, double quote, lowercase ie, double quote, end bracket. Now we know that the text ie exists in our string. It's right in the middle of the word friends. So we should expect a positive result. So let's save it and run it. Good, it returned true. But one thing you need to remember about strings is that they're case sensitive. So let's make that IE text that we're looking for capitalized and try it again. See, this time it's false. And that brings us to our next handy method. There's actually two. The two lowercase and two uppercase methods can convert the strings to, well, upper and lowercase. So let's use one of them. Now before the dot in our contains command, let's add this code. Dot two uppercase with a capital U and a capital C, open and close brackets. Now what this will do is it will take our string, convert it to uppercase, and then see if the text IE is found in there. So let's save and run this. It's true again, the text is found. Now remember in the StringBuffer and StringBuilder demos that we had to replace text by knowing their indexes? Well, with string methods, we don't have to. We can replace text directly. The important difference is that this results in a whole new string being created, not a manipulation of the existing string. So let's replace our two uppercase and contains command with the following. Dot replace, open bracket, double quote, hello, double quote, comma space, double quote, howdy, double quote, close bracket. So this will replace our existing hello with the goofy howdy instead. Or at least it should. Let's save and run it to find out. Hey, it worked! Now another method of the string class is the equals method. And this is for when you want to compare two strings to each other. Of course, you can just use the equals sign operator and that would work just as well. However, there's a variation of the equals method that's even better, and that's the equals ignore case. As you can guess from the name, the method allows us to compare two strings to see if they're the same, regardless of what case they may be. So let's replace our replace method with dot equals ignore case with a capital I and a capital C, open bracket, double quote, and then in various upper and lower case, hello, space, my friends, double quote, close bracket. Good. So we can see plainly that with different case, the text doesn't equal. But since we're using the special method, they should be equal. So let's execute this and find out. Hey, true, perfect, equal, just like we hoped. Now finally, let's look at one last method. The index of method is very important. Remember all those methods that we've used so far that all require an index? Well, what if you don't exactly know where that text is? The user types a string and you have no idea where any given piece of text is, or if it's even there. Well, that's where the index of method comes in. Let's try it out. Let's replace our equals method with this. Dot index of, with a capital O, open bracket, double quote, my, double quote, close bracket. Now this will look for the text my and return where in the string it finds it. Now let's save the file and run the project to see. Excellent. We see that it's at index 6. But what happens if it's not found? Well, let's change the text to uppercase. And now let's save and run it again to see. This time we see a value of -1, and that means that the text was not found. Now there are various flavors of the index of method, and each is built for different variations of being able to find text. So you'll need to look at the documentation to decide which is best for your situations. But that's the string methods in a nutshell, and there are lots more, like isEmpty, concat, split, intern, trim, and value of. Some methods even have multiple overloads, so it's worth reading over each of them. Anyway, great job. Like most programming languages, Java's string implementation includes the ability to use escape characters. But what is that, and when would you use it? Well, first you need to understand that when you use strings in Java, you will inevitably run across the need to use special characters, and that includes embedding quotes, adding tabs and carriage returns, or even including fancy Unicode text. Much of those values can't just be typed into a string because, well, you just can't. So how do you put a double quote in a string that is defined by double quotes? Well, for that, you need to use escape characters. In Java, the escape character is the backslash. Any special character that you want to put into a string will always be prefixed by the backslash, even the backslash. Let's take a look at a very simple example of the use of escape characters in Java strings. In the code snippet we see on the screen, we create a string with the text, "She smiled and said hello." Now in any book you've read, you'd see the text hello in quotes, because that's what the person said. In this text, we see the same thing, except the quotes have a backslash in front of them. And the reason for that is because the quotes are special characters. If they didn't have the backslash, they would appear to the Java compiler to be the end of the string, and that's not right. So they have to be escaped. Anyway, when the code is run and output to the console using the print line command, the result would be "she smiled and said hello" with the word hello in quotes. Now, if the backslash is a special escape character, then what happens if we want to actually see backslashes in the text? Well, the simple answer is that you would put a backslash before the backslash. In this code snippet, we want to output a directory location to the screen. Specifically, we're creating a string that says the file is in C:\documents:\files. You'll see in that text that the backslashes are all doubled, and that means that Java will allow the backslash to be output to the string. So if we ran this code, the output of the print line command would be exactly what we expect, and the double backslashes would be output as a single backslash. Now another thing about the backslash is that it can be used to denote special characters. A backslash before a certain character can be used to represent a piece of text that you can't otherwise actually type. Java supports the following special characters. /t means tab, /b means backspace, but it's worth noting that it's usually something that's captured from input text versus something that's actually presented in a string. /n means new line, /r means carriage return, /single quote puts a single quote in a string, but it's not usually required though. And you've seen the /double quote in action already, and the /f means form field. but just like backspace, it's usually captured versus actually being presented in a string. Now let's take a look at an example of how you might use one of these special characters. In the code snippet here, we're using a few of the backslash characters. Here we've created a string that once again says that the file is in C documents files. But this time we've put the location in quotes, and we've used the special character /n to put the location on its own line. So if we ran this code, the result would be the text, the file is in, and then the location C : /documents /files would be in quotes and on the next line. Now another thing you can do with backslashes is insert special Unicode characters into your string. Some text can't be typed on your keyboard. Think of a mathematical symbol, bullets, ASCII bounding boxes, and so on. All characters have a Unicode value. So by using the special string /u and then the Unicode value, you can insert Unicode text into your string. As an example, this table shows that the Unicode value for the copyright symbol is 00A9, and the greater than or equal to Unicode value is 2265. So how would you use the Unicode values in a string? Well, like I said, you would use the string /u and then the Unicode value. To illustrate, consider this code snippet. In this snippet, we're creating a string that says copyright /u 00A9 2021. Then, when the string is output to the console using the printline command at the bottom of the code, the /u 00A9 is replaced with the copyright symbol. So the output is actually copyright symbol 2021. You can use Unicode characters for all kinds of things. One interesting example is to output Chinese characters. Now I use this all the time for bullet points and check marks. Unicode characters are readily available on the internet for you to browse and use. In this demo, we're going to go over the various string escaping mechanisms associated with the string class in Java. Sometimes strings have special characters in them that interfere with code, and so those characters need to be dealt with, and that's escaping. Alright, so in this demo, we're going to piggyback off our previous demos which we built in Eclipse. So let's head over to the Eclipse IDE now. Alright, so I already have our project open from the previous demo, and if you don't, go ahead and open that project now. Okay, so in our last demos, we created a few strings, implemented a string buffer, and implemented a string builder. Then we explored the various features of the string class itself. In this demo, we're going to create another string, and this time look to escape some special characters. Alright, so the first thing we need to do is create a string instance. So let's go to our main class. We can do that by double-clicking on the main.java file in the Package Explorer panel on the left-hand side of the screen, but I already have mine open. Now at the bottom of the main method, let's create a new string. Let's go a couple of lines down and type the following. String space S5 space equals space double quote Die Hard is a Christmas movie. Double quote semicolon. And now let's add a print line command below that. Good, and now let's save and run the project so that we can see where we're at. And remember, to run the project, it's Control F11. Good! So far so good, right? Well, what if we wanted to put the movie title in quotes? Well, let's do it. Let's put double quotes around the movie title. Notice how right away there are errors. Java does not like this. Basically, according to the compiler, it looks like we have an empty string, followed by two commands, die and hard, followed by another string, and none of it with any sort of operators. So it's very confused. So how do we fix that? Well, that's where escaping comes in. If we want to use a key character like a double quote in a string, we have to escape it. The escape character in Java is the backslash. So let's see what happens when we put a backslash in front of the quotes that we want in the string. Much better. Let's save and run this to see if it works. Perfect! Now the quotes are accepted in the string. But you may have noticed an interesting flaw. What if the character we want in the string is the escape character? What if we actually want a backslash in our string? Well, let's replace our text with something else to demonstrate. Let's replace the text with my temp folder is C:\temp. And now let's run this to see what happens. Now there are two things worth noting in the output. First is that the backslash doesn't appear, but neither did the T in the folder name temp. We'll get to that part in a second. The main thing we want to deal with here is showing our backslash. Well, to do that, we just add another backslash in front of it. So let's do that and rerun. Perfect. Now we can see the backslash. So now we can ask the question, well, why did the T not show up when we ran this last time? Well, you may have noticed that there was a big space instead, and that's because the escape character can also be used to input other special characters. So the /T actually means tab, and that's what we saw. In fact, there are a few special characters like that. Let's see if we can use a whole bunch of them. Let's replace the text with this. Hello, comma, /r/n/n, my name /s, Sven, period. I like /r/n/t dash movie // Die Hard /r/n/t dash hobby programming. Now in this text, we use the /r for carriage return, the /n for line feed, the /t for tab, the /" for single quote, and the /" for double quote. Now missing from the string is the /b for backspace and the /f for form feed, but those don't render in strings and are usually used more for commands. So let's run the code and see what it shows us. Excellent! So we see the new line commands, the quotes, and the tabs. Nice! Now there are also ways to escape Unicode characters. So it doesn't just have to be line feeds, quotes, and backslashes. Imagine you wanted to replace our dashes in the string we just wrote with a bullet symbol. Well, you could do that. In fact, let's do that right now. Let's replace the dashes with /U2022. And I'm going to clean up some spaces while I'm at it. Now let's run this and see what we get. Hey, excellent! So you can see that the Unicode character that corresponds with that code was output to the screen, and it's a bullet mark. Now that's cool. Now there are tons of Unicode characters, so you can do quite a lot with that capability. In fact, you can use it to output various kinds of symbols, letters with accents, or even different languages like Chinese. So that's escaping in Java in a nutshell. Not much to it, right? Great. When we're using strings in Java, there's lots of situations where we'll want to include values in a string, and we're going to want them to be formatted a certain way. For example, imagine you wanted to create a method that created entries in a log file, or output those values to the console. Now imagine you wanted that method to include a timestamp in it. Well, you probably want that timestamp to be formatted in a particular way, right? Well, that's where Java's formatting classes and methods come in. As you insert values into a string, the way to do it is with format specifiers. Format specifiers exist to aid with the display of values in just about every data type. This includes strings, integers, dates, doubles, and so on. Format specifiers always start with the % symbol. Formatters don't just output values to a string either. They can actually be used to convert values from one form to another. For example, you can provide a decimal value and use a format specifier to output it as a hex. And while format specifiers start with the % symbol, they terminate, or rather are defined by, a type character. For example, %f, where f is the terminating character, is a format specifier for floating point numbers. When we're formatting a string, we're really just inserting values into a string. But we can use format specifiers to indicate how we want to insert values into a string. For example, you would format a number different than a date, right? Well, format specifiers can help you do that. There are tons of format specifiers and even variations of individual specifiers. You can imagine that you can format numbers in loads of different ways, right? The most common format specifiers are the ones shown here. %s is a really good catch-all that outputs anything as if it were a string. The %f and %d can be used for numbers, and the %t can be used to output timestamps in various ways. Let's take a look at an example of how you would use a format specifier to output a numeric value. In the code snippet we see here, we create a new formatter class and then call the format method on that class. In the first parameter of the format method, we see a simple string with the value %d in it. The second parameter is the value -123. All this method does is take the value of -123 and replace the %d specifier in the string with that value. So the output of the println method that follows it would be a string with the value -123 in it. In the text block that follows, we do the same thing but with a +123. What we get in the output is exactly the same, but this time not negative. All that shows us is that the %d specifier works whether the value is positive or negative. Now you may recall from earlier in the course that we talked about escape characters. Well, like an escape character, the % character is special because it means the start of a format specifier. So what if you wanted to output a string that had the % symbol in it? Well, let's take a look at this code snippet to see. In this code snippet, we once again create a new formatter class and then call the format method against it. The value we pass into the format method is 100%%. What that tells the formatter class is that the % symbol is not a specifier, but that we actually want to see the % symbol in the output. So the result when we run the code is 100%. Format specifiers can do some pretty fancy stuff while formatting a string. Let's take a look at this next code snippet for an example. In this code, we're yet again creating a formatter class and calling the format method. This time, the first parameter, which is the format string, is set to %.5s. The second parameter, which is the value to replace the specifier with, is set to hello space world. This specifier is very interesting. What it's saying is that it wants to get the first 5 characters from the other parameter. So if we look at the text hello world and then count out the first 5 characters, we can see that we should get the value of hello back. And in fact, if we ran this code, that's exactly what the println command would show us. Finally, let's look at an example of how you would use the format specifier to output date values. In this code snippet, we create a date object and set its value to the 1st of January 2021. In the next line, we use a simple string formatter to create a string with a formatted date in it. The first parameter of the format method includes 3 format specifiers, and the second parameter is our date. Each of the 3 format specifiers starts with %1 $. And what that tells the formatter is to use the first parameter in the list of parameters that follow the format string, and that the format specifier to use against that parameter will be found after the $. In this case, the format specifiers all start with t, and then some other character. The t means that we want to treat the parameter as a date time. The character that follows the t tells us how to format that parameter. So TB means the month's full name, TE means the day of the month, and TY means the full 4-digit version of the year. So in the end, when the code is run, the output is January 1, 2021. In this demo, we're going to go over the various formatting specifiers associated with the string class in Java. Sometimes we need to output strings based on a known template and replace parts of that text with other known values, and then still format those values. In this demo, we're going to piggyback off the previous demos which we built in Eclipse, so let's head over to the Eclipse IDE now. Alright, so I already have our project open from the previous demo. If you don't, then go ahead and open that project now. Okay, so in all of our demos so far, we've created and manipulated strings. We've also used special characters and even explored the various features of the string class itself. But there's one feature of the string class we haven't explored yet. In this demo, we're going to use the string format method to output a formatted message. Alright, so the first thing we need to do is create a string template. So let's go to our main class, and we can do that by double-clicking on the main.java file in the Package Explorer panel on the left-hand side of the screen, but I've already got mine open. So in our previous demos, you can see that we've created strings, used a string buffer and a string builder, and then demonstrated escape characters. In this demo, we're going to show how we might format a string. And there are tons of situations where you'll want to do something like that. Probably the easiest to wrap our heads around is logging. So what I'm going to do in this demo is create another method called log, and then we'll pass in some variables and ask for that information to be logged to the console. So let's get to it. Now the first thing we need to do is create a new method. To do that, we're going to add the following code after the main method bracket on line 29. Private space static space void space log open bracket string space level comma space string space message end bracket and then the squiggly brackets. Good. Now what we've done here is we've created a method that accepts two parameters, a log level and a log message. So now what we're going to do is output the message to the screen. So let's do that. Inside the method, let's write the following code. System.out.println open bracket string dot format open bracket double quote open square bracket %s close square bracket space %s double quote comma space level comma space message. And then we'll end brackets and semicolon. Now what this code is doing is creating a string that includes two values, the log level and the log message, and outputs it to the screen. The two %s values indicate the place where the level and the message will be placed in the given string. So now let's see that in action. Let's go back to the main method and add a line of code at the end. Let's add log open bracket double quote warning double quote comma space double quote my message double quote end bracket semicolon. Great. Now in this line, we're calling our method and populating the two needed parameters. So let's save this and run it to see what we can get. Now remember, to run, it's Control F11. Look at that! Now we're seeing our formatted log message. Nice! And we used the %s as a specifier. But what's a log message without a timestamp? Well, useless if you ask me, so let's add one. Let's go back to the log method and add a line of code above our print line command. Let's type long space now space equals space system dot current time millis with the T and the M capitalized, and we'll open close brackets and a semicolon. Now this line of code is creating a numeric value that represents the current date and time in milliseconds. Now let's use that value. In our format command, let's change the string. Let's add another square bracket %s square bracket to the beginning of the text. Good. Now, since we want our date to be the first item that's replaced, let's add comma space now before the level parameter. Now let's save and run it. Awesome, now we also see a value that is our date. It's gross and totally illegible, but it's there, and that's great. But it's not really great, is it? I mean, we'd much rather see the time, wouldn't we? Well, that's where the various string format specifiers come in. So far, we've been using the %s because it's a catch-all and will display whatever we pass it. But since we want to format our date, we need to give it a different specifier. Now, dates are a bit complicated because there's lots of ways you can format them. Generally, a date format specifier starts with %t, but that's not enough. In fact, if you leave it as %t, it won't compile. all the %t does is tell the compiler that you want to treat the value like a timestamp. Then it wants to know how to format the timestamp. To do that, we add an extra character after the t. So what we're going to do is we're just going to output the full timestamp. So let's replace the first %s with the %tc, all lowercase. And now let's save it and run it. That's much better, isn't it? Now there are all kinds of different specifiers for all kinds of different data types, not just dates and strings. There are specifiers for characters and yes, strings, booleans, hex values, Unicode characters, octals, and numbers. In fact, let's explore numbers for a second. In our string format command, let's add another square bracketed %s after our level, but before our message. And now let's just hard code a number in the list of parameters. Now, since we added this %s as the third item, you'll need to add our hard-coded number as the third item. So I'll hard code the number 12345. Now let's run it and see what we get. Good! Now that's exactly what we expect, isn't it? But wait a minute. What if I want to have my number have formatting with commas because it's in the thousands? Well, I can do that by changing the specifier. The number specifier isn't a %s, it's a %d. So if we want commas in the number, we can change the specifier to %d. So let's do that. And now let's save and run again. Perfect! Now that's what we're talking about. Now what else can we do with numbers? Well, numbers can have different sizes, so sometimes we want to align text in things like logs. So let's say we wanted to make sure that the number field in our log was always 20 characters in length, no matter the size of the number. Well, we can do that. Let's replace that comma with the number 20. And let's save and run. There! Now we can see that the block is 20 characters in length. Now let's pretend we wanted to pad the field with zeros. Well, we could do that too. Let's just add a 0 before the 20 and then save and rerun. Nice! So now our field is populated with leading zeros. Well, let's say our number was always going to be 5 characters big. So let's change our specifier back to %5d. And now let's save and run this. Okay, that's what we expect. Now for giggles, let's change our number to -12345. And let's save and run that. In this case, because the negative sign needs to be displayed, the field is now 6 characters long, not 5. And that will bump everything out of alignment. Well, to fix that, we can change the specifier to %5d. So let's do that. Good. Now, no real change this time, but let's remove that negative sign, save, and run again. Good. Now there's a space allocated for a potential negative sign. Nice. And now just for one more example of a specifier, let's pretend I wanted to output that number as a hex value. Well, I could do that pretty easily. Let's change that %5d specifier to $x. And then we'll save and run that. Look at that, our number is converted to hex and output properly. But what if we prefer an uppercase X? Well, we can just change our X to an uppercase then. There you go, now it's uppercase. What if you prefer octal to hex? Well, then we can change that X to an O. And there you go. There you have it. That's format specifiers for strings in Java. You can format all kinds of different things. Great job. So in this course, we've examined working with string and the benefits of using the StringBuilder and StringBuffer classes along with the stack and heap memory. We did this by exploring programming with Java strings, StringBuffer and StringBuilder, programming with Java string class methods, Java escaping characters, and programming with Java string formatting specifiers. In our next course, we'll move on to explore the Java math and random number generator classes. When it comes to programming, there is no escaping the fact that sooner or later, you're gonna have to do some math. The good news is that Java has some built-in packages to help you make that a lot easier. In particular, Java includes a built-in math class. The math class allows you to perform mathematical actions against numeric values by using static methods. Of course, if it's standard math you're looking to do, you can always use the standard operators like plus, minus, asterisk for multiply, and / for divide. But for slightly more complex math, the math class is best. The math class includes all sorts of methods to help you take a number or multiple numbers and calculate additional values. Just to name a few, the math class has methods to perform calculations like square root, power, min and max, rounding, and absolute. At the same time, you can also use the math class to perform standard trigonometry, hyperbolic trigonometry, or even inverse trigonometry. Exponential methods are even included in the math class. And of course, there's also logarithmic functions. So you can look at standard e-based log, base 10 log, and so on. The biggest advantage of the math class over some conventional operator-based math is how it works under the hood. Most of the math class methods use the underlying Java strict math package to perform their operations, and that means that some math is performed in the most accurate bit-for-bit way possible. However, not all math methods use the strict math package. It attempts to be less strict and more relaxed. And that relaxed methodology means that the math class is actually much better performing than standard mathematical operations. The math class also provides methods that allow you to perform certain calculations or actions and capture exceptions if you overrun certain data type limits. For example, the addExact method allows you to add two numbers together. Sounds pretty normal, right? Well, let's pretend you wanted to add 1 to the maximum size of an integer. What would happen? Well, with the addExact method, you can capture an exception so you can take the appropriate action. The same is true for the multiplyExact method, and of course the subtractExact method allows you to capture the same types of exceptions in the same way. The toIntExact method can be used to convert long values to an integer. But a long value can be significantly larger than an integer, so once again, the method allows you to capture exceptions in the case that you'll overrun the integer size. So how should you go about using the math class anyways? Should you always use it? Well, first, as I said earlier, it's worth remembering that many of the math class methods generally use the equivalent method in strict math anyways. Strict math is another package in Java that ensures bit-for-bit results when it's run, so it can be very accurate. Now that being said, Java themselves suggest using platform-specific native libraries to achieve higher performance implementations in the environments that you plan to run in. As you work on code, you'll find yourself inevitably doing a lot of different types of math. You can do most basic math functions using Java's math class, and some of the most common basic methods in the math class are math.min, math.max, math.abs for absolute, math.round, math.squareroot, math.exp, which stands for exponent, math.expm1, math.addExact, math.subtractExact, and math.multiplyExact. Let's dig into these a little bit. Let's take a peek at an example of how you would use the math.min method. In this code snippet, we create two integer values. A is equal to 100 and B is equal to 5. In the print line command below our variable declaration, we call the math.min method and pass in those two integers. The purpose of the math.min method is to examine two numbers and return the smaller one. In this case, we would expect the output to be 5, since 5 is smaller than 100. Now let's take a look at an example of how you would use the math.max method. Actually, we can use it in exactly the same way as the math.min method. In fact, this code snippet is exactly the same as the snippet we examined for the math.min method. Once again, we have a variable a set to 100 and a variable b set to 5. This time, though, we call the math.max method with those two variables. The purpose of the math.max method is to examine two numbers and return the larger one. In this case, we would expect the output to be 100, because 100 is larger than 5. Next, let's take a peek at an example of how you would use the math.abs method. In this code snippet, we've created two integer variables. A is set to 125, and B is set to negative 125. In the following two lines of code, we call the math.abs method against each of those variables. The purpose of the math.abs method is to determine the absolute value of a given number. So in both cases, the output is 125. Let's keep it going. In this code snippet, we're going to look over an example of how you would use the Math.round method. There are actually several different types of rounding methods in the math class, but the round method is the most common. In this snippet, we've created a double value that is set to 100.659843. In the next line, we call the Math.round method and pass it that variable. When no additional parameters are passed in, the Math.round method will round a given number to the nearest integer. In this case, the number would be rounded up to 101. So if we run the code, that's exactly the output we'd see. Now let's look at an example of how you would use the math.sqrt method. In this code snippet, we've created an integer variable called a. A is set to 100. Then in the next line, we pass that variable to the math.sqrt method. The purpose of the math.sqrt method is to calculate the square root of the given value. In this case, if we run the code, the math.squareRoot method would accept the value of 100 and output a calculated result of 10. Next, let's look at an example of how you would use the math.exp method. In this code snippet, we've created yet another integer called a, and its value is set to 2. Then, in the next line of code, we call the math.exp method and pass in variable a. The purpose of the math.exp method is to calculate Euler's number e raised to the power of the given value. E is roughly around 2.72. So in this case, e is being raised to the power of 2 and the result is roughly 7.39. And that sounds about right, doesn't it? Now a similar method to math.exp is math.expm1. The purpose of math.expm1 is to calculate Euler's number e again, raised to the power of the given value, and then subtract 1. So in this code snippet, we've used the exact same code as last time, but this time we're calling the math.expm1 method. In our last example, the return value was around 7.39. This time, when we use the expm1 method, we get a value of 6.39. Next, let's take a look at an example of how we might use the math.addExact and math.subtractExact methods. In this code snippet, we created two integer variables. Variable a has been set to 100, and variable b has been set to 5. In the next line of code, we call the math.addExact method with the two values, and in the line after that, we call the math.subtractExact method with the same two values. The purpose of the addExact method is to sum two given parameters, while the purpose of the subtractExact method is to subtract the second value from the first. So why use these methods instead of just using the plus and minus operators? Well, the main reason is because these methods can throw exceptions that can be caught if they overrun the data types that are being used. For example, if you add 1 to the maximum size of an integer, you would get an exception that you can catch and manage. In this case, when we add 100 to 5, we get the expected 105. And then when we subtract 5 from 100, we get the expected 95. And finally, let's take a look at an example of how we might use the math.multiplyExact method. In this code, we yet again create two integer variables that are set to 100 and 5. In the next line of code, we call the multiplyExact method and pass in the two variables. The purpose of the multiplyExact method is to multiply the two given parameters together. While we could use the asterisk symbol instead of this method allows us to catch exceptions if we're going to overrun the data type. But in this case, when we multiply 100 and 5, we get 500. In this demo, we're going to look at some of the basic functions available in Java's math class. We'll use the math class to find the minimum and maximum number between two values, the square root of a value, and the absolute value of a number. To do all that, we're going to create a project in Eclipse and then create and display strings in a couple of ways. Alright, so as I said, we're going to use the free Eclipse IDE in this demo. You can use any other kind of Java IDE and it'll work perfectly fine. Anyway, let's go ahead and open the Eclipse IDE now. Okay, so the first thing we're going to do is create a new project. In Eclipse, that's as simple as opening the File menu and selecting New Java Project. Now, when you create a project, you need to give it a name, and for the sake of this demo, I'm just going to call my project Demo 10. Now, that math class is very common and has been around since the very beginning, so there is really nothing special beyond setting the name that we have to do. So let's just leave all the defaults as they are and click Finish. Good. Now it asks us for a module name. Now, this isn't super important for what we're going to be doing in this course, so let's just leave it as the default and click Create. Perfect. Now our project is created and we're just about ready to get started with the math class. But before we can actually start coding with the math class, we need a file to code in. So let's go ahead and do that. Now first, let's close the Module tab that opened up on our screen. Alright, so now in order to be able to play with code, you first need to have an entry point into the project. So let's do that by creating a main class. From the File menu, let's select New Class. Perfect. Now in the pop-up, we're being asked for information about our class. The source folder and the package are pointed to the root of our project by default, and that's fine for our purposes. So let's give our class a name. In this case, let's call it main with a capital M. Good. And we'll leave all the modifiers, the superclass, and interfaces as the defaults. But let's make sure we check the public static void main method stub checkbox and leave the others unchecked. Good. Now let's click Finish. Excellent. We have our class. Now we're going to be spending a lot of time in this class, so we're going to try to make our lives a bit easier. Let's create a method that will output the results of our math to the screen. Now below the main method, let's create a new method. Let's type the following code. Private static void log open bracket string method comma object result. And then the squiggly bracket. Now this method takes in two parameters, a method name and a result. What we want to do with this method is output text to the console. So let's add some code to the body of the method. Now let's type the following code inside our method. System.out.println, which stands for print line, open bracket, string.format, open bracket, double quote, %s, space, %s, double quote, comma, method, and result. And then two close brackets and a semicolon. Excellent. Now what this code does is it creates a formatted string that outputs the method name and the result to the console. Good. Now we're finally ready to get started. Now there are a few basic static methods available in the math class. A static method is a method that you can access from the class definition without creating an instance of the class. The first methods we're going to look at are the min and max methods. Now before we get started, let's remove the comment on line 6. Good. Now where that comment was, let's type the following code. Log, open bracket, double quote, min, double quote, comma, space, math.min, open bracket, -10, and 10. And don't forget the semicolon. Good. Now, in the next line, let's type the following code. Log, open bracket, double quote, max, double quote, comma, space, math.max, open bracket, -9, comma, +9. Close the brackets and the semicolon. Now in these two lines of code, we're calling the math class's min and max methods. The min method takes two numbers and gives us back whichever value is the smallest. In this case, we expect the answer to be -10, right? Then the max method takes in two numbers and gives us back whichever value is the biggest. And in that case, we're expecting the result to be 9, right? Well, why don't we find out? Let's save the file with a Control S and then run the project with a Control F11. Excellent. Now, if you look down at the bottom of the screen in the console window, you can see the two numbers have been output. And the output says our min value is -10 and our max value is 9. And that's right. That's fantastic. Next, let's take a look at the square root method. We know the square root of 64 is 8. So let's run some code where we know that that's the answer we're going to get. Now, on the line below our min and max values, let's add this code. Log, open bracket, double quote, root, double quote, comma space, math.sqrt, which stands for square root, open bracket, 64, and then close the brackets and the semicolon. Now once again, we're wrapping our math command in our log method so that we can see the result. But as you can see, the square root method accepts a single value and then returns its square root. Or at least it should. Let's save this file and run the project to find out. Nice! Now as you can see in the console at the bottom of the screen, the value of 64 was square rooted and a value of 8 was returned and output to the screen. Alright, now let's take a look at one last basic math class method. Let's take a look at the absolute method. The absolute method takes any numeric value and returns its positive equivalent. So we know that the absolute value of, say, -5.2 is just 5.2. So let's see if the math class agrees with us. Now on the line below our latest square root call, let's add this code. Log, open bracket, double quote, abs, double quote, comma space, math.abs, which stands for absolute, open bracket, -5.2, close the brackets, and the semicolon. Now, just like we've done every time so far, we've wrapped our math command in our log method so that we can see the result. Now, as you can see, the absolute method accepts a single value and then returns its absolute value. So let's give it a try and find out if that's true. Save and run. Perfect! Now, as you can see in the console at the bottom of the screen, the value of 5.2 is returned from the negative variable. So there you go. Those are the basic static methods available in the math class. There are many more advanced methods available in the math class, and we'll get to those in a later talk. Not all the math you'll do in Java will be basic and simple. In some cases, you'll need to perform some advanced math too. But don't worry, Java's math class has lots of advanced methods built in right alongside the basic methods. Some of the most common advanced methods in the math class are math.log, math.log10, math.log1p, math.2radians, math.sine, math.cosine, math.tan, math.asine, math.acosine, math.sinh, math.cosineH, and math.tanh. So let's dig into these a little bit. Let's take a look at an example of how we would use the math.log method. In this code snippet, we create a double variable called a and set it to 100. Then, in the line of code below that, we call the math.log method with that variable. The purpose of the math.log method is to retrieve the base e log value for the given numeric parameter. In this case, with an input of 100, the method would return a value of about 4.61. But base e log is not the only thing you can do. Let's take a look at an example of how we would use the math.log10 method. In this code snippet, we once again create a double variable with the value of 100. Then this time we call the math.log10 method. Now the purpose of the math.log10 method is to retrieve the base 10 log value for the given numeric parameter. Now in this case, it's pretty easy. With an input value of 100, the method would return a value of 2. In fact, there's even another log method. This time, let's take a look at an example of how we would use the math.log1p method. In this code snippet, we use the same familiar double variable set to 100, and this time we pass it to the math.log1p method. The purpose of the math.log1p method is to calculate the natural log of the given input plus 1. So in reality, with an input of 100, the method is actually returning the natural log of 100 and 1. So in this case, we get an output of about 4.62. Now, when we start doing trigonometry, we start needing to know about degrees and radians. The methods in the math class that calculate trigonometry values need an input in radians. But generally, we think of values in degrees. So enter the Math.2radians method. In this code snippet, we create a double variable called a and set it to 100. Now that value is in degrees. Then in the line below, we call the Math.2radians method. The purpose of that method is to convert the value in degrees to radians. In this case, the radian value of 100 degrees is about 1.76. Next, let's take a look at an example of how we would calculate the sine value of a given input. In this code snippet, we create our familiar value of 100. Then, in the line below, we call the math.sine method and pass in the value. The purpose of the math.sine method is to calculate the sine value for an input angle in between 0 and pi. Now remember that the input for this method is generally considered to be in radians, so really we're passing in 100 radian. In this case, the sine value for 100 radians is about negative 0.51. Now let's take a look at an example of how we would calculate the cosine value of a given input. You'll notice that this code snippet is remarkably similar to our sine example that we just looked at, and that's because these methods are almost exactly the same. Now once again, we create a value of 100, and once again that's considered to be in radian. We then pass that value into math.cos method so that we can calculate the cosine value for an input angle between 0 and pi. In this case, the cosine value for 100 radians is about 0.86. Now in trigonometry, we can't talk about sine and cosine without talking about tangents. Just like sine and cosine, the math class also includes a method for handling tangents. In fact, once again, you'll find this code snippet to be virtually identical to the last two that we did. So yet again, we create a double value and set it to 100. And yet again, it's considered to be a value in radian. This time we pass that value into the math.tan method so that we can calculate the tangent value for the input angle. In this case, the tangent value for 100 radians is about negative 0.59. Now be careful though. You technically can't calculate a tangent for values at 90 degrees. Again, that's not 90 radians, but rather 90 degrees. That would technically result in infinity. So while we can calculate the regular sine, cosine, and tangent, we can also calculate their inverse arc angles. In this code snippet, we create a double value called a and set its value to 0.2. Then in the next line, we call the math.asine method and pass in the value. Now, just like in our other examples, the arc methods still expect an input in radian. So our value of 0.2 is technically considered to be in radian. The purpose of the math.asine method is to calculate the arc sine value for an input angle between 0 and pi. Now let's take a look at an example of how we would calculate the arc cosine value of a given input. You'll notice that this code is once again remarkably similar to our arc sine example that we just looked at, and that's again because these methods are almost exactly the same. So once again, we create a value, and once again that value is in radian. We then pass that value into a math.acos method so that we can calculate the arc cosine value for an input angle between 0 and pi. So while we can calculate the regular sine, cosine, and tangent, and we can calculate the arc sine, arc cosine, and arc tangent, we can also calculate their hyperbolic value. In this code snippet, we create a double value called a, then in the next line we call the math.sinH method and pass in the value. Now once again, just like all the other trigonometry methods, the hyperbolic methods still expect an input in radian. Now the purpose of the math.sinH method is to calculate the hyperbolic sine value of the input angle. Now let's take a look at an example of how we would calculate the hyperbolic cosine value of a given input. You'll notice again that this code snippet is again remarkably similar to our hyperbolic sine example that we just looked at, and again that's because they're almost exactly the same. So once again we create a value, and once again that value is in radian. We then pass that value into math.cosh method so that we can calculate the hyperbolic cosine value for an input angle. And finally, let's take a look at an example of a hyperbolic tangent implementation. Just like hyperbolic sine and hyperbolic cosine, the math class also includes a method for handling hyperbolic tangents. In fact, once again, you'll find that this code snippet is virtually identical to the last two that we did. So once again, we create a value, and once again, that value is in radian. This time, we pass that value to a math.tanh method so that we can calculate the hyperbolic tangent value for the input angle. In this case, the hyperbolic tangent value for an input of 10 radians is about 1. In this demo, we're going to look over some of the advanced methods available in Java's math class. In particular, we're going to look over some of the logarithmic methods, trigonometry methods, hyperbolic methods, and some other common math class methods. And then we'll output the results to the console to validate our result. Alright, so to do all that, we're going to piggyback off our previous demo which we built in Eclipse. So let's head over to the Eclipse IDE now. Alright, so I already have our project open from the previous demo, but if you don't, go ahead and open the project now. Okay, so in our last demo, we created a logging method so that we could output the results of a few basic math class methods that we invoked. In this demo, we're going to call some advanced mathematical methods in the math class so that we can see their output. Alright, so let's get back to our main class. We can do that by double-clicking on the main.java file in the Package Explorer panel on the left-hand side of the screen. Now I've already got mine open. Good. Now in our last demo, we called some of the basic math class methods and wrapped them in our call to our log method. So let's do that again, but this time we're going to use some logarithmic methods. Let's drop a couple of lines down from our last block of calls and type the following code. Log, open bracket, double quote, log, double quote, comma space, math.log, open bracket 100, two close brackets, and a semicolon. Now the log method returns the natural log base e of whatever value we pass in this case 100. But there are other log methods. So let's go down to the next line and invoke one more. On the next line, let's type the following code. Log, open bracket, double quote, log10, double quote, comma space, math.log10, and then we'll pass in the value of 100 again, close the bracket, and semicolon. Good. Now the log10 method returns the base 10 log of whatever number we pass in, and again in this case 100. So let's save the file and run the project to see what we get. Now remember, you can save the file with a Control S and run the project with a Control F11. Excellent. In our console output at the bottom of the screen, we can see that the log calls output some values. Nice. Now I won't bother going into detail about how we can validate some of the advanced math here, but we know that the log10 method works by order of magnitude, and we can plainly see that the input of 100 output the correct value of 2. So great job so far. Now let's try some trigonometry. Now there are three main trigonometry methods: sine, cosine, and tangent. So on the next few lines, let's write out some trigonometry, shall we? Now on the next line, let's type the following code. Log, open bracket, double quote, sin, double quote, comma space, math.sin, which is sine, open bracket, 90, double close bracket, and semicolon. Good. Now what we've done here is we've called a method that returns the sine value of a number, in this case 90. Now the sine method actually accepts a value in radian. So what we're actually saying is that the value of 90 is in radians, but that's not quite right. That's a value in degrees. So let's just adjust this code a bit. Let's replace the number 90 with this code. Math.toRadians with a capital R, open bracket, 90, close bracket. Good. Now we're passing in the radian version of the number 90, and then getting the sine value for that. Now, of course, a 90-degree value means that you've reached the top of the sine wave. So that means that we should expect to get a value of 1 back. So let's save the file and run the project to see. Perfect. We got a value of 1. Now we know that the cosine is the inverse of a sine. So let's copy and paste the code that we just made for sine and replace it with cosine. And now we should expect a value of 0 for the same 90 degrees. So let's try it. Perfect, we got 0, or at least close enough as makes no difference. Now let's copy and paste the code one more time. And now let's update the code for tangent. Now we know that at 90 degrees you can't have a tangent, so let's change it to 45 degrees instead. And let's save and run the project. Good. Now at 45 degrees, we get a tangent of about 1. Very nicely done. Now in addition to the base trigonometry methods, there are also some arc versions and the hyperbolic version. Now to illustrate, let's implement the hyperbolic version. Let's copy and paste our 3 trigonometry lines and then update them to sine h, cosine h, and tangent h. And let's give this a run. Alright, nice! Now I won't bother going into the math of how this actually works, but if you're familiar with hyperbolic curves, then those same degrees that we passed into the base trigonometry methods should yield the numbers that we're seeing in the console. Fantastic! Now the advanced methods of the math class aren't all about trigonometry. There are also some additional calculation methods. For example, let's take a look at rounding. Now on the next line, let's type the following code. Log, open bracket, double quote, floor, double quote, comma space, math.floor, open bracket, 6.5, close bracket, semicolon. Good. Now in the next line, let's write something very similar. Let's write log, open bracket, double quote, CEIL, double quote, comma space, math.ceil, which stands for ceiling, open bracket, 6.5, close bracket, semicolon. And next, in yet another line, let's add this. Log, open bracket, double quote, round, double quote, comma space, math.round, open bracket, 6.5, 2 close brackets, and a semicolon. And finally, let's add one more line like this. Log, open bracket, double quote, RINT, double quote, comma space, math.RINT, which stands for round int, open bracket, 6.5, close bracket, semicolon. Perfect. So now these 4 methods are all taking the same number, 6.5, and rounding them in their own way. The floor method rounds down to the nearest integer, and here we would expect a value of 6. The ceiling method rounds up to the nearest integer, so since it's the opposite of floor, we would expect a result of 7. The round method rounds up or down to the nearest integer. Here we would expect a result of 7 since 5 typically rounds upwards. And finally, the rint method rounds to the nearest mathematical integer. In other words, it rounds up or down to the nearest number unless the decimal is 5. In that case, it rounds to the nearest even number. So here we expect a value of 6. So to recap, we expect the values 6, 7, 7, and 6. So let's run this and see what we get. Nice! 6, 7, 7, and 6. Okay, so let's do one more method. Let's take a look at the power method. In the next line, let's write this code. Log, open bracket, double quote, POW, double quote, comma space, math.POW, it stands for power, open bracket, 8, comma 2, close bracket, semicolon. Good. Now in this method, we're asking for the value of 8 to be raised to the power of 2. So we know that 8 squared is 64. So if we run this code, then that's what we should expect as a result. So let's do that. Nice! We got the answer we expected. So that's the advanced methods of the math class in a nutshell. There are several variations of some of the methods, along with some others that we didn't go over. But for the most part, this should give you a good glimpse into how the math class is organized and how it works. Great job! Sometimes we need to use random values. There are all kinds of use cases for that. The good news is that Java has us covered there. In fact, in Java there are 3 main ways to create random values. First is the random class in the java.util package. Then there's the random static method in the math class. And finally there's the ThreadLocalRandom class. Let's dig into these a little bit. The random class is probably one of the easiest and most common ways to generate random values in Java. To use the random class, you need to import the java.util.random package, and once you do, you then need to create an instance of the random class to gain access to its method. Now once you've generated an instance of the random class, you can then start generating random values. The cool thing about the random class is you can generate random values of virtually any data type. That includes integers, doubles, booleans, and even bytes. To generate random values, all you have to do is call the appropriate method. In some cases, like with integers, you can even set the upper boundary for random numbers. For example, you can ask to generate a random number between 0 and 10, rather than anywhere between the minimum and maximum size of an integer, which is about 2 billion to negative 2 billion, by the way. Now let's take a look at an example of how you would use the random class. In this code snippet, we import the java.util.random package right at the very top of the code. Then, in the main method, we create an instance of the random class and assign it to the randNo variable. Then we call the nextInt method and pass in a value of 50. Now the purpose of the nextInt method is to generate a random integer value anywhere in the integer spectrum, which means it can even be negative. When a value is passed in, it will generate a value between 0 and that value. So in this case, we're generating a random value between 0 and 50. Each time we run this code, we would get a new value. In the example here, the output was 42. Next, let's take a look at an example of how we would use the Math.random method. In this code snippet, you'll see that unlike the random class, there's no need to import a package and there's no need to create an instance of any class. In fact, the only line of code here is just to call the random static method in the math class. The purpose of the Math.random method is to generate a random number between 0 and 1. The downside of the Math.random method is that it can't generate random values of any other data type. Finally, let's take a look at an example of how we would use the ThreadLocalRandom class. In this code snippet, we import the java.util.concurrent.threadLocalRandom package right at the very top of the code. Now, unlike the random class, the ThreadLocalRandom class doesn't require an instance to be created. But unlike the Math.random method, the ThreadLocalRandom class can generate random values of different data types. Effectively, the ThreadLocalRandom class is the best of both worlds. In fact, Java recommends using this class because it's optimized for thread usage. In this code snippet, we generate a random integer value by calling the current.nextInt method. The current portion of the command retrieves a pointer to the current thread. Now that's not super important for this course, so let's just leave it at that. The nextInt method then generates a new random integer somewhere between the minimum and the maximum possible values of an integer. Java's random class is one of the easiest and most common ways to generate random values in Java. It has a few characteristics worth noting. First, it's thread safe, or more appropriately, the random class is built in such a way that you can use it in multiple threads without worry of collision. However, it's worth understanding that the random class is not cryptographically secure. That means that the random values are generated in such a way that they can technically be guessed. And that means they'd be really bad to use for security ciphers. But one of the best perks of the random class is that it can generate random values of multiple different data types. The random class has 2 constructors. First is the default empty constructor. Using this constructor provides you with an instance of the random class and you can go ahead and get started. Next is the constructor that accepts a seed. With this constructor, you can specify the starting seed for your random class, and that can be useful, but it's not very common. Now, I mentioned earlier that the random class includes the ability to generate random values for lots of different data types. To do that, you simply need to call the right method once you have an instance of the random class. For example, the ints method will generate and return multiple random integer values all at once. The doubles method will generate and return multiple double values all at once. And you guessed it, the longs method will generate and return multiple random long values all at once. Next, you have the next int, next double, next float, next boolean, and next byte methods, which generate a single random value for the next data type that the method references. The next Gaussian method generates a random Gaussian value between 0 and a standard deviation of 1 and returns the result as a double. And finally, we have the ability to update the seed value by calling the setSeed method. Now let's take a look at an example of how we might generate some random integers with the random class. In this code snippet, we create an instance of the random class. Then we enter into a loop that executes 10 times. In each iteration of the loop, we ask our random class to generate an integer value between 0 and 50 by calling the nextInt method and passing in a parameter of 50. We then output the generated value to the console using the printLine command. Now notice how the random class is created outside of the loop. That's an optimization step that prevents us from creating a new random class every time the loop iterates. Anyway, each time you run this code, you would get a new set of 10 random integer values between 0 and 50 output to the console. So what if we wanted to generate a random value between a different range? Well, let's take a look at an example of how we might do that. In this code snippet, we're trying to generate a random value between 5 and 25. This code snippet shows that the nextInt method is being called again, but a parameter of 20 is being passed in. And that means that a random value between 0 and 20 is being generated. Then 5 is merely added to the result. So while the random number generation is still technically calculating as a 0 base, our little trick makes it look like it's generating a value between 5 and 25 instead. Now with the random class, generating random double values means getting a value between 0 and 1. So what if we wanted a different upper bound for our doubles? What if we wanted to generate a random double value between 0 and 50 instead of 0 and 1? Well, let's take a look at an example of how we might do that. In this code snippet, we once again create an instance of the random class. Then we enter into a loop that executes 10 times. In each iteration of the loop, we ask our random class to generate a double using the nextDouble method, and then we simply multiply the results by 50. Then the results are output to the console. So if we ran this code, we'd get 10 random double values between 0 and 50. Next, let's take a look at an example of how we would use the random class to generate a random float value. In this code snippet, we once again create an instance of the random class, and then we call the nextFloat method. The purpose of the nextFloat method is to generate a random float value between 0 and 1. The code snippet then outputs the results to the console. So each time we run this code, we'll get a new value output to the console between 0 and 1. And finally, let's take a look at an example of how we would use the random class to generate random Gaussian values. In this next code snippet, we once again create an instance of the random class. Then we call the nextGaussian method. The purpose of the nextGaussian method is to generate a random, normally distributed value between 0 and a standard deviation of 1 from the random class's current sequence. Now, if that sounds complicated, it's because it's meant to be. Regardless, the output will be a double value that's between 0 and 1. In this demo, we're going to go over some of the features of Java's random class. In particular, we're going to look at how to create an instance and then generate random values of various data types. Alright, to do all that, we're going to piggyback off of our previous demos, which we built in Eclipse. So let's head over to the Eclipse IDE now. Alright, so I already have our project open from the previous demo, but if you don't, you can go ahead and open it now. Okay, so in our previous demo, we created a logging method so that we could output the results of a few basic commands to the console. In this demo, we're going to call that same logging method to output some random values of various data types to the console. So that means that we need to navigate to our main class, and we can do that by double-clicking on the main.java file in the Package Explorer on the left-hand side of the screen. And I've already got mine open. Good. Now in this demo, we're going to make use of Java's random class, and that means that we need to import a package into the file. So let's go up to the very top of our code file, and between the package definition and our class definition, let's add the following code. Import java.util.random semicolon. Good. Now what we've done here is we've imported the package that contains Java's random class. And that means that we can now use the random class in this class. In fact, the first thing we're going to do is create an instance of the random class. So let's go down to the bottom of our main method. Underneath the latest block of code we wrote, let's drop down a couple of lines and type the following. Random, space rand, space equals, space new, space random. Open close bracket, semicolon. Nice. Now what we've done here is we've created an instance of our random class in our method, and we've named that instance rand. So now let's use it. Now the random class can create all kinds of random values in all kinds of different data types. So let's start with the most basic of all, the Boolean. A Boolean value can be true or false, and that's it. So let's test out just how random this random class is. In the line below our random variable, type this code. Log, open bracket, double quote, random, space Boolean, double quote, comma space, rand dot next Boolean. Open close bracket, and then we'll close the bracket for the log call and semicolon. Now in this code, we're asking the random class to generate a random Boolean value. So let's save this file with a Control S and then run the project with a Control F11. Nice! So in the console output at the bottom of the screen, it's generated a value of false. Let's run the project a few more times and see what it outputs. Good. Now notice that the result wasn't always the same. Sometimes I got true and sometimes I got false. It didn't just switch back and forth either. It randomly decided between the values. Okay, so that's Boolean values, but what about floats and doubles? Well, let's give it a try. Let's add a new line below our code and type this. Log, open bracket, double quote, random space double quote, comma space, rand dot next double. Capital D, and don't forget the open and close brackets, and a semicolon at the end. Good. Now what this method and the next float method does is generate a value somewhere between 0 and 1. And that means that if you wanted a random number between 0 and 100, let's say, you'd have to multiply the output by 100. Anyway, let's save this file and run the project to see what we get. Nice. Pretty simple, isn't it? Well, we've seen now that we can do Booleans and doubles, and they're pretty simple, but there's also integers. And integers are pretty easy, but they do have a twist. So let's start with the simple method. Let's drop to the next line and type this. Log, open bracket, double quote, random space int, double quote, comma space, rand dot next int. And don't forget the brackets and the semicolon. Good, now let's give this a run. Perfect. Now, the interesting thing about the random integer is that it can also be negative. It's limited to the bounds of the integer itself. So it can be anywhere between about 2 billion and negative 2 billion. So let's run it a couple times so that we can see negative values. Right away, we got one. But with this method, there's a twist. One of the overloads allows you to put a bounding number in. So let's do that. Let's put the number 10 inside the next int method call. Good. Now what this means is that the random class will generate a random integer value between 0 and 10. So let's run it and find out. Perfect. Now if we run it a few more times, we'll see a new value each time. Great. So let's explore one more feature of the random class. You can actually use the random class to generate multiple random values at once. Rather than generating one at a time, you can ask the random class to generate a set of number values at random. So let's give it a try. In the next line, let's type the following code. Double, space, doubles, open and close square brackets, space equals, space rand dot doubles, open bracket, 5, close bracket, dot to array with a capital A, and open and close brackets and a semicolon. Good. Now what we're doing in this line of code is that we're asking the random class to generate 5 random double values. Then we're converting the results to a standard array of doubles. Now let's output the results to the console. In the next line, type the following code. 4, open bracket, int, space I, space equals, space 0, semicolon, space I, space the less than symbol, space doubles, dot length, semicolon, space I, plus plus, and then close bracket and put some squiggly brackets. Perfect. Now this is a simple for loop and it will iterate over all of the values in the array. So now we're going to output each individual value to the console. So inside the for loop squiggly brackets, let's type the following code. Log, open bracket, double quote, random double, space, double quote, space plus, space, open bracket, I, space plus, space 1, close bracket, comma, space doubles, open square bracket, I, close square bracket, close bracket, semicolon. Good. Now I won't bother explaining the indexing and labeling here. Suffice it to say that each of the 5 generated double values will be output to the screen this way. In fact, let's run the code and find out. Hey, perfect! Each of our 5 values have been generated and output. In fact, you can run the code again and you'll see a different set of random values each time. Excellent! So that's Java's random class in a nutshell. As you can see, you can generate random values of virtually any data type, and you can even generate multiple random values at once. Great job! An easy-to-use mechanism for generating random values in Java is to use the random method in the math class. The random method generates a pseudo-random double value in much the same way that the random class does when you call the next double method. The value that's generated is always between 0 and 1. Now underneath the hood, the random method actually generates an instance of a random number generator, but it doesn't do it every time you call the method. Instead, the very first time it's called, the behind-the-scenes instance will be created, and then every new call after that will just use that instance. In fact, the random number generator that gets generated is an instance of the random class. The Math.random method has one key aspect. It only generates double values, and it only generates those values between 0 and 1. So if you wanted to generate a value within a certain range, you'll have to be clever about it. In fact, generally speaking, if you want to use the Math.random method to create random values between a range, you may have to create your own user-defined method like a randomWithRange method that accepts your desired range. Then, in your method, you would call the Math.random method with multipliers and offsets to generate values within the desired range. So let's take a look at an example of how we would use the Math.random method to generate a random value. In this code snippet, you can see that there's no need for any package import, and we don't have to create an instance of any classes. In fact, all we do in this code is call the Math.random method and assign the result to a double variable called x. Then the output is written to the console using the print line command. So in this case, each time we run the code, we'll generate a new random value between 0 and 1. But what if you wanted to generate a random integer in a certain range? Let's say we wanted to generate a random integer between 5 and 55. In this code snippet, we do just that. In fact, we use a few of the math class methods to achieve it. First, we placed all our code in a for loop so that we could generate 10 random values. The first thing of note is that we call the Math.random method. Now, as you know, this generates a random value between 0 and 1. Then we multiply the results by 50. Now, this means that we're effectively generating a random double value between 0 and 50. Then, to make sure that the results are an integer without any decimal points, we use the Math.round method to round the results to the nearest integer. Now this means that we will now have a random integer between 0 and 50. And finally, we can take the result and add 5. This gives us the final result of a random integer between 5 and 55. In this demo, we're going to implement the random method in Java's math class to replicate the capabilities of Java's random class. In this demo, we'll be able to see what's possible with the random method, but we'll also see that while it can be useful, it can be more difficult in other situations. Alright, to do all of that, we're going to piggyback off of our previous demo which we built in Eclipse. So let's head over to the Eclipse IDE now. Alright, so I already have our project open from the previous demo. If you don't, you can go ahead and open it now. Alright, so in our first demo, we did create a logging method so that we could output the results of a few basic commands to the console. In this demo, we're going to call that same logging method to output our new random values to the console. So that means that we need to navigate to our main class, and we need to do that by double-clicking on the main.java file in the Package Explorer panel on the left-hand side of the screen, but I've already got mine open. Good, now in our last demo, we made use of Java's random class. In this demo, we're going to try to generate the same outputs but using the random method in Java's math class. The big advantage to the random method in the math class is that we don't have to import any packages and we don't have to create a class instance. It also means that we can get right to coding. So let's start off with the easiest bit of code. In our main method, let's drop down a couple of lines from our last code block and type the following code. Log, open bracket, double quote, random space double quote, comma space, math.random, open and close brackets, then close the bracket for the log call and a semicolon. Now the random method generates a random double value between 0 and 1, and this is exactly the same as the next double method that we call in the random class. But notice that we don't need to create a class this time. So let's run this code and see what we get. And remember, that's a Control S and then a Control F11. Perfect. Now in the console log at the bottom of the screen, we now see our random double value. Okay, so now things get a bit tricky. What we want to do now is replicate what we did with the random class. And to do that, we're going to use some tricks that we learned from using the math class so far. Now let's start with the Boolean value. Let's keep things in the same order as before, so we're going to add a line above the line that we just typed. So let's type this code. Log, open bracket, double quote, random space Boolean, double quote, comma space, math dot rint, open bracket, math.random, open and close bracket, then close the bracket for rint, and then space equals space 1, close bracket, semicolon. Cool. Now what this line of code is doing is it's generating a random value between 0 and 1. Then we're using the rint method to round that value to 0 or 1, whichever one is closest. Then we're using a simple equals operator to decide if the value is equal to 1 or not. Basically what's happening here is that we're saying that any value generated at or above 0.5 will be considered true, and all other values will be considered false. So let's run this and see what it says. Excellent, we got false. Now let's run it a few times and make sure it works. False, false, true. False. Nice. All right, so the next thing that we did with the random class is to create a random integer. Now this one's a bit tougher. In the end, we bounded our integer to a max of 10, but let's just start with a random integer. To do that, we're going to write something lengthy, so stay with me on this. Here we go. Log, open bracket, double quote, random, space int, double quote, comma space, math.round, open bracket, math.random, open close bracket, space, star, space, integer with a capital I, dot, and in all capitals, max underscore value, close bracket, space, star, space, open bracket, math.rint, open bracket, math.random, open close bracket, equals 1, question mark, 1, colon, negative. Close bracket, semicolon. Phew! Now that's quite a piece of code. Now alright, let me review it and tell you what's going on. Remember that the random method generates a random number between 0 and 1. Well, the integer value is anywhere from about 2 billion to negative 2 billion. So the first thing we need to do is multiply that random value by the maximum size of an integer. So that means if we got the random value of 1, it would be converted to the maximum size of an int. But what it also means is that if we got the minimum random value of 0, then it would be converted to 0. Then, no matter the result, the value is rounded to the nearest integer so that we don't have any decimal. Now remember that the random class is able to give us a random value all the way down to negative minimum of an integer. So the second part of the call does the same thing as our random boolean that we did before, except in cases where the random value is less than 0.5, it will multiply our result by negative 1. So in the end, this is using 2 calls to the random method to generate a positive or negative random integer value. So let's see if it works. We'll save and run. Oh, I had a typo. Now we'll save and run. Fantastic! We generated an integer value. Now let's run it a few times to make sure we're getting both positive and negative values. Perfect. Now with the random class, we're able to bound our random integer. Well, the good news is that we can do that here too without too much pain. In fact, it might even be easier. In our last demo, we bounded the result to between 0 and 10. Well, to do that here, all we have to do is replace the integer.maxValue code with the number 10. And then we can remove the code that multiplies by 1 or negative 1. Perfect. Now that's way less code, isn't it? Let's save this and run it. Perfect. We got a random integer between 0 and 10. Let's run it a couple times. Excellent. Now finally, the last thing we did with the random class is that we generated multiple double values at once. Well, sadly, the random method in the math class can't do that. The call to the random method is for one value at a time. Now we could simulate that by creating our own class or method, but if you do that, then you may as well just use the random class. And in fact, you can see from the work that we've done here that the random class is quite a bit easier to use if you want to generate multiple random values or random values of different data types other than double. Now regardless, that's the random method in the math class in a nutshell. Great job! Java's ThreadLocalRandom class is one of the best ways to generate random values in Java. In fact, Java's best practice is to use this class wherever possible. It has a few characteristics worth noting. First, compared to the ThreadLocalRandom class, the random class underperforms. And the reason that the random class doesn't work as well as the ThreadLocalRandom class generally has to do with its use in threads. If there are multiple threads, then each thread may use the same shared instance of the random class, and this can result in contention. And that's the key, threading. In a multi-threaded environment, it's much better to use the ThreadLocalRandom class. Now, when the ThreadLocalRandom class was created, it was optimized to work in threaded environments. It's much faster and more efficient than the random class in multi-threaded scenarios. Now, the ThreadLocalRandom and the random class are very similar in usage, almost identical actually. So let's compare them a bit. The ThreadLocalRandom class is actually a combination of the ThreadLocal class and the random class, hence its name. While it's been heavily optimized, it still does all of the same stuff as the random class under the hood, so they operate similarly because they are effectively the same class. Now, one difference between the classes is that explicit initial seed setting is not supported in the ThreadLocalRandom class. However, you can update it before calling any of the random value generation methods. Now, however, one of the major benefits of the ThreadLocalRandom class is that random value generation in the current thread is not affected by other threads generating their own random values. Now, like the random class, the ThreadLocalRandom class includes the ability to generate random values of lots of different data types. To do that, you simply need to call the right static method. For example, the first method that you'll have to call before calling any of the rest of the methods is the current static method, and this returns a pointer to the current thread's instance of a random value generator. Then, once you have the current thread, you can call the next int, the next double, the next float, and the next boolean methods to generate a single random value of any data type and method reference. And finally, we have the ability to update the seed value by calling the setSeed method. Now let's take a look at an example of how we might generate some random integers with the ThreadLocalRandom class. In this code snippet, we import the ThreadLocalRandom package right at the top of the code. Then you'll notice that we don't need to create an instance of the ThreadLocalRandom class anywhere. In the code, all we have to do is call the current method to get the current thread's random value generator, and then call the nextInt method to generate a random value anywhere in the integer spectrum. The result is then output to the console. So in this case, each time we run this code, we'll get a new random value somewhere between -2 billion and +2 billion. Now let's take a look at an example of how we might generate some random doubles with the ThreadLocalRandom class. In this code snippet, we once again import the ThreadLocalRandom package right at the top of the code. Then, in the main body of the code, we call the current method to get access to the current thread's random value generator, and then finally we call the nextDouble method to generate a random double value between 0 and 1. Pretty simple, really. And finally, let's take a look at something a little bit different. Let's take a peek at an example of how we might generate some random Boolean values with the ThreadLocalRandom class. In this code snippet, you'll see that we're running the same type of code that we ran in the last couple of examples, except in this case, we're calling a method called nextBoolean. The purpose of the nextBoolean method is to generate a random Boolean value. That's it. So each time we run this code, we'll get a random true or false value. Now they don't alternate. In other words, if I got true this time, it doesn't mean I'll get false next time. That wouldn't be very random, would it? In fact, I've run demos in the past to show this off, and I get the result of false 10 times in a row. Unlikely as it was, it is pretty common for a demo. In this demo, we're going to implement Java's ThreadLocalRandom class to replicate abilities of Java's random class. In this demo, we'll be able to see what's possible with the ThreadLocalRandom class, and we'll see that it can be just as useful, if not better, than the random class. Alright, now one last time, we're going to piggyback off of our previous demo which we built in Eclipse. So let's head over to the Eclipse IDE now. Alright, so I already have our project open from the previous demo, and again, if you don't, go ahead and open it now. Okay, so as you've come to see in this course, in our first demo we created a logging method so that we could output the results of a few basic commands to the console. In this demo, we're going to keep calling that method to output our new random values to the console too. So that means that we need to navigate to our main class, and we can do that by double-clicking on it in the Package Explorer on the left-hand side of the screen. Mine's already open. Good. Now in our last demo, we tried to use the random method in Java's math class to replicate the capabilities of Java's random class, which we implemented in the demo before. Now in this demo, we're going to try to replicate the capabilities of Java's random class again, but this time with Java's ThreadLocalRandom class. Now one of the advantages of the ThreadLocalRandom class is that we don't have to create a class instance, but we do have to import a package. So let's do that first. Now at the top of the file, in a new line below our import for the random package, let's add the import command. Import space java.util.concurrent.threadLocalRandom. Semicolon. Good. Now this imports the ThreadLocalRandom class into our project so that we can use it in our class. I'm going to start calling it TLR. Now, as you may be able to guess from the name, the TLR class is primarily used for thread safety. In fact, Java recommends using this class instead of sharing an instance of the random class. Remember that when we use the random class, we have to create an instance. Well, if we shared that between threads, the concurrency could cause collisions. The TLR class is intended to handle that for you behind the scenes. Alright, so if that's all true, then let's see if we can use it just like we did with the random class. So let's go down to the bottom of our main method, drop down a couple lines from our latest code block, and type the following code. Log, open bracket, double quote, random space boolean, double quote, comma space, thread local random dot current, open close brackets, dot next boolean with a capital B, open close brackets, close the bracket to our log call, and a semicolon. Now in this code, we're asking the TLR class to generate a random boolean value. Now notice how the code is identical to the code that we wrote for the random class. The only difference is that in this case, you didn't need to create an instance of the TLR class. The other thing you'll see is the current method. Now that's a reference to the current thread. It's really the only static method, so let's not worry too much about that. Anyway, let's save the file with a Control S and run the project with a Control F11 to see what it tells us. Nice! So in the console output at the bottom of the screen, it generated a value of true. Now let's run the project a few more times and see what it outputs. True, true, false. True, false. Good. Now notice how the result wasn't always the same and behaved just like the random class. So far, so good. Okay, so we know that we can replicate the random Boolean values correctly, but what about floats and doubles? Well, let's give it a try. Let's add a new line below our code and type this. Log, open bracket, double quote, random space double quote, comma space, thread local random dot current, open close brackets, dot next double, open close brackets, close the bracket, semicolon. Good. Now once again, this method is exactly the same syntax as the random class. This method also generates a random value somewhere between 0 and 1. Anyways, let's save the file, run the project, and see what we get. Perfect. That's pretty simple, isn't it? Great, so now we can replicate the random class's Boolean and double methods, but let's not forget about that tricky integer and its bounding. But let's start with the unbounded random integer. Let's drop in the next line and type this. Log, open bracket, double quote, random, space int, double quote, comma space, thread, local, random, dot current, open close brackets, dot next int. Open close brackets, close the bracket to the log call, and semicolon. Good, now let's give that a run. Perfect. Now just to make sure that this is the same as the random class, let's run this a few times to make sure that we're getting values that are both positive and negative. After all, remember that an integer can technically be anywhere between roughly 2 billion and negative 2 billion. Good. Now let's see if we can bound the random number generation like we did with the random class. Let's put the number 10 inside nextInt. Good. Now what this should mean is that the TLR class will generate a random integer between 0 and 10. So let's run it and find out. 4. Perfect. And if we run it over and over again, we should get different values between 0 and 10 each time. Good job. Okay, so now in our previous demo, we tried to replicate the random class's ability to generate multiple random values at once, and we quickly discovered that that wasn't possible. Now, is the TLR class able to do it? Well, yes, it is. In fact, let's give it a try. In the next line, let's type the following code. Double space doubles 2, open close square brackets, space equals space ThreadLocalRandom dot current, open close brackets, dot doubles, open bracket 5, close bracket, dot toArray with a capital A, open close brackets, semicolon. Now what we're doing in this line of code is that we're asking for the TLR class to generate 5 random double values. Then, just like we did with the random class, we're converting the results to a standard array of doubles, which we've called doubles2 this time. Now let's output the results to the console. In the next line, let's type the following code. 4, open bracket, int space I space equals space 0 semicolon space I space less than symbol space doubles 2 dot length semicolon space I plus plus close bracket and the squiggly brackets. Perfect. Now this is a simple for loop and it will iterate over all the values in the array. So now we're going to output each individual value to the console. So inside the for loop squiggly brackets, let's type this code. Log, open bracket, double quote, random space double space, double quote, space plus space open bracket, I space plus space 1, close bracket, comma space, doubles 2, open square bracket, I, close square bracket, close bracket, and semicolon. Good. Now once again, I'm not going to bother explaining the indexing and labeling here. Suffice it to say that each of the 5 generated double values will be output to the screen. In fact, let's run the code and find out. Save, Control F11. Hey, perfect! Each of our 5 values has been generated and output. In fact, you can run the code again, and you'll see a different set of random values each time. Excellent. So that's Java's ThreadLocalRandom class in a nutshell. As you can see, it perfectly mimics the random class, so you can generate random values of virtually any data type, and you can even generate multiple random values at once. The advantage is that it's more thread safe and doesn't require an instance to be created. Great job! So in this course, we've examined the Java Math and Random Number Generator classes. We did this by exploring programming Java Math and basic math classes, advanced math classes and programming with Java random classes and the Java.util.random class, and programming with the Math.random and ThreadLocalRandom classes. In our next course, we'll move on to explore various types of Java decision statements.
In this video, I'll describe and compare the various Java decision statements such as if-then else, and switch to describe when to use each statement. Decision statements refer to conditional execution, a branching of code based on a comparison or logical test. In general, we also call them conditional statements. The basic syntax starts with the if statement, using the if keyword. We say that if a condition is true, then execute the given block of code. If a condition is true, but we also have an option for if a condition is false, we can use an if-else statement. So we have our if block in case it's true, then an else block with other code to execute if it's false. We can also use nested if statements. So inside of an if block, we have another if block. And inside of that, we can have another if block. So there's nothing stopping an if block from containing another if block. And we have the switch case statement. to execute different cases of code based on a particular value. The if statement is the decision-making model for Java. We can document the if statement and decision-making in Java through a flowchart visualization. So we start, we reach a condition, and that condition is our if statement. So if the condition is true, we execute more statements, and then we come to the end, our stop. If the condition is false, we bypass the statements and go straight to the end, where the stop is. The if statement, with its conditional block of code, is surrounded by braces, and it's the simplest decision-making construct we have in Java. When the given condition inside of the parentheses, which follow the if keyword, is true, the code inside the given block is executed. So you have code surrounded by braces after the if, and the condition is in parentheses to execute code when a condition is true. But what if the condition is false? The code skips over the conditional code block. However, we can follow it with the else keyword, which means executing some other code when the if statement is false. What follows the else keyword is another code block surrounded in braces. The conditional code block after an if statement is just like any other code in Java. We can also, and often do, embed another if inside of our if statement's conditional code. We can execute an if block inside of an if block, and down further, an if, in an if, in an if, in an if, and so on and so on. But if you do get more than a few levels deep, you should probably see if your code can be broken up into a different way, separated into functions, because too many nested ifs are hard to follow. But syntactically, there's nothing stopping you from nesting as many if statements as you'd like. We also have a branching statement, the switch case. It's like an if conditional, but it's based on a specific value. We have the switch keyword, followed by a variable name in parentheses, and a code block with braces which contain the possible cases. It's important that the variable in the switch can have multiple discrete values. Each branch is a case or multiple cases based on the value of the variable. Choices of code execution are the cases, or a default case that is executed if no others are reached. So let's look at a basic if statement with some example code. So we have this public class Java conditionals, which will display the result if the value of I is less than 50. And inside of our main function here, I have int I equals 10, and then if I is less than 50, so the I less than 50 is in parentheses, that's our condition, and then our if block is between the next braces. So we have an open brace, which usually appears at the end of the line, along with the if statement and its condition. And then on the next line, we have system.out.println, the variable I, plus, which is going to concatenate the rest of the string, is less than 50. And that's the end of our code. We close the brace to end the if statement, then another closing brace for our main, and a closing brace for our class. And if this code were executed, the output would be 10 is less than 50. Let's have a look at another example if statement, this time inside of a loop. So we have the same class name, public class conditionals, and this one will count to 10, but display a result when the value of I reaches 5. So we'll print an extra notice when I reaches 5. Then inside of main, I have a for loop, for int I equals 1, while I is less than or equal to 10, I++. And inside the body of this loop, I have an if statement, if I double equal sign 5. So the condition, which requires two equal sign for a comparison to compare I to 5, and when it reaches 5, it executes the code within the braces. Now we have to be careful here. The braces for the if statement put it onto a single line. So we have an open brace, system.out.println, and in quotations we have \n, a new line character, then I is now equal to, then we end our double quotes, plus I. So we concatenate the value of I at that point, which should be 5. We put our semicolon to end the line, and then the brace appears on the same line. So that's the end of the if block. Then on the next line, we're outside of the if block, but we're still inside of the loop with a system.out.print of I plus and double quotes with a space in between. So we're printing the value of the loop followed by a space, and then the loop is closed on that line with its brace, And then we have a double brace on the next line to close the main function and the class declaration. And the output in this case will be 1, followed by a space, then 2 and 3 and 4. Then we get the new line character, I is now equal to 5. And since it's a println, it'll go to the next line and print the 5, and then continue on with a space, and then 6, another space, 7, 8, 9, 10. And that's the end of the code once it reaches 10. And that concludes this presentation on Java decision statements. In this video, I'll describe the if-then and if-then-else statements and how they're used as decision statements in Java. So an if statement gives us a conditional way of executing some block of code if the condition is true. So if a condition is true, do something. Execute a particular block of code. If it's not true, skip over it. And if we have an else condition, a type of otherwise, when a condition is false, it leads to doing something else. And these are mutually exclusive. If we have an if and else statement, then if the condition is true, the code is executed and the else statement is skipped over. And if the statement is false, the true condition block of code is skipped over and the else condition is executed. So what does this look like? Well, we have a condition. When it's true, we execute what's part of the if statements block, and then we stop, skipping over or bypassing the else statement. If the condition is false, we bypass the if statements code and execute what's in the else statement until we reach the end and stop. So what does this look like in code? Well, I have this example code that displays whether a value of I is less than or greater than 50. So in the main function, I have int I equals 40. If I is less than 50, so I less than 50 in the parentheses, that's the condition. And if that's true, and in this case it obviously is because I is explicitly set to 40, it will print using system.out.println the contents of the variable I concatenated with the string is less than 50. Then the close brace followed by the else keyword leads into the else block, which follows it in braces. So we have the open brace along with the close brace with the main statement and the public class a few lines down. But inside of this else block, the code that executes is system.out.println with the contents of I concatenated with the string is greater than 50. And if we'd run this, the output would be 40 is less than 50. Well, let's look at a modified version of the same code where I is set to 60. So the first line in the main function is int I equals 60. Then we have the same conditional if I is less than 50. The printed output is the variable I is less than 50, else I is greater than 50. And since it was set to 60, the second block of code will be executed, the else block, and the output will be 60 is greater than 50. We can expand this a little further, covering the case when I equals 50. So we can use an if, else block. So we have 3 blocks with 2 explicit conditions and 1 condition, the else condition that executes if the other 2 are false. So we can chain our if statements together using the else if. And inside the main function, I have int I equals 50. Then if I is less than 50, the I is less than 50 string is printed. At the end of that block, we have a brace and then the keyword, the combination else if together. Its conditional is I =, 50. So we use the double equal sign for comparison. So if I is equal to 50, then we print I is equal to 50. And then the else block, where I is greater than 50 is printed. And the output in this case is I is equal to 50. And that concludes this presentation on the Java if-then else. In this video, I'll demonstrate the if-then and if-then-else statements and how they're used as decision statements in Java. So I start out in this main.java file by declaring the package that it's contained in as package com.example. Then I import java.util.scanner. So this class is used to take user input, and what we'll do in this example is use that input to make a decision, to make a number of decisions, which will affect our output. Then on line 5, I declare public class main, and inside of it, I have a main method, the entry point into our application on line 7, public static void main with string double brackets args. And inside the body of this method, I have scanner input equals new scanner with system.in as its argument. So this is going to take standard input, parse the value, in this case an integer, and we'll make decisions based on it. On line 10, I have system.out.println, enter an integer is the string. And then on the next line, I have int value equals input.nextInt. So it's expecting an integer. Now, one thing I haven't done here is to check that the input is valid. You should always validate your inputs, but for the sake of this example, I'm going to leave the input validation and any exception handling needed to validate the input. So I'll expect an integer, and then on line 13, I have my first conditional. The keyword for a conditional statement is if. So if, then in parentheses, I have some code that's expected to return true or false. If it's true, then it executes the block within the braces that follows the if statement. If it's false, it skips over it and doesn't execute the block. So I have if, and then inside of the parentheses, value, and double equal sign. This is a direct comparison to check for equality. If we're doing assignment, in Java, we use a single equal sign. If we're doing a comparison, we use a double equal sign. So if value is equal to 0, or, so the or operator, the logical or, is the double pipe characters. So we put the two pipe characters, and then value, double equal sign 1. So the way we read this is if the value is equal to 0, or the value is equal to 1. If either of those conditions are true, then execute the code within the parentheses. System.out.println, you entered 0 or 1. Then on line 17, I have a different conditional. If, in this case, I have value %2. So this is value modulus 2. So this modulus operator, the percent symbol, says that if we take value, divide it by 2, and take its remainder, so the remainder of the division, if that's equal to 0, that means the number is divisible by 2 evenly. And so inside of the block, I print system.out.println, your value is even. On line 19, I do something similar, but here I'm demonstrating that you can have if blocks contained within other if blocks. So this is called a nested if. So we have an if statement. So if that's true, inside of it, we have another if block. And an important thing to remember here is that your nested if block, the if block that appears in another if block, we should always make sure that its condition is dependent on the outer if. So in this case, I say if value %4 double equal sign 0. So if value mod 4 is equal to 0, then I print and your value is divisible by 4. But if in this case I change the 4 to a 5, this wouldn't make sense because 5 is not even, and this could never be true. So that's one thing to watch out when using nested if statements. And we also have to line up our if statements. So this inner if statement is separate from the else statement that follows on line 22. So we always should line up our parentheses, and with an IDE, like IntelliJ I have here, there's a very faint line that follows from the if statement to its closing brace. And if we keep this formatting, then we can always follow visually where the indentation happens and who the corresponding blocks belong to. So this else statement corresponds to if value mod 2 is equal to 0. So if it's even, we execute the block inside. Then on line 22, the else, this means that the value is odd. If a number is not even, it's odd. So I print using system.out.println with the string, your value is odd. And I have a few more blocks to demonstrate. The next block on line 26, I have if value is greater than or equal to 1000, double ampersand. So this is the AND logical operator, which means the conditions both have to be true for the if block to return successfully, for it to execute the block. So both of these conditions have to be true. Value greater than or equal to 1000 and value less than or equal to 2000. And then inside the block, I have system.out.println. Your value is between 1000 to 2000 inclusively. So it includes the values 1000 and 2000. And on line 30, I have if value is less than 100. Inside its block, I print your value is less than 100. And then the next block is else if. So combining the two words together, else and if, with a space in between them, we can have additional block that if the first condition is false, if the if statement is false, it checks the else if. If value is greater than 100, we use system.out.println to print your value is greater than 100. And then I follow that with an else block. So we can have as many else ifs as we want, and we don't necessarily need an else at all, but if we do include it, the else will get executed if the if and the else ifs, in this case the one else if both of those are false, it will execute the else statement. In this case, it uses system.out.println to say your value is not less than 100 and is not greater than 100. So that's combining the results of those two conditions. So if a value is not less than 100 and not greater than 100, your value must be 100. So I actually print that. Therefore, your value must be 100. And that's what this condition amounts to. So I'll execute the program with Shift F10, and I'll select the output window, the run window, and I'll enter the integer 0. And it tells me you entered 0 or 1. Well, I entered 0. Your value is even. 0 is an even number. Your value is divisible by 4. That's true. And your value is less than 100. So that worked. Now, if I want to test all the branches, I'll need to keep running the program. So if I run it again, I'll test the condition for 1. And it tells me you entered 0 or 1. Your value is odd. And your value is less than 100. And now I'll run it again and enter 1000. And it tells me your value is even. Your value is divisible by 4. Your value is between 1000 and 2000 inclusively. And your value is greater than 100. And that'll conclude this demonstration of decision statements in Java using conditionals. In this video, I'll describe the switch statement and how it's used for decision statements in Java. So the Java switch case statement is a type of branching statement to execute conditional code based on particular criteria, based on a single value. And given that value, there are typically numerous multiple executing options for the Java switch case statement. Let's see how this looks visually. So given a particular switch condition, in this case a variable, we have various cases based on the value of that variable. So if the condition or the case is based on a particular value, let's say a character value, so if we have a value based on particular cases, so case A, case B, case C, they can execute individually, independently in Java, or multiple cases can execute the same code. And if all of the cases fail, we can have a default case. So this does behave somewhat like the if, else statements in Java, but the cases are more explicit based on the value and not based on a logical Boolean condition. It's also easier to have multiple cases, multiple values execute the same code, and it can be argued that the syntax is more concise. The switch case statements also make use of a break keyword. So instead of surrounding blocks in open and closed braces like an if statement, we use open-ended blocks of code that only exit when the break keyword is reached. So we have a match that's found, and to get out of a switch block, we either break or we fall through to the next result. And the break says there's no further processing needed, and we can skip past the rest of the code in our cases. But the break is optional. So if we have multiple cases, a particular case can execute some code and then continue executing the code in the next case and continue on until it reaches a break statement. So it gives you a lot more power in reusing codes either fully or partially using the switch case. So what does this look like in code? So inside of my main function in this example, I set a string I is equal to an open and close double quotes. So it's an empty string. We have a switch statement, switch I, so it's going to use the value of I to decide on which case to execute. And our first case is case with the string red, followed by a colon, and then inside of it has system.out.println, the string red, followed by the break statement. Now the break statement can appear on the same line as long as it's separated with a semicolon, or it can appear on a line by itself. Typically, we put it on a line by itself at the end of a case that we'd like to execute. Then we have case blue, which prints the string blue and breaks, and case green that prints green and then breaks. And in this case, the output is nothing because none of the cases are reached. Now, when there's no cases reached, we can also use the keyword default. So if none of the cases, like in the previous example, were reached, then we can say none of them were found, or executing whatever code we wish to handle that particular case. But this is optional. So if we have it, we execute the code. And if we don't have it, nothing is done. So it's entirely optional. So let's have a look at an example where we have the default keyword. So it's similar to what I had on the previous example code. String I is equal to the empty string. The switch is based on I. And then the case statements are case red, which will print the string red and break, case blue, which prints the string blue and breaks, and then default. So it's just the keyword default, followed by the colon, and then the code. System.out.println, no color, and in this case the break, but the break is optional if it's the last item in the switch block. So the output in this case is the string no color. Now I modify it so that one of the cases is executed, the blue case. So in my main function, I have string I equals the string blue, the switch on I, and then inside of the braces, the switch braces in the block, I have two cases and a default case. So case red, that prints red and breaks, and then case blue. So the string blue matches the string I, so that in this case it will print blue and then break. So it skips over the default case. And the output in this case is just blue. We can also use this with integer values. So I have an example here with int I equals 10, and then switching on I switches on an integer value. So the cases must use the literal values for integers. So case 5, followed by a colon, then the block that executes if I is 5, which prints I is equal to 5, and then breaks. Case 10, which is the case that will be true in this case, prints I is equal to 10, followed by the break keyword, and then default, which prints I is greater than 10. And the output in this case, I is equal to 10. But we have to be careful how we use that default case, because in this example, I changed the previous slide to set int I equals 4. I switch on I, my case 5 and case 10 are the same as the previous slide. So in case 5, I is equal to 5 is printed, case 10 prints I is equal to 10, and then the default case prints I is greater than 10. Well, that's not quite true because I is 4, and even though it doesn't match 5 or 10, the default, the actual output is wrong. So we're not using comparisons, we're not looking at a case where I is less than or greater than any of the values, it's looking at the explicit value. The output here would be I is greater than 10, maybe something more appropriate to print in this case, in the default case, would be I is something other than 5 or 10. So I've modified the example from the previous slide. I have int I equals 4, switch I have the case for 5, the case for 10, and the default case is I is not equal to 5 or 10. And that's what gets printed. I is not equal to 5 or 10 because it's equal to 4, and that case wasn't handled, so the default case gets executed correctly. And that concludes this presentation on Java switch. In this video, I'll demonstrate the switch statement and how it's used to execute conditional statements in Java. On line 1 in this example, I add the contents of my main.java to the package com.example. Then on line 3, I import java.util.scanner, which I'm going to use to get an input of an integer through the command line when the program is run. Then on line 5, I declare public class main, and in it, it has a main entry point, public static void main, with string double brackets args as its parameters. Then in the body of the main function, I have scanner input equals new scanner with system.in. So this is going to let us read from the standard input. On line 10, I have system.out.println of enter an integer. And then on line 11, I have int value equal to input.nextInt. So it's going to take an integer from the input and then execute code based on a switch statement on the value, depending on what we enter. So this will take our value and put it into a switch statement. On line 13, I have switch, and it takes a value, and then in parentheses, I need a value. So in this case, it's just the value, the integer that's entered. Then the cases of a switch statement are defined inside of the braces. So we have everything enclosed in braces, and all of the conditional statements that can be run are inside of this. On line 14, I have case, and then a value, in this case 0, followed by a colon. So the syntax is the case keyword, the value, and then a colon. And then below that, I have system.out.println with the string 0. So it's going to say that we entered 0. So everything after the case gets executed, until it reaches a break statement or it reaches the end of the switch. So in this case, I have break followed by a semicolon. So this will exit the switch statement and continue executing from line 29. Then on line 17, I have the next case, case 1, colon. And this time I print system.out.println of the string 1, followed by a break with a semicolon. On line 20, I have case 10 with a colon, and then on line 21, I have case 100 with a colon. This allows us to execute code based on multiple values. So as long as we don't see a break statement, we'll keep executing. And in this case, case 10, case 100 executes the same code. System.out.println, this will be printed for 10 or 100, followed by a break statement. Then I have case 1000 with a colon, and on line 25, I have system.out.println. This will be printed for 1000. And then on line 26, I have system.out.println of without a break. This will fall through to the default case. So there's a special keyword called default, and because case 1000 doesn't have a break statement, it just keeps executing. But in the case of default, so if none of the cases are met, so case 0, case 1, case 10, case 100, and case 1000, if none of these are met, the default case gets executed. But also because case 1000 doesn't have a break statement, it falls through and executes the default case. And all the default case does is system.out.println, this is the default case. The default case must come last, but it doesn't require a break statement because it reaches the end of the switch block. Let's try this out. I'll do Shift F10 to run the code. And the first integer I'll enter is 0. I'll go through all the possibilities. So 0, print 0. And I'll keep doing Shift F10 after each execution. I'll enter the integer 1, and it prints 1, and then 10. This will be printed for 10 or 100. So everything looks good so far. I'll enter the integer 100 this time, and this will be printed for 10 or 100. I'll run it again, and this time I'll type 1000, and it has this will be printed for 1000. Without a break, this will fall through to the default case, and it prints this is the default case. And now finally, I'll enter, let's say 99, and all this prints is this is the default case because none of the other cases are met. And that covers all of the possibilities in our switch statement. And that'll conclude this demonstration of programming Java switch statements. In this video, I'll describe the various classes and methods for comparing primitives and objects. So what are the main methods for making comparisons in Java? Well, there's the double equal sign, which is used to compare primitives in Java, the equals method, used to compare strings, and the general CompareTo method, used to make comparisons between objects, values, and when compared with strings, used to set an order between objects, not just equality, which aids in sorting and ranked comparisons. So the double equals comparison operator is primarily used for numeric values or primitive values, but it's not used for objects. It's also different than the single equals sign, which is used for assignment. So in some languages, the equals operator is used for both assignment and comparison, depending on the context. But in Java, using the assignment operator when you mean comparison is an error. So in the main function of this code, I have int I equals 5. Then if I is equal to 5, where the single equal sign is used, will result in an error. So this is a mistake. What should be done, the equal sign in Java is used for assignment, to assign a value to a variable. The double equal sign is used only to compare values. So the comparison in the code example, where we have int I equals 5, if we want to check to see if I is equal to 5, then we say if I double equal sign 5. So that's our condition that will return true or false. And in this case, it will obviously return true, and the output will print I equals 5. But we can't use it for comparing objects or comparing strings. When using objects, the double equal sign only checks whether the two objects refer to the same place inside of Java's memory. So if they refer to the same thing, not that their internal values might be the same. Inside of the main method of this example code, I have string myString1 equals the string JA, string myString2 equals the string VA, String by string3 is set equal to the string Java, and then string by string4 equals the concatenation of my string1 plus my string2. So the internal characters of my string4 will be JAVA, Java. So my string3 and my string4 have the same internal characters as their string representations. But now I have Boolean test, so test variable which will contain true or false, and I set that equal to the comparison of my string3 double equal sign my string4. And this will actually return false, because my string3 and my string4 refer to two separate instances of the memory containing the characters JAVA. So we're not testing the internal string's equality, we're testing the object equality in what it refers to. So how it internalizes those strings within Java's memory space in the JVM. Then I call system.out.println with my string3 concatenated with should be equal to my string4. And system.out.println of using double equal sign results in the concatenation of the test variable, true or false. So the output is Java should be equal to Java. Well, it should be, and in terms of the characters, they are. It's just that the variables are not equal. And using double equal sign results in false. And that concludes this presentation on Java string compare. In this video, I'll describe how the double equals operator differs between primitives and objects. We use the double equal sign to compare primitive data types. Java has 8 primitive types, and the thing about primitive types is that they can't be set to null or they can't be uninitialized. Primitive types are set to a default value of 0. In the case of a Boolean data type, a primitive Boolean, it's set to false. So the primitive data types are byte, short, long, int, float, double, char, and Boolean. So testing equality with primitives, you always use the double equal sign. And the primitives are assigned with literal values, or set to be equal to other primitives. They occupy a fixed value in memory in Java's JVM memory, and they're tested for equality using the double equal sign. But there are some exceptions. So in this example, I have double my double equals 5.0, my double plus equals 5.1, my double plus equals 5.1, and the third time, instead of having 20.3, we have 20.29999 repeating, ending with a 7. And if we test for equality using the double equal sign, we have Boolean test equality equals my double equal sign 20.1, and then we print the test equality variable, the output's going to be false. So we have to be very careful about precision. Using double equal sign with objects is looking at the object reference type. So the references can be tested for equality if two variables refer to the same type or same memory, but it must be the same object in memory. The objects being compared with double equal sign cannot be compared in terms of their internal values using the double equal sign. For that, the dot equals method or the CompareTo method must be used. And that concludes this presentation on Java comparisons. In this video, I'll demonstrate how the double equal sign, the equality operator, differs between primitives and objects. I'll start in this example code by creating an object called thing. I'm in this file called thing.java. I add it to the package com.example. I declare it as public class thing. And then on line 4, inside of thing, I have private int value. So it has a single property. It has a getter and a setter. So on line 6, I have public int get value that returns value. And on line 10, public void set value that takes int value and sets this dot value equal to value. I also implement an equals method as public boolean equals, which will return true if the values are equal and false if they're not. And it compares a second object, thing O, as its parameter, and then it returns this dot value double equals O dot value. So it's going to do a comparison between the int values, the primitive values that are contained within the two objects. Then in main.java, I add this to the package com.example. I import java.util.scanner because we're going to enter some inputs. I declare public class main, and then the main function public static void main of string double brackets args. Then inside the main method, I have scanner input equals new scanner with system.in, so we can read from the standard input. On line 10, I have system.out.println, enter a string, then string A equals input.nextLine. So we're going to read the input up until the user hits return and store it in A. On line 13, I have system.out.println, enter another string, then string B equals input.nextLine. On line 16, I print the comparison of the strings using the double equal sign. Now, when dealing with strings, this is not the way to compare their values. This is how we compare the objects to see if string A, the variable, was assigned to B or B was assigned to A. So the only way this is true are if the objects are the same object. If they have the same string values, this will be false. Then I take two integers as input, so I print enter an integer with int x equal input.nextInt, so it's going to expect an integer input, then enter another integer, int y equals input.nextInt. Then I print the comparison of x and y, so system.out.println of int x equal to int y. So I have in parentheses x double equals y. So we're comparing the primitive values. So with primitive types like int, boolean, float, double, short, etc., these comparisons actually compare the values because we're not dealing with objects, we're dealing with primitives. Now let's look at our custom object. I have thing u equals new thing, and then u.setValue x. So it's going to set the value of thing u to x, and then thing w equals new thing, followed by w.setValue y. So it's going to take the previous inputs and use them to create our thing objects and set their values. On line 33, I have system.out.println thing u double equals thing w. So we're doing a comparison, u double equals w. So it's looking at the equality of the objects. What we probably want is a comparison of the value. And for that, I can print my u.equals w, so the result of that, to actually compare the values contained within thing u and thing w. So when are these objects the same? Well, they're only equals using the comparison operator, the double equal sign, when the objects are the same. So anytime we have u equals w or w equals u, or some way of assigning the objects so that they're pointing to the same objects, then it will be true. So I print after setting u equals w, we check the equality u double equal sign w. So now let's run the code. I'll do Shift F10. For the first string, so enter a string, I'll type hello. The second string, hello again. They're identical in every way, but string A is not equal to string B. That returns false. Now, if I enter an integer, let's say 1, and then a second integer 1 again, so they're both the same value, if I compare int x and int y, well, it returns true. But using those values to set the values of thing u and thing w, and then comparing thing u to thing w, it returns false, even though u.equals w is true. So then after setting u equal to w, I check the equality of the objects u and w, and then that returns true. So it takes a little bit more to have equality between objects, and they're only equal when they're the same object, not just when their values are the same. And that concludes this demonstration of programming Java comparisons. In this video, I'll describe the differences between the equals method and the double equals operator in Java. And I'll explain some confusing results you might see and why things work a certain way. So I have an example of comparing strings using the double equal sign. And if you're comparing the contents of the string, you should never use the double equal sign. This is only for comparing the objects and checking to see that the object references refer to the same object. So in the main function of this example, I start with string mystring1 equals the string JA. String mystring2 equals VA. String mystring3 equals the string Java. And now I do a system.out.println of mystring1 double equal sign JA. Well, we assigned mystring1 to JA, and we're comparing it to JA, but we're comparing the object references. The internal object created by JA as the literal string I've typed into this comparison, and the variable mystring1 and what it refers to in memory, which contains the characters JA. But here it returns true. And if we're comparing the objects, how can this be the case? the Java compiler takes the instance of JA and sees it twice, so it combines those two literal strings to be the same in memory. So the literal string typed into this comparison and the literal string that we assigned to myString1 gets put into the same place by the compiler because it sees a literal string, and instead of storing it twice, it saves memory and stores it once. So the variable and the string refer to the same location in memory, so it returns true. And the same goes for myString3 Java. However, if we take myString1 and we concatenate myString2, making the internal representation of what's returned, the string that concatenation returns, to be JAVA, to be Java, and we compare that to the literal string Java, this will return false, because the concatenation and the literal string refer to two different places in memory. The objects refer to two different things. And this confusion, you might say strange behavior, although it can be explained, it also motivates us to avoid using the double equal sign when we're dealing with string objects. Let's look at another similar example. In the main function, I set myString1 equal to JA, string of myString2 equal to VA, string myString3 equals Java, and string myString4 equals the concatenation myString1 plus myString2. So the internal contents of myString3 and myString4 are the same, but their memory locations, what they refer to, is not. So when we do system.out.println of using double equal sign, comparing myString3 and myString4 with double equals, this is going to return false, even though their internal values are the same. What we need to use when comparing string values is the equals method. So this is a method of the object class that gets inherited by string and many other classes to compare the contents of the objects. And it's for testing the content equality and not the object reference equality. So here we can see the entire thing highlighted. In the main function, the first three lines are the same as my previous code example. myString1 is JA, myString2 is VA, myString3 is Java, and myString4 is the concatenation of myString1 and myString2. So its internal contents are also Java, just like myString3. Then when comparing the objects, myString3 double equals myString4, it returns false even though their contents are the same. The objects are different. But when we compare the contents, we use myString3 dot equals myString4. So using equals results in true. And that's what we get for the output. Using double equals results in false, and using equals, the method, results in true. And we'll have a look at one more example. So I set up the variables the same as I did in the previous example. myString1 is JA, myString2 is VA, myString3 is Java, and myString4 is the concatenation of Ja and Va, making Java. So I create a variable called test as a Boolean. So I have Boolean test equals myString3 dot equals myString4, which returns true. Then I print myString3 plus should be equal to plus 4. So we concatenate the string, which will give us Java should be equal to Java. And then using equals results in the result of test, which in this case is true. So the output is Java should be equal to Java, and using equals results in true as expected. And that concludes this demonstration of the differences between the equals method and the double equals operator. In this video, I'll describe the difference between equals, the method, and the double equal sign operator in Java. So the equals method, in the case of a string, is used for comparing the values of the string. The equals operator, the double equal sign, when comparing objects, are to test whether the objects themselves are equal, whether they refer to the same object, and not the actual contents of the objects themselves. So in this main.java file, I start by putting it into package com.example, and on line 3, I import java.util.scanner so that we can take the input of the strings from the command line. So we'll actually type in the inputs and compare them. On line 5, I create my public class main, and on line 7, I have my main entry point, declared public static void main, string double brackets args as its parameter. And then on line 8, I create scanner input equal to new scanner, system.in as its argument. So we're reading from the standard input. On line 10, I have system.out.println, enter a string, then string A equals input.nextLine. So the string we enter, followed by the return or enter key, will capture the input for A. Then I do the same thing. Then I print enter another string, followed by string B equals input.nextLine, capturing the input of a second string. Then on line 17, I have system.out.println with string A equal == string B, and then I concatenate in parentheses A == B. So I'm comparing A to B, but the comment I have on line 16 says this compares the objects, not the contents of the string. So the only possible way of A == B using the operator for this to be true is if at some point A is set equal to B is assigned to B, or B is assigned to A. Otherwise, even if we enter the same string values, this will never be true. If we want to compare the string for equality that returns true if they're equal and false if they're not, I have to use the equals method. And that's what I do on line 20. Boolean r equals, the variable name, equals a.equals b. So I pass b as its argument. On line 21, I have system.out.println with the literal string are the strings equal plus r equal. So I output the contents of the variable, which will show us true or false. So I'll use Shift F10 to run the code. I'll enter the first string. I'll put in the string hello. The second string, I'll make it identical with hello, and they're both in lowercase. So it's important that they're the same case, otherwise they won't be equal. And in this case, string A equal string B is false, so the objects are different. And are the strings equal? Well, that's true because they're identical. If I do something such as hello with a capital H, so leading with an uppercase H, and then hello all in lowercase, in this case, well, string A and string B are still false, and they'll always be false no matter what we put in. And are the strings equal? In this case, no, they're not, so it returns false. And that concludes this presentation on comparing the equals method with the double equals operator. In this video, I'll describe the use of the Java CompareTo method. So the Java CompareTo method is quite often used with strings for a lexicographic comparison, an ordered comparison, which comes first and which comes second when compared lexicographically or alphabetically. Now, the reason why we say lexicographic is because we're doing a Unicode value of characters comparison. And the way the method works is it returns less than 0 if the string you have is less than the one you're comparing to. So if it comes before it, it returns greater than 0 if your string is greater than the one you're comparing it to. So if it comes after it lexicographically. So what does this look like? Well, let's take two strings. In this example code, in the main function, I have string mystring1 equals JA and string mystring2 equals VA. And then I print using system.out.println CompareTo value is, and I concatenate the result of mystring1.compareTo mystring2 as its argument. And the output of this is CompareTo value is -44. So it computes the difference between the two strings. In this case, the difference between the character J, the uppercase J, and the lowercase v. And since it's negative, that means mystring1 comes before mystring2 when considered lexicographically. What if the strings are equal? Well, in this case, I have string mystring1 equals Java, string mystring2 equals Java, and the CompareTo value of mystring1.compareTo mystring2, the value is 0. So when they're the same, it returns 0. Let's have a look at how lowercase and uppercase letters compare. So I have string mystring1 equals Java with an uppercase J and lowercase AVA. String mystring2 is equal to Java all in uppercase, so uppercase JAVA. And the result here of system.out.println with the string CompareTo value is mystring1.compareTo mystring2, the value is 32. And this value means that mystring1 comes after mystring2. And the reason for this is that the uppercase letters come before the lowercase letters. So the comparison here is between the first A in Java, so the uppercase A and the lowercase a. And the difference, the numeric difference in terms of its Unicode value between uppercase A and lowercase a is 32. So it only needs to compare the first two characters to determine which one comes first and what the value of the comparison is. What happens if we have the same strings but in different orders? So the same characters, so it has nothing to do with the value of all of the individual characters. It's only the individual characters that come first. So in this example, I have string mystring1 equals Java space coding and string mystring2 equals coding space Java, with everything in lowercase except for the uppercase J on Java. So the CompareTo value of mystring1 dot compared to mystring2 in this case is -25, the difference between the uppercase J and the lowercase c. That's the only comparison needed to determine the value of the CompareTo. So the first difference in the string gives us our value. If there are no differences, it returns 0, meaning the strings are the same. And that concludes this presentation on the Java CompareTo. In this video, I'll demonstrate how to compare using the Java CompareTo method and how to interpret the results. So CompareTo is an ordered comparison. You're not just comparing two items and getting a result that says if they're the same or not, so a binary true or false. You're actually getting some extra information about the order of the items. When using a string, the CompareTo is for lexicographical order, or more commonly known as alphabetical order. Let's start in the example code I have here in main.java. On line 1, I include package com.example to give it a package, and then on line 3, I import java.util.scanner so we can get some input, and in this case, we're going to input two strings and compare them. On line 5, I declare my class, public class main, and the main entry point to the application, public static void main, string double brackets args, the common Java entry point. On line 8, I create my input scanner, scanner input equals new scanner, with system.in as its argument, so that we can read values from the standard input. On line 10, I have system.out.println, enter a string. On line 11, string a equals input.nextLine, so we can type in some characters, hit enter, and it will accept that as string a. On line 13, system.out.println of enter another string, then string b equals input.nextLine to get the second string. On line 16, I have a value int string order equals a.compareTo b. So a is a string with a CompareTo method that takes an argument as another string. Its return value is an integer. Using the equals method, it will return a binary true or false to determine whether the values of the strings are the same or not. In this case, it returns 0 if they're the same. If the string order is less than 0, that means string A comes before string B when talking in alphabetical terms. And if string order is positive or greater than 0, then that means B comes before A when we're talking alphabetically. So on line 17, I have if string order is equal to 0, I print the strings are equal. Else if string order is less than 0, then I print string A, so I show the contents of A surrounded in single quotes comes before B, with string B surrounded in single quotes. Else if string order is greater than 0, then string B comes before string A. I'll type Shift F10 to run the code, and I'll enter the first string. I'll type hello, enter. The second string, hello. So these are the same, and it's important that they're of the same case. So they're both in lowercase, and it gives me the strings are equal. And why that's important, if I run it again and enter hello with a capital H, so capital H-E-L-L-O, and then hello with a lowercase h, and it tells me string hello with a capital H comes before hello with the lowercase h. So the uppercase letters come before the lowercase letters. So if you're sorting something and we come upon a word that's spelled the same but different in case, then the one with the uppercase will come first. Now I'll run it again, and this time I'll just hit enter. So if we enter a string using the input scanner and we just type enter, it actually stores an empty string. I can also put a space in, so the second string I'm going to put a space. So I'm going to compare an empty string to a space. And it gives me string, double single quotes, so there's nothing in between. So the empty string comes before the string with a single space. So the empty string will always come first when we're talking alphabetically or lexicographically. Let's compare something else. Let's look at a string that's just the character A compared to a number. So the number 1 in this case is not an integer, but actually the character 1. So what comes first, the A or the 1? And when compared lexicographically or alphabetically, the character 1 comes before the character A. And we're dealing with numbers. The number 0 comes first, and the numbers appear as strings in the order you'd expect. So 1 comes before 2, etc., all the way to 9. And that concludes this demonstration of programming with the Java CompareTo method. So in this course, we've examined various types of Java decision statements. We did this by exploring Java decision statements, programming Java if-then else, and switch statements, Java string comparison operators and methods, programming Java equal and CompareTo operators. In our next course, we'll move on to explore ways to create loops in the Java program.
Sooner or later, you'll find yourself in a situation where you have to execute a particular block of code multiple times. Maybe it's because you want to process a bunch of items in a list, or maybe it's because you want to search for something in a list. Whatever your reason, the way you'll do it is by executing a looping statement. Now in Java, there are 3 main types of looping statements. The for loop allows you to execute a loop based on indexes, conditions, or lists. The while loop allows you to perform a loop for as long as you deem necessary. And a do-while loop allows you to perform a loop for as long as you deem necessary, but it will always execute at least once. Now all loops in Java are based on a condition. We don't want loops to execute forever, we want them to execute a logical number of times. So the most important aspect of any loop is to devise a condition. Now to make this a bit easier to understand, let me explain how a loop works by using this flowchart. In this chart, the loop starts right at the top where it says start. Immediately the loop checks the condition. Now that condition could be anything. It could be whether you want a certain count, it could be a time of day, it could be whether something is orange or not. Whatever the condition, it will return a true or a false. As long as the condition returns true, the loop will continue. So when the condition is true, the loop will execute the code statements contained in that loop. Now if the condition ever returns false, then the loop will stop. Okay, so we understand loops in general, but why are there so many different kinds of loops? Well, it kind of depends on the specific work you're trying to do. By far the most common type of loop is the for loop. Like any other loop, a for loop executes code statements that are contained inside that loop. And it will execute those code statements repeatedly, over and over and over again. And it will do that as long as the defined condition is met. But the trick with a for loop is that you need to set an iteration parameter, create a condition, and then provide an iteration command. The most common strategy for a for loop is to set a count for the number of times that you want to execute the loop. And with each iteration of the loop, the current count is incremented. The condition is just that the current count is less than the total number of times that you want to execute the loop. Now, less common than a for loop, but still very common, is the while loop. And just like the for loop, while loops execute the code statements that are contained inside that loop. The difference between a for loop and a while loop is that a while loop will execute for as long as a given condition is true. You don't need to specify an iteration parameter or give any incrementation logic. It just executes as long as the given condition is true. The important thing to remember about the condition is that it's tested inside the definition of the loop. Well, more appropriately, it's tested first before the statements in the loop are executed. Then, with each iteration of the loop, the condition is tested again. A common reason to execute a while loop is simply because we don't know how many iterations it will take to perform the task that we want to do. So for example, imagine we wanted to know how many times we can divide a user-provided number by 2 until we get an answer of less than 1. So our condition would be true for as long as the answer is greater than 1, and we simply don't know how many times that'll take. Now there are actually 2 flavors of while loops. The other flavor is the do-while loop. A do-while loop is very similar to a while loop. Actually, it's exactly the same as a while loop except for one crucial difference. The difference is that do-while loops test its condition after executing the code statements inside the loop. And what that means is that a do-while loop will always execute at least once. So the code in the loop is executed and then the condition is tested. So why would we do that? Why would we ever execute a do-while loop if it means that we'll run the loop once? Well, one scenario I've seen used is for something like initiation. Imagine you wanted to establish a connection to something. You'll want to execute the connection command and then, if it fails, keep trying until it works. So the condition is true as long as the connection is not established. In Java, there are a few different kinds of loops. Now, which kind of loop you'll use is going to be dependent on the type of work that you're doing. But by far the most common type of loop is the for loop. Like any other loop, a for loop repeatedly executes code statements that are contained in that loop. Now, how often the loop executes is based on an iterator and a condition. Now, every single time the loop executes, including the very first time, it will evaluate the condition to decide whether or not to keep going. If the condition is met, meaning if it returns true, then the loop continues on. However, if the condition is not met, meaning it returns false, then the loop terminates. The most common strategy for a for loop is to set a count for the number of times that you want to execute the loop. Now, with each iteration of the loop, the current count is incremented. And the condition is just that the current count is less than the total number of times that you want to execute the loop. Now let me explain how a for loop works by going over this flowchart. When Java encounters a for loop, it will start the process of iteration. And the very first thing Java will do is evaluate the condition. Now if the condition is true, then the code statements are executed. If the condition is false, then the loop immediately terminates. But it's important to understand that the condition is evaluated before any code is run. And that means that the condition can return false immediately, and the contents of the loop will never execute at all. Now, how do we build a for loop? How can we make one work? Well, let's take a look at an example of what the syntax for a for loop would look like. What you see here is how the code for a for loop is laid out. Now first we tell Java that we're executing a for loop by typing the word for. Then in round brackets we specify the conditions. Now it's important to see that the conditions for a for loop are actually broken down into three parts: the initialization, the condition, and the increment. And notice that they're separated by semicolons. The initialization is run when the loop first starts, and it's used to initialize incrementation variables. The condition is run at the start of each iteration, and it decides whether an iteration should happen at all. And the increment runs at the end of each iteration. It's usually used to increment the variable that we initialize, and I'll show you how that works in a second. Then, for a for loop, you add squiggly brackets and then put whatever code you want to loop over inside those brackets. Now technically, if your for loop only has one line of code, you don't actually need the squiggly brackets. But it's a best practice to always use those brackets, so it's best to get into that habit. So let's go over a few examples and see this in action. Alright, so here's an example of the most basic and simple for loop that you can have. In this code, we've created a simple class with a static main method. And all that means is that when the Java project runs, this class will run right away. Now inside the main method, we can see a for loop. That loop has an initialization that says int I equals 0. And that means that there is now a variable called I that has been set to 0. And after that, we can see the condition, and that it's been set to I is less than 10. And this means that the for loop will execute for as long as the value of that variable I is less than 10. And since we set it to 0, we know that this loop will execute at least once because 0 is less than 10. Now after that, we see the increment, and it's been set to I++. Now what this means is that every single time this loop executes, we'll increment the value of I by 1. So if you put all that together, you can see that we're setting a variable to 0, incrementing it by 1 with each iteration of the loop, and then terminating the loop once that variable hits 10. Then, inside the for loop squiggly brackets, we have the code that will be run each time the loop runs. In this case, we're using a simple print line command to output the value of our initialization variable to the console. Now remember that we initialize a variable to the number 0. So that means that the first iteration of the loop will see the value being equal to 0. And then we increment that variable with each iteration. And importantly, the condition allows the loop to run so long as it's less than 10. So that means the loop will run 10 times, and the value of I will be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, but not 10. Now this strategy is by far and away the most common looping strategy. A simple int I equals 0 and an I++ are the most obvious and common implementations of a for loop. Of course, just because something is common, it doesn't mean it's the only way to go. So let's go over another example so you can see what I mean. Now let's imagine a scenario where you wanted to iterate over every second item in a list. Well, in that scenario, you'll set up the loop the same fundamental way. We'd still initialize our variable to 0, and we'd still set up our condition to execute as long as we're less than a certain number. Now where it changes is the incrementer. Now in this example, we set the initializer to 0 and we set the condition to run as long as that variable is less than 20. But then in the incrementer, we increment that variable by 2 using the I plus equals 2 syntax. Then inside the for loop squiggly brackets, we have the code that will run each time the loop runs, and it's another simple print line command to output the value of our initialization variable to the console. Now once again, remember that we initialized the variable to the number 0. And that means the first iteration of the loop will see the value being equal to 0. And then we increment that variable by 2 with each iteration. And since our condition allows the loop to run as long as it's less than 20, that means the loop will be run 10 times, and the value of I will be 0, 2, 4, 6, 8, 10, 12, 14, 16, and 18. But again, not 20. Now it's also important to understand that we can also use our incrementation variable from anywhere inside the for loop. So let's go over an example to show you what I mean. In this example, we define an integer variable outside the for loop and call it add, and we initialize it with a value of 10. Then we create a for loop that starts at 0 and runs as long as the I variable is less than 10 and increments that I variable by 1 with each iteration. So we can tell from this definition that the loop will run 10 times. Then inside the loop, we add the current value of I to the add variable and then print that out to the screen. Now notice that we're using the plus equals syntax again. That means that we're changing the value of the add variable every run of the loop. So let's figure out what that means. Well, in the first run of the loop, the add variable is set to 10 and our I variable is set to 0. Add those two and we're still left with 10, so the number 10 is output to the console. Now in the second run, the add variable is still 10 and our I variable is now set to 1. If we add those two, then we have 11. And on the third run, the add variable is now 11 and our I variable is 2. So adding those, we get 13. And on the fourth run, the add variable is now 13, our I variable is 3, and combined there's 16. And on it goes as we get 20, 25, 31, 38, 46, and 55 as our outputs before we reach the point where our condition tells the loop to stop. Now it's important to note that in Java, there's the concept of scope. Our variable I is defined as part of the for loop, so it can only be used inside the for loop. If you were outside the for loop and tried to access the value of I, Java would break and not know what you're actually talking about. In this demo, we're going to look at creating a simple for loop in Java. We'll use a simple iterator to count to 10 and output the value to the console. Now to do all that, we're going to create a project in Eclipse. Alright, so as I said, we're going to use the free Eclipse IDE in this demo, but you can use any other kind of Java IDE and it'll work equally fine. Anyway, let's go ahead and open the Eclipse IDE now. Okay, so the first thing we're going to want to do is create a new project. In Eclipse, that's as simple as opening the File menu, selecting New, Java Project. Now when you create a project, you need to give it a name. So for the sake of this demo, I'm just going to call my project Demo12. Now, for loops have been around since the inception of Java, and they're super common, so there's nothing special beyond setting the name that we have to do. So let's just leave all the defaults as they are and click Finish. Good. Now it asks us for a module name. Now, this isn't super important for what we're trying to do in this course, so let's just leave this as the default and click Create. Perfect. Now our project is created and we're just about ready to get started with for loops. Before we can actually start coding with for loops, we need a file to code in. So let's go ahead and do that. First, let's close the module tab that opened up on our screen. Alright, now in order to be able to play with code, you first need to have an entry point into this project. So let's do that by creating a main class. Now from the File menu, let's select New Class. Perfect. Now in the pop-up, we're being asked for information about our class. Now the source folder and package are pointed to the root of our project by default, and that's fine for our purposes. But let's give this class a name. In this case, let's call it main with a capital M. Now we'll leave the modifiers, the superclass, and interfaces as the defaults. But let's make sure that we check the public static void main method stub checkbox. And let's leave all the others unchecked. And good, now let's click Finish. Excellent, we have our class. And now we're finally ready to get started. So let's start by creating a list of things. In fact, our list of things will be colors. So on line 6, let's replace the comment with this code. String with a capital S, open and close square brackets, space colors, space equals sign, space, open squiggly bracket, double quote blue, close quote, comma, space, double quote, white, double quote, comma, space, double quote, red, double quote, comma, space, double quote, green, double quote, comma, space, double quote, yellow, double quote, comma, space, double quote, orange, double quote, end squiggly bracket, and semicolon. Good. Now we have a list of colors: blue, white, red, green, yellow, and orange. So what we want to do next is create a loop that will iterate over all the items in that list and output the results to the console for us to see. In fact, let's do that. Let's drop a couple of lines down from our list and type the following code. For, open bracket, int, space I, space equals, space 0, semicolon, space, I, space less than symbol, space colors, dot length, semicolon, space I plus plus, end bracket, and the squiggly brackets. Perfect. Now what this code is telling Java is that we want to execute a for loop. Now the first part of the for loop is an iteration variable that we've called I, and we've set it to 0. Then we specified a condition that tells the loop to keep iterating as long as our I variable is less than the total number of items in our colors list. And the last part of the loop definition tells Java to increment our I variable by 1 every time the loop executes. The result is that this loop will execute as many times as there are items in our colors list. Okay, so let's output the colors to the screen. Now inside the for loop, let's type the following code. System.out.print, open bracket, colors, open square bracket, I, close square bracket, space plus space, double quote, space, double quote, end bracket, semicolon. Good. Now what this code is doing is it's calling our colors list with an indexer equal to our I variable. In the first iteration of the for loop, the I variable is set to 0. And so that means that it'll access the first item in the colors list. Then in the second iteration of the loop, the I variable is set to 1, which means that it'll access the second item in the colors list. And the color value at each iteration is then output to the console using the system.out.print command. Now, I've added a space here so that we can see each color in the console separated by a space. So let's see this in action, shall we? First, we save the file using the Control-S command. And now we can execute the project by using the Control-F11 command. Wow, excellent! So now we can see in the console log at the bottom of the screen that we're successfully outputting each color in the same order as the list. Nicely done. But let's do something a little bit different. Let's process the items in reverse order. First, let's make sure the console sees this as a new line. So let's add the following code directly after our for loop. System System.out.println, open bracket, double quote, close bracket. And don't forget that semicolon. Now let's add another for loop directly below that println command. So let's type the following code. For, open bracket, int, space I, space equals, space colors, dot length, semicolon, space I, space greater than symbol, space 0, semicolon, space I, minus, close bracket, and the squiggly brackets. Now what this code is doing is it's setting our iterator value to the size of our colors list. Then the condition says that the loop will execute for as long as the variable is greater than 0. And finally, the iteration variable subtracts 1 from the I variable every time the loop runs. So our first loop counted up from 0 to the size of our list, but this loop will count down from the size of our list to 0. So let's output the colors to the screen. Now inside the new for loop, let's add the following code. System.out.print, open bracket, colors, open square bracket, I, space minus, space 1, close square bracket, space plus, space double quote, end bracket, and don't forget that semicolon. Now this code is outputting the color to the console just like our last loop. But the difference here is that we have to add a -1 to the indexer. Now the reason for that is because indexes in Java are all 0-based. When we set the I variable to the size of our loop, we're actually setting it to a value of 6, the size of our list. But that's not a real index, because the 6th item in the list is actually at index 5. So that's why we have to subtract 1. So let's see this in action. Let's save the file and run the project. Nice! Now we're seeing our list of colors in reverse order. Nice job! Now in Java, there's the option to use an enhanced kind of for loop as well. Sometimes people even call it a for each loop. Now, enhanced for loops have been around since about version 5 of Java. Now the best part of enhanced for loops is that it's a very simple method for iteration. The idea behind enhanced for loops is that you can give them a list, like an array, and then they'll automatically iterate over each item in the list without you having to specify iteration variables, conditions, or an increment. Now, as I said, enhanced for loops are really simple to use. All you have to do is specify the list you want to iterate over and a variable that you want each item in the list to be associated to in each iteration. Now, what that means is that these loops are super rigid. Remember that a regular for loop needs you to specify the iterator, the condition, and the increment. Then, if you wanted to access an item in an array, you'd have to use the iterator as an index. So that's a bunch of moving parts that are handled for you automatically by Java with enhanced for loops. And that means way less room for error. Now, that being said, the main thing to remember is that enhanced for loops are used for arrays or lists of things. They can't be used for anything else or really in any other way. Now, with enhanced for loops, the process is quite simple. You give it a list of some kind and it will step through the list for you, one by one. Every item in the list will be iterated over for you to run whatever code you wish. Now, the order of the loop is also fixed. It will always go first to last. You can't specify jumps, and you can't go in any different order. Certainly you can manipulate the list or do fancy things in the code to achieve that if you want to, but the actual definition of the loop means that the list is processed one by one, first to last. But the big advantage of the enhanced for loop is that there's no need for an index. You give it a list and it populates a variable with the item being iterated over. So, how do we build an enhanced for loop? How can we make that work? Well, first let's take a look at what the syntax of an enhanced for loop looks like. What you see here is how the code for an enhanced for loop is laid out. First, we tell Java that we're executing an enhanced for loop the same way that we tell it that we're executing a for loop, by typing the word for. Then, in round brackets, we specify the details. Now, it's important to see that the details of an enhanced for loop is actually broken down into two parts, a variable and a list. And notice how they're separated by a colon. The variable is processed at the start of each iteration. So on the first run, the enhanced for loop looks at the given list, and populates the variable with the very first item in the list. Then, on the second run, the enhanced for loop looks at the given list and populates the variable with the second item in the list. And it keeps doing that until there are no more items in the list to process. Now, importantly, that means that if you give the loop an empty list, it won't do anything at all. Then, just like the regular for loop, you add squiggly brackets and put whatever code you want to loop over inside those brackets. Generally, you then access the variable from the loop definition to do whatever you need to do. So let's go over a few examples to see this in action. Now, in this example, we create an array of integers that we call numbers. Inside that array, we see the numbers 13, 30, 47, 72, and 99. Then, below the array definition, we create an enhanced for loop, and we pass in our numbers list. We also create an integer variable called number before the colon. So what this means is that every time the loop iterates, the variable called number will be set to the next value in our numbers array. Now meanwhile, inside the loop we have a simple print line command that outputs the value of the number variable to the console. So the first iteration of the loop would see the number variable being set to the first value in the numbers array, 13. Then the next iteration would see the number variable being set to the second value in the numbers array, 30. And this would continue until there are no more items left in the array to process. And finally, let's go over one more example. It's important to understand that the enhanced for loop can go over any list. It doesn't have to be just numbers. In this example, we've created a simple list of strings. Each entry in the array is a breed of dog: retriever, terrier, chihuahua, and bulldog. Then we set up an advanced for loop, and this iterates over the list of breeds and puts each value into a string called breed. And then that value is output to the console. So the result is retriever, terrier, chihuahua, and bulldog. Pretty easy, isn't it? Well, that's why they're enhanced for loops. In this demo, we're going to implement an enhanced for loop in Java. Specifically, we're going to output the contents of a list to the console without the use of an iterator variable or conditions. To do all that, we're going to piggyback off our previous demo which we built in Eclipse. So let's head over to the Eclipse IDE now. Alright, so I already have our project open from the previous demo. Now if you don't, go ahead and open the project now. And let's get back to our main class if you haven't, and you can do that by double-clicking on the main.java file in the Package Explorer panel on the left-hand side of the screen. Okay, so in our last demo, we created two for loops to iterate over a list of colors that we also created. The first loop iterated over the list in forwards order, and the second iterated over the list in reverse order. In both cases, we needed to specify an iteration variable, a condition, and then an increment. And then we needed to access our array of colors by using an indexer. It was relatively simple, but it's also a bit tedious and inconvenient. In this demo, we're going to simplify the process by using an enhanced for loop. Okay, so the first thing we're going to want to do is drop down a couple of lines from our last for loop and add a line of code to put a break in the console. So let's type system.out.println open bracket, double quote, close bracket, semicolon. Good. Now let's create an enhanced for loop. We can do that by typing the following code. For, open bracket, string with a capital S, space color, space colon, space colors, end bracket, and then the squiggly brackets. Perfect. So what we've done here is we've created an enhanced for loop that iterates through all of the items in the colors list that we created in our last demo. Now during each iteration of the loop, the current item being processed, that is, the current color, will be placed into the variable that we've called color. Now inside the loop, let's type the following code. System.out.print, open bracket, color, space, plus, space, double quote, close bracket, and don't forget that semicolon. Good. Now what this code is doing is it's outputting the value of the color variable to the console, along with a space at the end. So let's see this code in action, shall we? Let's save the file with a Control S, and run the project with a Control F11. Awesome! Now we're seeing our list of colors in the console at the bottom of the screen, and that's great. And notice how they're in the same order as the list we gave. That's important because it shows that the enhanced for loop always runs first to last. So we can see from the code that iterating over an array of items is a lot easier with an enhanced for loop than it is with a regular loop. But what if we wanted to iterate over our list in reverse order like we did with the regular for loop? We've just said that an enhanced for loop can only iterate first to last. So that means that we'd have to manipulate the list outside of the loop. So let me show you. First, we need to import a few packages. So at the top of the code between the package definition and the class definition, let's add these 3 lines of code. Import space java.util.arrays with a capital A, semicolon. Import space java.util.collections with a capital C. And then import space java.util.list with a capital L, and don't forget that semicolon. Good. Now these packages will give us access to some tools that we need to manipulate our colors list. Now back inside the main method, let's drop down to the next line after our enhanced for loop and add a print line statement to help separate our console output. System.out.print open bracket, double quote, close bracket, and of course the semicolon. Good, and now let's begin. The first thing we want to do is create a new list so that we don't hurt our existing list. So let's type the following code. List less than string with a capital S greater than space colors 2 space equals space arrays with a capital A dot as list with a capital L open bracket colors dot clone open close brackets and then close bracket, and of course don't forget that semicolon. Fix the typo. There we go. Nice. Now what this code is doing is it's creating a whole new list object, an actual list object in this case, and its initial value is set to the contents of our existing colors. Now we're cloning the array so that we don't affect the original list. Now we've named the new list colors2. Now in the next line, let's type the following code. Collections with a capital C dot reverse open bracket colors2 close bracket and the semicolon. Now what this code is doing is it's taking the contents of our new list and reversing it. Now let's create an enhanced for loop to iterate over the new list. Let's type the following code. For open bracket string with a capital S space color space colon space colors2 close bracket and then the squiggly brackets. Nice. So this is just like our other enhanced for loop, except it's iterating over our new list. So let's add the console output line inside the loop. Let's type system.out.print open bracket color space plus space double quote end bracket and of course the semicolon. Perfect. Now we've created a new list from our first one, we've reversed it, and now we're iterating over the contents of that list. It's still first to last, but the list itself has been reversed. So let's see it in action. Let's save our file and run the project. Very nice! We're seeing a reversed list. Excellent job. In Java, another kind of loop that you can implement is a while loop. While loops repeat forever as long as their condition remains true. So it's not based on an iterator like a for loop or list like an enhanced for loop, but rather just an arbitrary decision as to what condition allows the loop to stop. Importantly, like the for loop, the condition for a while loop is tested inside the definition statement, or more accurately, it's evaluated before the loop is entered. To illustrate how a while loop works, consider this flowchart. In Java, when the while loop is encountered, the first thing that happens is that the condition defined in the while loop is immediately evaluated. If the condition is false, the loop immediately terminates. Importantly, that means that the condition can be false right away and the loop never actually executes at all. However, if the condition is true, then the loop will continue and all the code statements inside that loop will be executed according to whatever logic and testing statements that you've defined. So, how do we build a while loop? How can we make that work? Well, let's first take a look at what the syntax of a while loop looks like. What you see here is how the code for a while loop is laid out. First, we tell Java that we're executing a while loop by typing the word while. Then, in round brackets, we specify the conditions. Now, it's important to see that the conditions of a while loop are actually just a single statement. Now, you may have multiple conditions in that statement, this and that, or this or that, but the important part is that the totality of the conditions need to return true or false. And I'll show you how that works in a second. Then for a while loop, you add squiggly brackets and then put whatever code you want to loop over inside those brackets. Now technically, just like a for loop, if there's only one line, you don't need the squiggly brackets, but it's best practice to always use those brackets, so it's best to get into that habit. So let's go over a couple of examples to see this in action. Now, before we get too deep into while loops, it's important that we explain one of the real dangers of a while loop. To illustrate, consider this example. In this code, we create a variable called I and we set its value to 0. Then we create a while loop and set the condition so that it will execute for as long as the I variable is less than 10. Now, inside the loop, we simply output the value of the I variable to the console. Seems pretty normal, right? In fact, astute observers will note that this is a lot like a for loop, except for one crucial problem. The I variable is never incremented. But why is that a problem? Well, it means that the I variable is set to 0 and never changes. And that means that it's always less than 10. And that means that the while loop will execute forever. And that's dangerous. If a while loop executes forever, it's called an infinite loop. And infinite loops are dangerous to the systems that they run on, because they'll continuously take up compute power or even memory. If left unchecked, an infinite loop can starve your system of needed resources and eventually result in system crashes. So what you want to do with a while loop is be very careful to make sure that there's a clear condition under which it will end. In fact, if we take the same example that we just had, all we'd have to do is add one more piece of code and we'd be all good. In this case, we've added an incrementation to our I variable. So what that means is now the I variable will increment by 1 every time the while loop executes. Then at some point it will increment to the number 10, and then the condition will return false because the value is now greater than or equal to 10. And that will signal the end of the while loop. In this demo, we're going to implement a while loop in Java. Specifically, we're going to output the contents of a list to the console without the use of an iterator. To do all that, we're going to piggyback off of our previous demo, which we built in Eclipse. So let's head over to the Eclipse IDE now. Alright, so I already have our project open from the previous demo, but if you don't, go ahead and open it now. And you'll need to access the main class, so you can do that by double-clicking main.java in the Package Explorer panel on the left-hand side of the screen. Okay, so in our last couple of demos, we created some for loops and we iterated over a list of colors that we created in the first demo. The first set of for loops iterated over the list of colors forwards and backwards using an iteration variable and conditions. Our second set of for loops used the enhanced for loop mechanism to iterate over the list first to last. We had to create a second list and reverse it in order to go backwards. In this demo, we're going to try to do the same thing, but using a while loop instead. Okay, so the first thing we're going to want to do is drop down a couple of lines from our last for loop and add a line of code to put a break in the console. So let's type system.out.println, open bracket, double quote, close bracket, and the semicolon. Good. Now we're just about ready to create our while loop. Now, what we want to do is we want to mimic our for loop. So to do that, we need an iteration variable. So let's type the following code on the next line. Int space w space equals space 0 semicolon. Now all we've done here is we've created an integer and set its value to 0. Now this is like the I variable that we created earlier. Now I chose not to call it I because I don't want to collide with my for loops. Anyways, let's finally create a while loop. We can do this by typing the following code on the next line. While, open bracket, W space, less than space colors dot length, close bracket, and then the squiggly brackets. Perfect. So what we've done here is we've created a while loop that loops as long as our W variable is less than the number of colors that we have in our list. Now inside the loop, let's type the following code. System.out.print, open bracket, colors, open square bracket, W, close square bracket, space, plus, space, double quote, space, double quote, close bracket, and of course, the semicolon. Now what this code is doing is it's outputting the value of the colors list at whatever index our variable W is at. Now remember that a while loop is dangerous if we don't make it so that the condition can end up being false. So right now, the W variable will always be less than the length of the colors list. So we need to add an increment before we can call this code done. So let's do that. Now right after the print command, let's add this code. W++ semicolon. Perfect. Now let's see this code in action. Let's save the file with a Control S and run the project with a Control F11. Awesome. Now we're seeing our list of colors in the console at the bottom of the screen, and it's in the correct order. That's great. Okay, but what if we wanted to output the list in reverse order like we did with our previous for loops? Well, let's do it. First, let's make sure that the console sees this on a new line, so let's add the following code directly after our while loop. System.out.println, open bracket, double quote, close bracket, semicolon. Good. Now let's also reset our W variable. Let's type the following code on the next line. W space equals space colors dot length, semicolon. Nice. Now what we've done here is we've set the W variable to be equal to the size of our color list. Now let's add another while loop. Now let's type the following code on the next line. While, open bracket, W greater than 0, close bracket, and then the squiggly brackets. Perfect. Now what this code is doing is it's saying that we're going to execute anything that's inside this while loop as long as the W variable is greater than 0. So let's output the colors to the console. Inside the new while loop, let's type the following code. System.out.print, open bracket, colors, square bracket, W, space, minus, space 1, close square bracket, space, plus, space, double quote, space, double quote, close bracket, and of course our semicolon. Now this code is outputting the color to the console just like our last loop. But the difference here is that we have added a -1 to the indexer. And again, the reason for that is because indexes in Java are all 0-based. So when we set the W variable to the size of our color list, we're actually setting it to 6, the size of the list. And that's not a real index. The 6th item is actually at index 5. So that's why we have to subtract 1. But remember again, a while loop is dangerous if we don't make it so the condition can end up being false. And right now, the W variable will always be greater than 0. So we need to add a decrement before we can call this code done. So let's do that. Now right after the print command, let's add this code. W semicolon. Perfect. Now let's see this code in action. Let's save the file and run the project. Nice! Now we're seeing the list of colors, and we're seeing it in reverse order. Great job! Now in Java, there's the option to use another kind of while loop as well. It's called the do while loop. It's virtually identical to the while loop, but it has one crucial difference. The difference between a while loop and a do while loop is that the condition that decides whether to continue the iteration is tested outside the code, or more accurately, it's tested after the first iteration. Crucially, that means that a do while loop is always executed at least once. So why use a do-while loop instead of a while loop? Well, you would want to use a do-while loop in situations where single execution is needed, and then you can decide on looping thereafter. So a common scenario is when you want to implement a retry. So imagine you want to connect to something like, say, a database. Now you could put that in a do-while loop, and if the connection is successful on the first try, well then it's done. But if the connection attempt fails, you may want to try again and again until it does work. Now, to illustrate how a do-while loop works, consider this flowchart. In Java, when the do-while loop is encountered, it sort of ignores the statement. Instead, the first thing that happens is that the code statements inside the loop are all executed, based on whatever logic is coded. Then, once the code has been executed, that's when the condition is evaluated. If the condition is true, then the loop runs again. If the condition is false, then the loop terminates. Importantly, that means that the loop will run at least once. So, how do we build a do-while loop? How can we make that work? Well, first let's take a look at what the syntax of a do-while loop looks like. Now what you see here is how the code for a do-while loop is laid out. First, we tell Java that we're executing a do-while loop by typing the word do. Then, just like other loops that we've had so far, you add squiggly brackets and then put whatever code you want to loop over inside those brackets. Now it's important to note that with a do-while loop, you must always have the squiggly brackets. Then, finally, after the closing squiggly bracket, we add the keyword while. Then we can finally add a condition inside the round brackets after the while keyword. Now, just like a regular while loop, the conditions of a do-while loop are actually just a single statement. You may have multiple conditions in that statement, this and that, or this or that, but the important part is that the totality of the conditions need to return true or false, and I'll show you how that works in a second. Now finally, and most importantly, the do-while loop is terminated with a semicolon. So let's go over a few examples to see this in action. Now before we get too deep into do-while loops, it's important that we explain one of the real dangers of a do-while loop. In fact, it's the same danger that we have with a regular while loop. To illustrate, consider this example. In this code snippet, we create a variable called I, and then we set its value to 0. Then we create a do-while loop, and we set the condition so that this will execute for as long as the I variable is less than 10. Now inside the loop, we simply output the value of the I variable to the console, and that seems pretty normal too, doesn't it? But again, there's just one problem. The I variable is never incremented. So again, why is this a problem? Well, it means that the I variable is set to 0 and never ever changes. So that means that it's always less than 10. And that means that the do-while loop will execute forever. And that's dangerous. If a do-while loop executes forever, then that's called an infinite loop. Now, infinite loops are dangerous to the systems that they run on because they'll continuously take up compute power or even memory. If left unchecked, an infinite loop can starve your system of needed resources and eventually result in system crashes, and nobody wants that. So what you want to do with a do-while loop is be very careful to make sure that there's a clear condition under which it will end. In fact, if we take the same example that we just had, all we'd have to do is add one more piece of code, and then we'd be all good. In this case, we've added the incrementation to our I variable with an I++. So what that means is that now the I variable will increment by 1 every time the do-while loop executes. Then, at some point, it will increment to the number 10, and the condition will return false. And that will signal the end of the do-while loop. In this demo, we're going to implement a do-while loop in Java. Specifically, we're going to output the contents of a list to the console without the use of an iterator. To do all that, we're going to piggyback off our previous demo, which we built in Eclipse. So let's head over to the Eclipse IDE now. Alright, so I already have our project open from the previous demo, and if you don't, go ahead and open the project now. And of course, we're going to need access to our main class, so make sure you open that by double-clicking on the main.java file in the Package Explorer panel on the left-hand side of the screen. Okay, so in our last few demos, we created some for loops and while loops to iterate over a list of colors to the console both forwards and backwards. The for loops used iteration techniques as well as an enhanced mechanism meant for lists. Meanwhile, our while loops mimicked the for loop strategy by creating an iterator variable too. Now in this demo, we're going to do the same thing again, but this time we're going to use a do while loop instead. Okay, so the first thing we're going to want to do is drop down a couple of lines of code from our last while loop and add a line of code to put a break in the console. So let's type system.out.println, open bracket, double quote, close bracket, and semicolon. Now we're just about ready to create our do while loop. Now what we want to do is mimic the loops that we've created so far. So to do that, we need an iteration variable. So let's type the following code. Int space dw space equals space 0 semicolon. Now all we've done here is create an integer variable and set its value to 0. Now this is like the I and w variables that we created earlier, and I chose not to call it I or w because I don't want to collide with my existing loops. Anyway, let's finally create a do while loop. Now we can do that by typing the following code on the next line. Do, and then squiggly brackets. Perfect. So what we've done here is we've created the start of a do while loop. But you can see that Java doesn't like it yet. That's because we haven't given it a condition. Now to do that, we need to type the following code right after the closing squiggly bracket. While, open bracket, dw, space less than symbol, space colors dot length, close bracket, and a semicolon. Now pay special attention to that semicolon. Unlike our other loops, a do while loop needs that semicolon to say that it's fully defined. Anyway, so what we've done here is we've defined a loop that will iterate for as long as our dw variable is less than the number of colors that we have in our list. Now inside the loop, let's type the following code. System.out.print, open bracket, colors, square bracket, dw, close square bracket, space, plus, space, double quote, space, double quote, end bracket, and of course, a semicolon. Now what this code is doing is it's outputting the value of the colors list at whatever index our variable dw is at. Now remember, a do while loop is dangerous in the same way as a while loop. If we don't make it so the condition can end up being false, we could end up with an infinite loop. Now right now, the dw variable will always be less than the length of colors, so we need to add an increment before we can call this code done. So let's do that. Now right after the print command, let's add the following code. dw ++ semicolon. Perfect. Now let's see this code in action, shall we? Let's save the file with a Control S, and then run the project with a Control F11. Awesome! Now we're seeing our list of colors in the console at the very bottom of the screen, and that's great. Okay, but what if we wanted to output the list in reverse order, just like we did with our previous loops? Well, let's do it. First, let's make sure the console sees this on a new line, so let's add the following code directly after our do while loop. System.out.println, open bracket, double quote, close bracket, semicolon. Good. Now let's reset our dw variable. On the next line, let's type the following code. dw space equals space colors dot length, semicolon. Nice. Now what we've done there is we've set the dw variable to be equal to the size of our color list. Now let's add another do while loop. And once again, let's type the following code, do, and then squiggly brackets. Good. Now, just like last time, let's add a condition right after the final squiggly bracket. Let's add the following code. While, open bracket, dw, space greater than symbol, space 0. And then close bracket, and the semicolon. And once again, don't forget that semicolon. All right. Now what this code is saying is that we're going to execute anything that's inside this do while loop as long as the dw variable is greater than 0. So let's output the colors to the screen. Inside the new do while loop, let's type the following code. System.out.print, open bracket, colors, open square bracket, dw, space minus, space 1, close square bracket, space, plus, space, double quote, close bracket, and the semicolon. Now this code is outputting the color to the console just like our last loop. And the difference here is that we've added a -1 to the indexer. And again, the reason for that is because indexes in Java are all zero-based. So when we set the DW variable to the size of our list, we're actually setting it to 6, which is the size of the list, but that's not a real index. The 6th item in the list is actually at index 5. So that's why we have to subtract 1. Now again, remember, a do-while loop is dangerous if we don't make it so the condition can end up being false, and right now the DW variable will always be greater than 0. So we need to add a decrement before we can call this code complete. So let's do that. Right after the print command, let's add the following code. DW semicolon. Alright, let's see this code in action. Let's save the file and run the project. Nice! Now we're seeing our list of colors in reverse order. Nice job! Okay, let's do one more thing, just to show how while loops and do-while loops are different. The main difference between a while loop and a do-while loop is that a do-while loop always executes once and then checks the condition. To prove that, in our last while loop, let's change the condition from w greater than 0 to w greater than 100. Now remember that with a while loop, the condition is evaluated and the loop terminates as soon as it's false. Now importantly, the condition is evaluated first. So what we've done here is we said that the while loop is allowed to execute as long as the w variable is greater than 100, which it isn't. So the result will be false. So let's see what happens when we execute this. Nice! Now we suddenly have a blank line in the console output, and that shows that that while loop never executed. Meanwhile, let's do the same thing with our last do-while loop. Let's change the condition from dw is greater than 0 to dw is greater than 100. Now just like the while loop, if that condition is false, which it will be now, the loop will terminate. The difference is that with a do-while loop, the condition is evaluated after the loop is run the first time. So let's see what happens when we execute this. Nice! Now we didn't get a blank line, we just got the value orange, and that's because the loop executed once and got the last value in the array, because we're going over it backwards, and output it to the console. Then it checked the condition, and then it stopped running. Great job! When it comes to programming, using a loop is basically inevitable. Be it the for loop, the while loop, the do-while loop, or even the enhanced for loop, you're going to want to make sure that you implement best practices into your loop. One of the most important best practices is to create loops in the most compact way possible. You want to keep your code clean. Now in my day, I've seen tons of loops that contain additional condition statements, method calls, and even nested loops. And that never ends well. The complexity is super high, and it's extremely difficult to manage and maintain. The other thing you're going to want to consider is performance. Now remember that the whole point of a loop is to run a certain block of code multiple times. And with loops, those loops are generally synchronous, meaning that they execute one after the other. So if you have a complex or long-running piece of code inside a loop, the performance of your application may be well below where you want it to be. So for example, if you need a connection to something and it takes a long time or lots of memory to establish that connection, consider establishing that connection outside the loop and then just using the reference inside your loop. And the final best practice is to watch the number of variables that you're creating and using inside the loop. Now each iteration of a loop is like its own method call and has its own memory space. So if you create variables inside your loop, that's fine. But just remember that you'll be creating those variables every time the loop iterates. So again, if you have an object that takes lots of memory and you create it with every iteration, you can find yourself using a lot of memory very, very quickly. And it doesn't have to be a big object either. I once had a colleague create a single character in each iteration of a loop. And the loop ran so many times that the system ran out of memory, with just a single character. So watch your variable usage. Now, probably the most common type of loop is the for loop, but it's worth having a few considerations before deciding whether a for loop is the right type of loop for the code that you want to write. Now first, it's important to understand that a for loop is most useful when counting is straightforward. Remember that with a for loop, the idea is that you start at a certain index, usually 0, and you count up or down to another value. The loop terminates when you reach your target count. Now what that means is that a for loop requires upfront knowledge of how many iterations you're going to want to do. And that's why the most common implementation for a for loop is to start at 0, count upwards by 1 until you reach the size of a given list. If you don't know how many iterations you need to do, then the for loop is probably not a good choice. And that's where the while loop comes in. You should consider using a while loop when you don't exactly know how many iterations you need to make. That strategy eliminates the limitations of a for loop. So imagine that you had a program that took any arbitrary number from a user and you wanted to see how many times you could divide that number by 2 until you got a value that was less than 1. In that scenario, you could be running the loop any number of times, right? Well, you couldn't do that with a for loop, so your best bet is to use a while loop. Now you can still treat while loops in the same count-based iteration strategy as a for loop. You just have to code the iteration inside the loop, rather than its definition. So it will still easily permit iterations of collections. Now, there's an additional kind of advanced and embedded looping strategy that you can use, and that's a for each loop with lambda expressions associated with list objects. The idea behind the for each loop is that all list objects include a for each method, and if you call that method, you can provide a lambda expression, which is like an inline method, and that code will be executed against everything you have in the list object. It's super handy and worth reading about, but it's also a little bit more advanced. Now, the benefits of the for each loop is that it fully encapsulates the iteration. In other words, there's no need to create any code for iteration. You don't need to specify iterators or conditions. It will simply call your code for each item that you have in your list. Now, the code that you can create for each iteration operation is contained in what's called a lambda expression. Lambda is very powerful and definitely something I recommend looking into. It can greatly shrink and simplify your code, but watch out! It can also lead to code that looks like it's small and useful, but actually ends up being very detrimental to your overall performance. But that's okay, because while the for each loop is handy, there's a nice middle ground, and that's the enhanced for loop strategy. The enhanced for loop strategy is much more convenient than a regular for loop. Rather than providing an iterator, a condition, and an incrementation strategy, all you have to do is provide a list that you want to iterate over. Now that sounds an awful lot like the for each loop, doesn't it? Well, that's because it is actually almost identical. While a for each loop requires a list object, an enhanced for loop can be used against any type of list or an array. Now the code for enhanced for loops is nice and clean too. It's not as condensed as a for each loop, but it's pretty close. Now the main idea of an enhanced for loop is effectively to take the concept of a common for loop implementation and then put all of the iteration and condition work in the background. Sometimes with loops, you want to have some extra control in how they're executing. Well, with Java, there are two types of statements that you can execute that will impact how or even if a loop executes. Those statements are break and continue. So let's go over these in a bit more detail. First, we have break statements. Now, the purpose of a break statement is to immediately terminate a loop. Imagine a scenario where you have a list of items and you're trying to find whether or not something exists in that list. So you start iterating over the list and halfway through you find the item. Now you don't want to continue processing the entire list, do you? I mean, you've already found the item. So what you can do is use the break statement to terminate the loop once you've found the item you're looking for. Now, when the break statement is executed, it ends the loop and sends the program to the next line of code after the loop for execution. Now, to illustrate a break statement, consider this flowchart. Java encounters a loop and begins executing the code statements in that loop.
Now, per usual, the loop has a set of conditions that control the loop. If the condition is true, the loop will continue. But if the condition is false, the loop terminates. Well, one of the code statements inside the loop can bypass that entire process. If the break statement is called, Java will immediately terminate the loop and bypass any of the other code or condition checks that might be defined. So let's go over an example that shows the break statement in action. In this code snippet, we create an array of strings called colorList. Inside is a set of colors: red, green, blue, yellow, and orange. Now, after the array definition, we use an enhanced for loop to iterate over all the colors in the list. Now, during each iteration, the current color from the list is put in the variable named color. Now, inside the loop, there's a simple if condition. It checks to see if the current color being processed is equal to the value yellow. And if it is, then a break statement is called and the loop will immediately terminate. If it isn't, the loop continues on. Now, after the if condition, there's a simple print line command that outputs the current color to the console. So what happens with this code is that it iterates over each color, but stops if it sees the color yellow. And that means the output would be red, green, and blue. Yellow would kill the loop, and so we'd never see it or orange. Now, another loop controlling statement in Java is the continue statement. The purpose of the continue statement is to skip a single iteration. So imagine a scenario where you're processing some items in a list and you realize that an item in the list is not worth being processed. Now, in that situation, you could call the continue keyword, and that would immediately end the current iteration of the loop and send the loop to the next iteration. Now, the important difference between the break and continue statements is that a break statement kills the whole loop, but the continue statement resumes loop processing just at the next iteration. So, to illustrate a continue statement, consider this flowchart. Java encounters a loop and begins executing the code statements in that loop. Now, per usual, the code has a set of conditions that control the loop. Now, if the condition is true, the loop will continue. But if the condition is false, the loop terminates. Well, one of the code statements inside the loop can bypass a single iteration. If the continue statement is called, Java will immediately bypass any other code or condition checks that it might have defined for the current iteration and immediately move on to the next iteration of the loop. Now, let's go over an example that shows the continue statement in action. In this code snippet, just like the code we had for the break statement before, we create an array of strings called colorList. Now, inside is a set of colors: red, green, blue, yellow, and orange. Now, after the array definition, we use an enhanced for loop to iterate over all the colors in the list. And during each iteration of the list, the current color from the list is put into the variable named color. Now, inside the loop, there's another simple if condition. It checks to see if the current color being processed is equal to the value yellow. Now, if it is, then a continue statement is called, and the loop will immediately move on to the next iteration of the loop. If it isn't yellow, then the rest of the statements in the loop are run. Now, after the if condition, there's a simple print line command that outputs the current color to the console. So what happens with this code is that it iterates over each color, but effectively skips a beat if it sees the color yellow. And that means that the output would be red, green, blue, and orange. Yellow would not be seen because that iteration of the loop was skipped. And orange is seen because we didn't break out of the loop completely. We just skipped to the next iteration. In this demo, we're going to work through an example of a break statement and another example of a continue statement in Java. To do that, we're going to use the break statement while performing a search for a value in an array, and then we're going to use the continue statement to skip unwanted values in an array. Now, to do all that, we're going to piggyback off our previous demo which we built in Eclipse, so let's head over to the IDE now. Alright, so I already have our project open from the previous demo, but if you don't, go ahead and open the project now. Alright, so we're going to be using our main class, and we can access it by double-clicking on the main.java file in the Package Explorer panel on the left-hand side of the screen, and I've already got mine open. Okay, so in all of our demos so far, we created some loops that iterated over some values in an array that we created during our very first demo. Some loops went through the array forwards and some went backwards, but all the loops iterated through all of the items in the list. In this demo, we're going to iterate over items in the list again, but we're going to break out of our loops or skip certain items when we do it. So let's get started. Okay, so the first thing we're going to want to do is drop down a couple of lines from our last do-while loop and add a line of code to put a break in the console. So let's type system.out.println, open bracket, double quote, close bracket, and a semicolon. Good. Now let's start by creating a for loop. Let's type the following code on the next line. For, open bracket, int, space I, space equals, space 0, semicolon, space I, space less than, space colors, dot length, semicolon, I, plus plus, close bracket, and then the squiggly brackets. Excellent. Now you'll recognize that what this for loop is doing is iterating for as many times as there are items in our list of colors. So what we want to do now is check to see if a particular color exists in our list. So let's add a simple if statement inside the loop. Let's type the following code. If, open bracket, colors, open square bracket I, close square bracket, space equals, space double quote green, double quote close bracket, and then squiggly brackets. Now what this condition is doing is it's asking if the color value in the loop's current index is green. If it is, then the code inside the if statement will be executed. So let's add some code inside the if statement. Let's add system.out.print, open bracket, double quote, found, double quote, close bracket, and the semicolon. Perfect. Now if the value of green is anywhere inside the list, we'll see the text found output to the console. But we're not quite done yet. Let's add another line of code after the if statement. So in the line after the if statement's closing squiggly bracket, let's add this code. System.out.print, open bracket, I, close bracket, and the semicolon. Now all this code is doing is it's outputting the current index to the console. So the way this code works is that the index value will always be printed to the console, and the found text will only be output if the value of green is found in the list. So let's execute this code and see what happens. We can do that by saving the file with a Control S and running the project with a Control F11. Excellent! So we can see in our console output at the bottom of the screen that indexes 0, 1, and 2 were output, followed by the word found, and then indexes 3, 4, and 5. And that means that the color green was found and it was at index 3. Of course, we already knew it would be found in that list, and we already know it's at index 3. Now the important part of what we're seeing here is that even though the color green was found in the list at index 3, the rest of the array was still scanned. And that's wasted processing because we already found what we were looking for. So what we want to do instead is tell Java to terminate the loop if we found what we wanted. So let's do that. Now inside the if statement, but after our print command, let's add the following code. Break, semicolon. Good. Now let's save and run this. Hey, nice! This time we still got the text found, but we can see that we didn't see any more indexes output to the screen. And that shows that Java terminated the loop right when we told it to. Excellent! Now let's explore the continue statement. Let's drop down another line after our latest for loop and add a print line command one last time. System.out.println, open bracket, double quote, close bracket, semicolon. Good. And now let's create another for loop exactly like the one that we just created. For, open bracket, int, space I, space equals, space 0, semicolon, space colors dot length, semicolon, space I plus plus, close bracket, and the squiggly brackets. Good. Now let's add the same if statement that checks for the color green. If, open bracket, colors, square bracket I, close square bracket, space, equals, space, double quote, green, double quote, close bracket, and then the squiggly brackets. Now, once again, let's add a console output inside that if statement. System.out.print, open bracket, double quote, found, double quote, close bracket, and of course our semicolon. And finally, let's output the color at our current index after the if statement. So let's type system.out.print, open bracket, colors, square bracket, I, close square bracket, space plus space, double quote, space, double quote, close bracket, and of course the semicolon. Excellent. Now if we save and run this, we'll get all the colors in our list output to the console just like we've seen in the past. The difference will be that we'll also get the word found whenever the color green is found. In fact, let's run and see this. Hey, and there it is, blue, white, red, found green, yellow, and orange. So just like last time, the important part of what we're seeing here is that every index is being processed, and that means that every color is being displayed in the console. But what if we really despise the color green, and we want to skip processing it altogether? Well, that's where the continue statement comes in. So let's replace our found print statement with just the following code. Continue, semicolon. Now what this code does is that any time the color at the current index is equal to green, the loop will immediately skip to the next iteration. In fact, let's run the code and see what we get. Hey, perfect! So now we're seeing all the colors output to the screen except the color green. So you can see it didn't stop, it kept going, and that's why we get the color orange. Great job! So in this course, we've examined various methods for performing looping in the Java programming language. We did this by exploring types of Java looping statements, programming for loops, enhanced for loops, while and do-while loops, Java looping best practices, and programming Java break and continue statements. In our next course, we'll move on to explore how to handle exceptions and how to debug your Java code.